everyone and welcome to this full course on Azure DevOps. Azure DevOps is a powerful platform that helps teams plan, build, test, and deploy applications faster and more reliably. This Azure DevOps full course is designed to take you from the basics of DevOps and cloud computing to building complete CI/CD pipelines using Microsoft Azure. In this course, you will learn how Azure DevOps brings together version control, continuous integration, continuous delivery, testing, and monitoring into a single streamlined workflow. You will explore essential tools and services such as Azure Repos, pipelines, boards, test plans, and artifacts, along with key Azure services used in real-world DevOps projects. And by the end of this course, you will have a strong understanding of how to automate application delivery, manage infrastructure, and collaborate effectively using Azure DevOps. Whether you're a beginner, developer, or IT professional, this course will help you build practical DevOps skills and prepare for real-world projects and Azure DevOps certifications. So before we begin, please like, share, and subscribe to Edureka's YouTube channel and hit the bell icon to stay updated on the latest tech content from Edureka. Also, check out Edureka's DevOps Certification Training course with GenAI. The DevOps training program prepares learners to master AI-driven DevOps across the entire software delivery lifecycle. It focuses on building intelligent, automated, and secure pipelines through hands-on learning. The course covers essential tools like Git, Jenkins, Terraform, Ansible, Docker, Kubernetes, and monitoring, while also integrating AI for code generation, testing, and performance analytics. You will gain real-world experience by designing and deploying scalable, AI-powered CI/CD pipelines, making you ready for next-generation DevOps roles. So check out the course link given in the description box below. Now, let us get started by understanding what Azure DevOps is.
What is DevOps? DevOps is basically a combination of two words, development and operations. So what do we get when we combine these two? Simply speaking, DevOps is a culture that implements technology in order to promote collaboration between development and operations team to deploy code to production faster in an automated and repeatable way. The goal of DevOps is to increase an organization's speed when it comes to delivering applications and services. Many companies have successfully implemented DevOps to enhance their user experience. Let's take for example, Facebook's mobile app, which is updated every 2 weeks, effectively telling users, you can have what you want and you can have it now. Ever wondered how Facebook is able to do this so smoothly? It's the DevOps philosophy that helps Facebook ensure that its apps aren't outdated and that its users get the best experience. Facebook accomplishes this through a code ownership model that makes its developers responsible. That includes testing and supporting through production and delivery for each kernel of code they write and update. It's through policies like this that Facebook has developed a DevOps culture and has successfully accelerated its development lifecycle. Industries have started to gear up for the digital transformation by shifting their needs to weeks and months instead of years while maintaining high quality. As a result, we will soon see that DevOps engineers have more access and control of the end user than any other person in the enterprise. So what are you waiting for? Don't be in the sidelines when that happens. To master your skills, enroll in Edureka's DevOps certification program and become a leader. Until next time, happy learning!
Why do we need DevOps? The birth of DevOps occurred when there were some drawbacks with the existing software development models for application development. The first model we'll be addressing today is the waterfall model. So the waterfall model is a model of software development which is pretty straightforward and linear. So this model follows a top-down approach, as you can see in the image. It has various phases starting with requirements gathering and analysis. So the first phase is where you get the requirements from the client for developing an application. So after this, you try to analyze these requirements that you've acquired. Next comes the design phase where you prepare a blueprint of the software. So in this phase, you think about how the software is actually going to look like. Once the design is ready, you proceed further with the implementation phase where you begin with the coding for the application. So here the team of developers work together on various components of the application. And once the application is developed, it is tested in the verification phase, that is the fourth phase. Here there are various tests conducted on the application such as unit testing, integration testing, performance testing, etc. After all of these tests on the applications are done, it is finally deployed on the production servers. At last, that is the fifth phase, is the maintenance phase. So in this phase, the application is monitored for performance. So any issues related to the performance of the application are resolved in this phase. But unfortunately, this model, that is the waterfall model, has some major drawbacks. So the first drawback is gathering and documenting your requirements each step of the way can be extremely time consuming, not to also mention difficult. It is hard to assume things about your product so early into the project. And because of the same reason, your assumptions might be flawed and different from what the customer expects. The second drawback is that now, if the above case is true, your customers are basically dissatisfied with your delivered product. Adding changes to the product can be expensive and most of all difficult to implement. So the third drawback is that in general, the risk is extremely high with the waterfall approach because the scope for mistakes is extremely high. If things go wrong, fixing them can be hard as you have to go a couple of steps back. The next model is the agile model. So agile is an iterative based software development approach where the software project is broken down into various iterations or sprints. So every iteration has phases like the waterfall model, such as requirements gathering, design, development, testing, and maintenance. You can see each of this iteration in the image. So each of this iteration generally lasts for about 2 to 8 weeks. So the difference between agile and waterfall model is that you release the application with some high priority features in the first iteration. After its release, the end users or the customers can give you feedback about the performance of the application. So the necessary changes are made to the application along with some new features. And once these features are added to this application, it is again released, which is in the second iteration. This procedure is repeated until the desired software quality is finally achieved. Now, in spite of being used often, the agile method has a few disadvantages. The first one is that for the approach to work, all the members of the team must be completely dedicated to the project. That is, everyone must be involved equally if you want the whole team to learn and do better on the next run. And this is mainly because agile focuses on quick delivery. There might be an issue with hitting deadline. The second drawback is that the approach may seem extremely simple, but it is hard to execute. So it requires commitment and for everyone to be on the same page, ideally in the same physical space. The third drawback is that documentation can sometimes be ignored. Because agile methodology focuses on working software over comprehensive documentation, things might sometimes get lost through each stage and iteration. As a result, the final product can feel different from what it was first planned. So these are the few drawbacks that the agile model or the agile methodology gives us. So in delivering valuable software to customers, development and operation teams are always in conflict with each other. While development wants to deliver its changes to customers quickly, operations want stability, which means not changing the production systems too often. So the gap between the development and operations team occurs on three different levels. The first one is the incentives gap. This is because of different goals of development and operations. The second one is the process gap, which is the result from different approaches of development and operations and how to manage changes, bring them to production, and maintain them there. The third one is the tools gap, which results from the fact that development and operations often use their own tools to do their own work. And this is resulting from the fact that development and operations often use their own tools to do their work. As a result, from all of these reasons, development and operations often act like silos, as they are two distinct teams. So the conflict between development and operations is because of two reasons. The first one is need for change. This is because development results in change. That is, they're always working on new features, bug fixes, etc. It wants the change to quickly roll out to production. And the second one is fear of change. Once the software is finally delivered, the operations department avoids making changes to the software to ensure stability. This is the major conflict between both of these teams. So this is where DevOps comes into picture. DevOps links software development to operations. I hope that is clear. That is, DevOps bridges the gap between agile software development and operations experiences. It is important to know that DevOps is a set of principles to break down silos. Specifically, DevOps is all about culture, automation, measurement, and sharing. So the first one is culture. So in culture, people and processes comes first. If you don't have a culture, all automation attempts will be fruitless. The relationship is important in culture because its functions include engage early, engage often, destroy silos, be open to options, and stop blaming. And the second one is automation. So once you understand your culture, you can simply start with automation, right? Now you can finalize various tools to achieve automation for DevOps. That is tools for release management, provisioning, configuration management, systems integration, monitoring and control, and orchestration becomes extremely important pieces for DevOps. The third is measurement. So if you cannot measure, you cannot improve. Makes sense, right? A successful DevOps implementation will always measure everything it can as often as it can. Performance metrics, process metrics, people metrics, capacity planning, trend analysis, fault finding, etc. All of these have to always be measured. So the last one is DevOps is about sharing. Sharing is the loop back in the cycle. So creating a culture where people share ideas and problems is extremely critical. So exposing ideas can create great open feedback that in the end it helps to improve shared ideas, share metrics, give DevOps shell access, see what technology can be leveraged, etc. So DevOps is all about these four particular features. I hope this is clear. So now let's move on to the next part of today's session, that is Introduction to DevOps. So finally, we will address what is DevOps. DevOps is simply a combination of two words. You can see that. One is the software development and the second one is operations. So this allows a single team to handle the entire application lifecycle. That is from development to testing, deployment, and finally operations. So DevOps really helps you to reduce the disconnection between software developers, quality assurance engineers, and system administrators. That is, it basically promotes collaboration between the development and operations team to deploy code to production faster in an automated and repeatable way. So DevOps basically helps to increase organization speed to deliver applications and services. It also allows organizations to serve their customers better and compete more strongly in the market. It can be also defined in another way. That is, it is also a sequence of development and IT operations with better communication and collaboration. So in the market, it has become one of the most valuable business disciplines for enterprises or organizations. With the help of DevOps, the quality and speed of the application delivery has improved to an extremely great extent. Organizations that have adopted DevOps notice a 22% improvement in software quality and a 17% improvement in application deployment frequency. They have also achieved a 22% hike in customer satisfaction. Overall, a 19% of revenue hikes as a result of the successful DevOps implementation has been achieved. Moving on, DevOps workflow is another important concept. So what is a DevOps workflow? So it basically provides a visual overview of the sequence in which input is provided. Also, it tells about which one action is performed and output is generated for an operations process. So basically, DevOps workflow allows the ability to separate and arrange the jobs which are top requested by the users. Also, this workflow gives the ability to mirror their ideal process in the configuration jobs. Moving on, let's see some of the DevOps principles. So the main principles of DevOps are continuous delivery, automation, and fast reaction to the feedback. But there are 6 other principles that we'll be discussing today. The first one is the end-to-end responsibility. So DevOps teams need to provide performance support until they become the end of life. It enhances the responsibility and the quality of the products engineered. The second one is continuous improvement. DevOps culture focuses on continuous improvement to minimize waste. That is, it continuously speeds up the growth of the products or the services that has been offered. The third one is automate everything. Automation is an essential part of the DevOps process. We'll be discussing about this later on in this session. This is for the software development and also for the entire infrastructure landscape. The fourth one is custom-centric action. So the DevOps team must be customer-centric so that they should continuously invest in products and services. The fifth one is monitor and test everything. The DevOps team needs to have robust monitoring and testing procedures. The last one is work as one team. In the DevOps culture, role of the designers, developers, and testers are already defined. So all they need to do is work as one team with complete collaboration. These principles are achieved through several DevOps practices, which include frequent deployments, quality assurance automation, continuous delivery, validating ideas as early as possible, and in-team collaboration. Now let's move on to the third topic of today's session, companies using DevOps. By now, you must have figured out that DevOps helps to increase an organization's speed to deliver applications and services. This is exactly why many organizations such as Amazon, Netflix, Etsy, HP, Adobe, and many other organizations are adopting DevOps and its practices. We will now discuss how Amazon makes use of DevOps to increase their work efficiency. You must be aware that Amazon is one of the biggest e-commerce companies in the world. But way back in time, their website followed a traditional monolithic architecture. So in this type of architecture, all the processes are coupled together and run as a single service. Over time, as the code and the source files grew, it became hard to scale, maintain, and upgrade their applications on physical servers. So what did Amazon do? Amazon simply solved the problem of the monolithic architecture by moving from physical servers to cloud-based Amazon Web Services. You all must have heard of AWS. Currently, AWS follows a microservice architecture. In Amazon, there are basically three types of microservices. They are users, threads, and posts. Developers here apply frequent but small changes over their code via version control tools like Git and GitHub. Practices like code deployment help fix bugs and adds new features to improve the underlying software application. AWS Code Deploy is one such service that keeps track of deployments and simplifies the entire software release process. Amazon also uses Apollo. Apollo is a simple one-click internal deployment tool. So Apollo's job is to deploy a specified set of software across a group of hosts. On the other hand, practices like configuration management and infrastructure as code help to monitor and make changes in the software. It keeps track of the system's performance and resources used by developers. So in this way, the testing team can identify problems way before in hand and fix them immediately. So this is how Amazon implement DevOps and its practices. Now let's move on and understand one major concept of DevOps, that is the DevOps lifecycle. So if you're into DevOps from quite some time now, you must have heard at least one of these DevOps phases, that is continuous development, continuous integration, continuous testing, continuous deployment, and continuous monitoring. So all of these phases that I just mentioned make up the DevOps lifecycle. As you can see on the screen, and as I've already mentioned, all of these phases make up the DevOps lifecycle. The first phase is the continuous development phase. So this is the phase that involves planning and coding of the software. So the vision of the project is decided during the planning phase, and the developers begin developing the code for the application. There are no DevOps tools that are required for planning, but there are a number of tools for maintaining the code. The code can be written in any language, but it is mainly maintained by using version control tools. So here, maintaining the code is referred to as source code management. So some of the most popular version control tools are Git, SVN, Mercurial, CVS, etc. Also, tools like Ant, Maven, Gradle can be used in this phase for building or packaging the code into an executable file that can eventually be forwarded to any of the next phases. The next phase in the DevOps lifecycle is continuous testing. So this is the stage where the developed software is continuously tested for bugs. For continuous testing, automation testing tools like Selenium, TestNG, JUnit, etc. are used. So basically the tools that I just mentioned right now allow quality assurances to test multiple code bases thoroughly in parallel to ensure there are no flaws in the functionality. So what automation testing does is it saves a lot of time, effort, and labor for executing the test instead of doing this manually, right? Also in this phase, Docker containers can be used for simulating the test environment. Selenium here does the automation testing, and the repos are generated by TestNG. So this entire testing phase can be automated with the help of a continuous integration tool called Jenkins. We'll talk about Jenkins later on in this session. So now let me explain you this with an example. Suppose you've written a Selenium code in Java to test your application. Now what you can do is you can build this code using Ant or Maven, and once the code is built, it is tested for user acceptance testing. So this entire process can be automated using Jenkins. Besides that, the report generation is a very big plus point. The task of evaluating the test cases that failed in a test suite gets simpler. We can also schedule the execution of test cases at predefined times. Once the entire testing is done, the code is continuously integrated with the existing code. The third phase of this life cycle is continuous integration. So now this stage is the heart of the entire DevOps lifecycle. It is a software development practice in which the developers require to commit changes to the source code more frequently. This may be on a daily or a weekly basis. So every commit is then built, and this allows early detection of problems if they are present. Building code does not involve compilation, but it also includes code review, unit testing, integration testing, and packaging. The code that is supporting new functionality is continuously integrated with the existing code. Since there is continuous development of software, the updated code needs to be integrated continuously as well as smoothly with the systems to reflect changes to the end users. As I've already said in the previous slide, Jenkins is a very popular tool used in this phase. So whenever there is a change in the Git repository, Jenkins simply fetches the updated code and it prepares a build of that code, which is in an executable file. So once this entire build is performed, it is then forwarded to the test server or the production server. Now let's move on to the fourth phase of the cycle, that is the continuous deployment phase. So this is the stage where the code is deployed to the production servers. It is very important to ensure that the code is correctly deployed on all the servers. Now before moving on, let us understand a few things about configuration management and containerization tools. Now these set of tools help in achieving continuous deployment. Firstly, I will talk about configuration management. It is basically the act of establishing and maintaining consistency in an application's functional requirements and performance. So let me put this in simple words. It is the act of releasing deployments to servers, scheduling updates, and most importantly, keeping the configurations consistent across all the servers. Since the new code is deployed on a continuous basis, configuration management tools play an extremely important role in executing tasks quickly and frequently. Now, some popular tools that are used here are Puppet, Chef, SaltStack, and Ansible. Containerization tools also play an equally important role in the deployment stage. Docker is one of the most popular tools used for this purpose. Basically, these tools help produce consistency across development, test, staging, and production environments. Besides this, they also help in scaling up and scaling down of instances very swiftly. Basically, containerization tools help in maintaining consistency across the environments where the application is deployed, developed, and tested. Using these tools, there is no scope of errors or failures in the production environment as they package and replicate the same dependencies and packages used in the development or testing or staging environment. Basically, it makes your application easy to run on different computers. The next stage is the continuous monitoring stage. This is the last stage in the DevOps lifecycle. This is a very crucial stage where you continuously monitor the performance of your application. So here, vital information about the use of the software is recorded. This information is processed to recognize the proper functionality of the application. The system errors such as low memory, server not reachable, etc. are resolved in this phase. The root cause of any issue is determined in this phase. It also maintains security and availability of the services. Also, if there are any network issues, they are resolved in this phase. That is, it helps us automatically fix the problem as soon as they're detected. So now this practice involves the participation of the operations team who will monitor the user activity for bugs or any improper behavior of the system. The most popular tools used for this phase is Splunk, ELK Stack, Nagios, New Relic, and Sensui. So what these tools do is they help you monitor the application's performance and the servers very closely, and they also eventually enable you to check the health of the system proactively. Now, using these tools, they can also improve productivity and increase the reliability of the systems, which in turn reduces IT support costs. Any major issues, if found, are reported to the development team so that it can be fixed in the continuous development phase. This also leads to a faster resolution of the problems. The stages are carried out on loop continuously till you achieve the desired product quality. Therefore, almost all of the major IT companies have shifted to DevOps for building their products. Moving on, if you want to become a DevOps engineer or be a part of this ideology, it is extremely important for you to be familiar with some DevOps related tools. Today, I will be talking about 7 important DevOps tools. Now, before we understand the tools DevOps engineers use, it is important to understand containers. So, what are containers? Containers allow you to package your application and its dependencies together into one manifest that can be version controlled, allowing for easy replication of your application across developers on your team and machines in your cluster. This is exactly why container-based microservices architectures have profoundly changed the way development and operation teams test and deploy software. Containers really help companies modernize by making it easier to scale and deploy applications. But they have also introduced new challenges and complexity by creating an entirely new infrastructure ecosystem. IT companies are now deploying thousands of container instances daily, and that's a complexity of scale they have to manage. How do they do it? Here is where Kubernetes comes to the rescue. Kubernetes is a container management technology developed in Google to manage containerized applications in different kinds of environments, like physical, virtual, cloud infrastructure, etc. So it really is just an open source system which helps in creating and managing containerization of applications. Its container management responsibilities include container deployment, scaling and descaling of containers, and container load balancing. It is extremely important to remember that Kubernetes is not a containerization platform, it is a multi-container management solution. Now let's move on and discuss some of the features of Kubernetes. The first one is automated scheduling. So Kubernetes provides an advanced scheduler to launch containers on cluster nodes based on their resource requirements and other constraints, while not sacrificing availability. The second feature is self-healing capabilities. So Kubernetes allows you to replace and reschedule containers when nodes die. It also kills containers that do not respond to user-defined health checks and does not advertise them to clients until they are ready to serve. The third feature is automated rollouts and rollback. So what Kubernetes does is it rolls out changes to the application or its configuration while monitoring your application health to ensure it does not kill all your instances at the same time. So if something goes wrong with Kubernetes, you can simply roll back the change. The fourth feature is horizontal scaling and load balancing. Kubernetes can scale up and scale down the application as per the requirements with a simple command, using a user interface or automatically based on CPU usage. Now let us understand the architecture. The Kubernetes architecture has two main components. The first one is the master node, the second one is the worker node. So the master node is responsible for the management of Kubernetes cluster. It is mainly the entry point for all administrative tasks. There can always be more than one master node in the cluster to check for fault tolerance. So there are few components in the master node that I'd like to discuss. The first one is the API server. So here the API server is the entry point for all the REST commands used to control the cluster. The second one is the controller manager. It is a daemon that regulates the Kubernetes cluster and manages different non-terminating control loops. The third one is the scheduler. So the scheduler schedules the tasks to worker nodes. So what it really does is it stores the resource usage information for each worker node. The fourth one is the etcd. So the etcd is simple distributed consistent key value store. So what it mainly is used for is to share configuration and service discovery. Now that we know how the master nodes work, let's move on to the worker nodes. So these worker nodes contain all the necessary services to manage the networking between the containers, communicate with the master node, and assign resources to the scheduled containers. So the first component that I'll be talking about in this worker node is the Docker container. So Docker runs on each of the worker nodes and runs the configured pods. The second one is the kubelet. The kubelet gets the configuration of a pod from the API server and ensures that the described containers are up and running. The third one is kube proxy. So kube proxy acts as a network proxy and a load balancer for a service on a single worker node. The fourth one is pods. So a pod is one or more containers that logically run together on nodes. With this, we come to the end of the first tool in DevOps tool. Let's move on to the second tool, that is Docker. So what is a Docker? Docker is simply a containerization platform that packages your application and all its dependencies together in the form of containers to ensure that your application works seamlessly in any environment. So each application here will run on a separate container and will have its own set of libraries and dependencies. It must be really convenient to move around these containers, right? So containers also ensures that there is a process level isolation, meaning each application is independent of other applications, giving developers surety that they can build applications that will not interfere with one another. Now, the quality assurance team need not install all the dependent software and applications to test the code, and this helps them save lots and lots of time and energy. This also ensures that the working environment is consistent across all the individuals involved in the process, starting from development to deployment. So here the number of systems can be scaled up easily and the code can be deployed on them effortlessly. There are some basic concepts of Docker you must be aware of. That is Docker file, Docker image, and Docker container. So a Docker image is created by the sequence of commands written in a file called Docker file. When this Docker file is executed using a Docker command, it results into a Docker image with a name. So finally, when this image is executed by Docker run command, it will by itself start whatever application or service it must start on its execution. So I hope Docker file, Docker images, and Docker containers are clear. We'll understand what is Docker Hub now. So Docker Hub is basically a cloud registry where you can find Docker images uploaded by different communities. Also, you can develop your own image and upload on Docker Hub, but first you need to create an account at Docker Hub. So let's move on and understand what a Docker engine is. So the Docker engine is the heart of the system. It is simply the application that is installed on your host machine. Basically, it works like a client-server application. It uses a server, which is a type of a long-running program called a daemon process. It also uses a command line interface client. And finally, it uses an REST API, which is used for communication between the CLI client and Docker daemon. As per the image, in a Linux operating system, there is a client which can be accessed from the terminal and a host which runs the daemon. We build our images and run containers by passing commands from the CLI client to the daemon. However, in the case of Windows or Mac, there is an additional toolbox component inside the Docker host. So this Docker toolbox is an installer to quickly and easily install and set up a Docker environment on your Windows or your MacBook. So this toolbox installs Docker client, machine, Compose, which is only present in Mac, and VirtualBox. With this, we come to the end of Docker. We'll move on to the third tool of DevOps tools, that is Git. So Git is an extremely important tool for software developers. It is a free open source distributed version control system designed to handle everything from small to very large projects with speed and efficiency. It was created by Linus Torvalds in 2005 to develop Linux kernel. Git has the functionality, performance, security, and flexibility that most teams and individual developers need. It also serves as an important distributed version control DevOps tool. So Git is primarily used to manage a project comprising a set of code or text files that may change over time. Now, before we go further, let us take a step back to learn about version control systems and how Git came into existence. So version control is the management of changes to documents, computer programs, large websites, and other collection of information. There are basically two types of version control systems. The first one being centralized version control system. The second one is distributed version control system. So Git is a distributed version control system where every contributor, that is the user, has a local copy or clone of the main repository. What is a repository? A repository is simply a storage space for your project files. Here, everyone maintains a local repository of their own which contains all the files and metadata present in the main repository. So the local repository is usually on the local machine of the user. So every programmer maintains a local repository, which is actually the copy or clone of the central repository on their hard drive. The central repository may be present on a web hosting platform like GitHub. They can commit and update the local repository without any interference. They can also update their local repositories with new data from the central server by an operation called pull and affect changes to the main repository by an operation called push from the local repository. So I hope everyone understood how Git works. Now moving on, let us understand the role of Git in DevOps. So Git plays a very vital role when it comes to managing the code that the collaborators contribute to the shared repository. So this code is then extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to the production. Tools like Git enable communication between the development and the operations team. When you're developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators while making changes within the project. Commit messages in Git play a very important role in communicating among the team. The bits and pieces that we all deploy lies in the version control system like Git. To succeed in DevOps, you need to have all of the communication in version control. Hence, Git plays a very vital role in succeeding at DevOps. Now let's move on to the next tool, that is Selenium. Selenium is one of the most widely used open source web user interface automation testing suite. It was originally developed by Jason Huggins in 2004 as an internal tool at ThoughtWorks. So Selenium supports automation across different browsers, platforms, and programming languages. So this tool can be easily deployed on platforms such as Windows, Linux, Solaris, and Macintosh. Moreover, it supports operating systems for mobile applications like Windows and Android. Selenium supports a wide variety of programming languages through the use of drivers specific to each language. Languages supported by Selenium include C#, Java, Perl, PHP, Python, and Ruby. Currently, Selenium WebDriver is the most popular with Java and C#. Selenium test scripts can be coded in any of the supported programming languages and can be run directly in most modern web browsers. Browsers supported by Selenium include Internet Explorer, Mozilla Firefox, Google Chrome, and Safari. So basically, it can be used to automate functional tests and can be integrated with automation test tools such as Maven, Jenkins, and Docker to achieve continuous testing. It can be also integrated with tools such as TestNG and JUnit for managing test cases and generating reports. So now moving on, what are the advantages of Selenium? Why should we choose Selenium? Since Selenium is open source, there is no licensing cost involved, which is a major advantage over other testing tools. There are many other reasons behind Selenium's ever-growing popularity. The first one is that test scripts can be written in any of the programming languages, that is Java, Python, C#, PHP, Ruby, Perl, .NET, etc. Tests can also be carried out in any of the operating systems, that is Windows, Mac, or Linux. Tests can also be carried out using any browser, that is Mozilla Firefox, Internet Explorer, Google Chrome, Safari, Opera. We've all discussed this in the previous slide. And the last use is that it can be integrated with Maven, Jenkins, and Docker to achieve continuous testing. So in short, Selenium can be used for automated testing. Also, because it has cross-browsers compatibility, it is more preferred. And it also increases test coverage and reduces test execution time. Now moving on, let us understand an important concept in Selenium, that is the Selenium Grid. Selenium Grid was developed by Patrick Lightbody and initially called it Hosted QA. It was used in a combination with remote control to run tests on remote machines. In fact, with Grid, multiple test scripts can be executed at the same time on multiple machines. Parallel execution is achieved with the help of hub node architecture. One machine will assume the role of hub and the others will be the nodes. Hub controls the test scripts running on various browsers inside various operating systems. Test scripts being executed on different nodes can be written in different programming languages. Grid is still in use and works with both WebDriver and remote control. So we'll be learning about the WebDriver in the next slide. However, maintaining a grid with all required browsers and operating systems is a very huge challenge. For this, there are multiple online platforms that provide an online Selenium grid that lets you access to run your Selenium automation scripts. For example, you can use Lambda Test. It has more than 2000 browser environments over which you can run your tests and truly automate cross-browser testing. Now let's understand what is Selenium WebDriver. Selenium WebDriver is a web-based automation testing framework that can test web pages initiated on various web browsers and various operating systems. In fact, you also have the freedom to write test scripts in different programming languages like Java, Perl, Python, etc. It is important to remember that Mozilla Firefox is Selenium WebDriver's default browser. Now, some benefits of Selenium WebDriver are that they support 7 programming languages, they test on various browsers, and they work on different operating systems. Also, it overcomes limitations of Selenium version 1, like file upload, download, pop-ups, and dialogues barrier. Now, let's move on to the next most important tool, that is Jenkins. Continuous integration is the most important part of DevOps that is used to integrate various DevOps stages. Jenkins is the most popular continuous integration tool. It is an open source automation tool written in Java with plugins built for continuous integration purposes. Jenkins is basically used to build and test your software projects, continuously making it easier for developers to integrate changes to the project and making it easier for users to obtain a fresh build. It also allows you to continuously deliver your software by integrating with a large number of testing and deployment technologies. So basically, with Jenkins, organizations can accelerate the software development process through automation. Jenkins integrates development lifecycle processes of all kinds, including build, document, test, package, stage, deploy, static analysis, and much more. So this tool also achieves continuous integration with the help of plugins. Plugins are extremely important. It allows the integration of various DevOps stages. If you want to integrate a particular tool, you need to install that particular plugin for that tool. For example, Git, Maven to project, Amazon EC2, HTML publisher, etc. There are many advantages of Jenkins, and I'd want to discuss each one of them in detail. So the first one is it is an open source tool with a great community support. The second one is it is extremely easy to install. The next one is it has more than 1000 plugins to ease your work. Now, if a plugin does not exist, you can simply code it and share it with the community. The fourth advantage is it is free of cost. The last one is it is built with Java. Now, if you have been coding for some time now, you must be knowing that Java is portable to all the major platforms. So this gives an added advantage to Jenkins. So what makes Jenkins different from the other continuous integration tools? There are two reasons. The first one is adoption, the second one is plugins. So Jenkins is widespread with more than 147,000 active installations and over 1 million users around the world. The adoption of Jenkins is extremely high. The second one is that Jenkins is interconnected with well over 1,000 plugins that allow it to integrate with most of the development, testing, and deployment tools. So these two features, that is adoption and plugins, make it one of the best continuous integration tools currently available in the market. Now let's move on to the next tool of DevOps tools, that is Puppet. Today, the most mature tool for configuration management is Puppet. But I know you must be wondering why Puppet is so popular and what makes it unique when compared to other configuration management tools. Puppet is a configuration management tool that is used for deploying, configuring, and managing servers. So now let's understand the functions of Puppet. So the first one is it helps in defining distinct configurations for each and every host. And it also continuously checks and confirms whether the required configuration is in place and is not altered on the host. The second function is dynamic scaling up and scaling down of machines. The last one is it provides control over all your configured machines. So a centralized change gets propagated to all automatically. Puppet basically uses a master-slave architecture in which the master and slave communicate through a secure encrypted channel with the help of SSL. Now let's see this architecture in detail. So as you can see the diagram on the screen, the Puppet agent sends the facts to the Puppet master. Facts are basically key value data pair that represents some aspect of the slave state, such as its IP address, uptime, operating system, or whether it's a virtual machine. Puppet Master uses the facts to compile a catalog that defines how the slave should be configured. Catalog is a document that describes the desired state for each resource that Puppet Master manages on a slave. Puppet slave reports back to the master indicating that the configuration is finally complete, which is visible in the Puppet dashboard. Now with this we come to the last tool of DevOps, NAG iOS. NAG iOS monitors your entire IT infrastructure to ensure systems, applications, servers, and business processes are functioning properly. It is an integral to the DevOps lifecycle. So it is basically used for continuously monitoring of systems, applications, servers, and business processes in a DevOps culture. So in the event of a failure, NAG iOS can alert technical staff of the problem, allowing them to begin remediation processes before outages affect business processes, end users, or customers. With this tool, you don't really have to explain why an unseen infrastructure outage affects your organization's bottom line. NAG iOS runs on a server, usually as a daemon or a service. It periodically runs plugins residing on the same server. They contact hosts or servers on your network or on the internet. One can view the status information using the web interface. You can also receive email or SMS notification if something happens. The NAG iOS daemon behaves like a scheduler that runs certain scripts at certain moments. It stores the results of those scripts and will run other scripts if these result changes. NAG iOS also use plugins. So these are compiled executables or scripts that can be run from a command line to check the status or a host or a service. NAG iOS also uses the results from the plugins to determine the current status of the hosts and services on your network. NAG iOS is built on a server or agents architecture. Usually on a network, a NAG iOS server is running on a host, and plugins interact with local and all the remote hosts that need to be monitored. So these plugins will send information to the scheduler, which displays that in a graphical user interface. With this, we come to the end of DevOps tools. Let's move on to the next part of the session, that is DevOps automation. Automation is the crucial need for DevOps practices. And automating everything is the fundamental principle of DevOps. We discussed this initially in the session. Automation kickstarts from the code generation on the developer's machine until the code is pushed to the code, and after that to monitor the application and system in the production. Automating infrastructure setup and configurations, software deployment is the key highlight of DevOps practice. DevOps practice is dependent on automation to make deliveries over a few hours and make frequent deliveries across platforms. Automation in DevOps boosts speed, consistency, higher accuracy, reliability, and increases the number of deliveries. Automation in DevOps encapsulates everything right from the building, deploying, and monitoring. In large DevOps teams that maintain extensive, massive IT infrastructure, the tools can be classified into 6 categories. That is infrastructure automation, configuration management, deployment automation, performance management, log management, and monitoring. So for infrastructure automation, a great example is the Amazon Web Services. Being a cloud service, you don't really need to be physically present in the data center. They're easy to scale on demand, and there are no upfront hardware costs. It can also be configured to provide more servers based on traffic automatically. For the second one, Chef is a great example. Chef is a handy DevOps tool for achieving speed, scale, and consistency. It can be used to ease out complex tasks and perform configuration management. With the help of this tool, the DevOps team can avoid making changes across 10,000 servers. Rather, they need to make changes in one place, which is automatically reflected in other servers. For deployment automation, Jenkins is a great example. As we have already discussed before, it helps facilitate continuous integration and testing. It integrates project changes more efficiently by quickly finding issues as soon as builds are deployed. For the fourth one, that is performance management, Application Dynamic is a great example. It offers real-time performance monitoring. The data that is collected by this tool helps developers to debug whenever an issue occurs. The fifth one, that is for log management, Splunk is a great example. This DevOps tool solves issues such as storing, aggregating, and analyzing all logs in one place. So for the last one, that is monitoring, NAG iOS is a great example. It notifies people when infrastructure and related services go down. It is a tool for this purpose which helps the DevOps team to find and correct problems immediately. Okay, now moving on, let's talk about Azure and AWS DevOps. Azure DevOps is also known as Microsoft Visual Studio Team Services. It is basically a set of collaborative development tools built for the cloud. VSTS was commonly used as a standalone term, and Azure DevOps is a platform which is made up of a few different products. Some of the products are Azure Test Plans, Azure Boards, Azure Repos, Azure Pipeline, and Azure Artifacts. So Azure DevOps is everything that needs to turn an idea into a working piece of software. You can plan a project with Azure tools. The Azure Pipeline is the continuous integration component of Azure DevOps. The Azure Pipeline is Microsoft's cloud-native continuous integration server, which allows teams to continuously build, test, and deploy all from the cloud. An Azure Pipeline can connect to any number of source code repositories such as Azure Repos, GitHub, tests to grab code, and artifacts for application delivery. Now let me talk about Azure DevOps Server. So this server is a Microsoft product that provides version control, requirements management, reporting, lab management, and other release management capabilities. It basically covers the entire application of lifecycle and enables DevOps capabilities. Azure DevOps can be used as a backend to the numerous integrated development environments, but it is modified for Microsoft Visual Studio and Eclipse on all platforms. Now that we discussed Azure DevOps Server, let me talk about Azure DevOps Services. So Microsoft announced the release of the software as a service offering of Visual Studio on the Microsoft Azure platform. At the time, Microsoft called it as a Visual Studio Online. Microsoft offers Visual Studio, Basic, and Stakeholder subscriber access levels for the Azure DevOps services. Now let's learn about AWS DevOps. AWS, that is Amazon Web Services, is the best cloud service provider, and DevOps is the implementation of the software development lifecycle. Here are some reasons which makes AWS DevOps a very highly popular combination, such as AWS CloudFormation, AWS EC2, AWS CloudWatch, and AWS Pipeline. So let me talk about AWS CloudFormation. Here, the DevOps team is required to create and release cloud instances and services more frequently in comparison to development teams. Templates of AWS resources such as EC2 instances, ECS containers, and S3 storage buckets lets you set up the entire stack without having to bring together everything. So in the AWS EC2, you can run containers inside EC2 instances. Hence, you can leverage the AWS security and management features. The third one, that is AWS CloudWatch. So the AWS CloudWatch is a monitoring tool that tracks every resource that AWS has to offer. That is, it makes it easy to use third-party tools for monitoring such as Sumo Logic, etc. The fourth one, that is AWS Code Pipeline, is an essential feature from AWS, which highly simplifies the way you manage your continuous integration and continuous deployment tools. It basically integrates with tools such as Jenkins, GitHub, and Code Deploy that enable you to visually control the flow of application updates from build to production. With this, we've reached the last topic of today's session, DevOps certification. DevOps training certification helps anyone to make a career as a DevOps engineer. So the DevOps certifications are available from Red Hat, Amazon Web Services, DevOps Institution, Microsoft Academy, and Edureka. Edureka's DevOps certification training program will provide you with an in-depth knowledge of various DevOps tools, including Git, Jenkins, Docker, Puppet, Kubernetes, etc. This training is completely hands-on and designed in a way to help you become a certified practitioner through best practices in continuous development, continuous testing, configuration management, continuous integration, and finally, continuous monitoring of software throughout its development lifecycle.
Let's get started with the video. Let's kick things off by talking about why businesses, and everybody for that matter, need cloud computing. Here's an example. Meet John, who's an entrepreneur who has a brilliant idea for an app which solves a problem and has a great user experience. So what does John need? John will need developers to build his app, But other than that, in terms of infrastructure, he will need servers, then he will need storage devices, a dedicated network, security systems, and of course, he will need a dedicated IT operations team to monitor the whole infrastructure and make sure everything is working properly. John figured that there would be four major problems with this setup. And what are those? Let's take a look. So the first problem is that owning his own infrastructure would require a huge amount of money. And because of a huge investment in setup of the infrastructure, this would also greatly increase the risk if the app fails. Second problem is that he noticed that the infrastructure would take too long to set up, as he would have to buy all the components required for his infrastructure, then hire IT technicians to install all the components and connect everything up so that everything is talking to each other and working nicely. So that means more money and more time. Next, he realized that even after the expensive setup of the infrastructure, he will have to hire a team of IT operations to work around the clock for the upkeep of the infrastructure. This would include things like resolving issues with the hardware or software, replacing broken pieces of the infrastructure, so he would need to have spare parts on hand, switching to backup servers if the server goes down, preventative maintenance, and so on. Means more money and more headaches when the issues crop up. Another problem has to deal with the inability of the infrastructure to scale. So what if the traffic on the servers increases or decreases abruptly? Well, if the traffic increases, he will have to scale the infrastructure to meet that demand, which means expanding the infrastructure, so buying more components, probably renting more office spaces, hiring more IT staff to monitor the expanded infrastructure, and so on. But what if there's a sudden drop in the demand? All of this extra infrastructure and resources will sit idle. What about the extra people he hired? He will have to let them go? Well, it's terrible, but he may have to. Well, now let me tell you, John was smart. He did not opt for this setup. He opted for cloud computing because he was studying up on cloud computing, and he found that all big and small companies that are at the top in their domains are using cloud computing. And this research into cloud computing was a real eye opener, as he found that all these issues that he would face with the infrastructure that we just talked about could be solved by using the cloud. So obviously he opted for cloud. This is because there was almost no initial setup cost required, and it could be done in a few minutes or hours by using a single computer. And he wouldn't need a dedicated team to take care of the physical machines because that is taken care of by the cloud provider. And finally, to John's relief, infrastructure in the cloud scales automatically as the demand changes. Isn't that freaking amazing? So why don't we find out more about cloud computing in this next section? What is cloud computing? Cloud computing is the delivery of the computing services like servers, storage, databases, networking, software, analytics, intelligence, and so on over the internet, which we call colloquially the cloud. Okay, so let's understand that. John takes a computer that is connected to the internet, then he accesses the resources on cloud platform. So these resources that John needs are running on physical machines in the data center that are owned by cloud providers. So like I said before, all John needs is a computer that is connected to the internet, and the remainder of the infrastructure is actually provided by the cloud provider, and he can access the resources that he needs from the data center using the cloud platform. So how does this work? Well, first, John goes to the cloud provider, whichever one he likes the most. Amazon Web Services, Microsoft Azure, Google Cloud, these are the top cloud providers. So after going to the cloud provider's website, he signs up for an account and then he signs up for the services as per his requirements and configures the resources that he will need for the app to run on. And the amazing thing is that he only pays for the services that he uses and for the amount of time that those services were up for. Isn't that amazing? Of course it is. So let's now talk about what is Azure. Azure is a cloud platform that is provided by the company Microsoft, from which you can rent your resources and services. So you can grab a computer that is connected to internet, then go to Azure portal on your web browser, and then access the resources that you need by signing up with Microsoft Azure. So now it's time to find out which cloud platform did John choose. It's kind of a no-brainer, but here's what John says. The developers of my app and we all use Windows OS and other Microsoft products. So we wanted a cloud service that is best compatible with them. Can you guess which one this is? Of course, it is Microsoft Azure because it is most compatible with the Microsoft products. So before we talk about the services, why don't we find out some of the interesting things about Azure? Just like every other cloud platform, Azure provides 5 distinct type of services: infrastructure as a service, platform as a service, software as a service, container as a service, and functions as a service. Apart from that, Azure has 22 main categories of products, which we will take a look at later on. Next, Azure is operating globally in 60 plus regions and provides its services to 140 countries and counting. So just like the major cloud platforms, Azure provides pay-as-you-go plans and free plan. So there are actually no upfront fees for signing up with Azure, and you can pay as you go and only pay for the time your services are running. And just like every other cloud platform, Azure provides free basic plan, which is surprisingly good, and it is valid for 12 months. So you can tinker around and see if you like it. Okay, so what about the languages that are supported on Microsoft Azure? They are C Sharp, F Sharp, Java, TypeScript, and Python. Now let's move on to the next section where we discuss the services offered on Azure. So in the previous section, you probably remember that I mentioned that Azure has 22 categories of products. But what I did not mention is that it has over 600 services. So obviously, we are not going to be able to have enough time to discuss all 600 services. So here's your homework. Go to Azure's website and check out each of these categories and read up on them. If you have any questions, come back to this video and comment down in the section, and we will be more than happy to answer any of those for you. So I hope that you got a picture of all the categories of services provided by Microsoft Azure. So let's now go back to John. John needed 3 services. They were compute, networking, and storage. So let's take a look at each one of these in a little bit of a detail and then move on. So the first product that he's going to need to build his infrastructure in the cloud is compute. He can use this to deploy and manage virtual machines, containers, and batch jobs, as well as support remote application access. Compute resources created within the cloud can be configured with either public IP addresses or private IP addresses, depending on whether the resource needs to be accessible to the outside world. So some of the services that are offered within compute product are virtual machine, containers, Kubernetes service, cloud services, mobile apps. Let's move on to talk about the next, which is networking. So after setting up the virtual machines using the compute product, he will require networking in order to connect those virtual machines up so they can talk to each other and form a network. So this product gives you the ability to set up virtual networks, dedicated connections, and gateways. And it also gives you services for traffic management and diagnosis, load balancing, DNS hosting, and network protection against some of the attacks like DDoS. Next one that John needs is storage, obviously, for his virtual machines so that they can store customer data and use backup storage for all of the infrastructure. So there are various services that are offered within storage, like Azure Disk Storage, Blob Storage, Azure Backup, Queue Storage, and many more. This category of services provides scalable cloud storage for structured and unstructured data. It also supports big data projects, persistent storage, and archival storage. Similarly, there are 19 more categories that provide services that can cater to all needs of any organization or company. Which brings us to our next section, which is companies using Azure. Let's see which companies use Azure. So hundreds of big companies use Azure, but these are the ones that I picked for you guys because each one of these use Azure for a different purpose. So let's check that out. eBay has been using Azure for app development and hosting since 2010, which is the same year Microsoft announced Azure to the world. Boeing mainly uses Azure for its data analytics services for things like crew planning, maintenance optimization, fuel optimization, and crew training by building predictive models on the platform. BMW uses Azure's Internet of Things to make manufacturing process within their factories more efficient by connecting all different machines, sensors, and other devices. On the other hand, Samsung has used Azure for its smart TV infrastructure. The entire smart TV infrastructure is actually on the Azure platform. By choosing Azure, Samsung was able to achieve a significant reduction in costs and increased capacity in order to meet its rapidly growing customer base.
Now let us understand what is Azure Certification. Azure Certification is a level of Microsoft Cloud expertise that an individual obtains by passing one or more certification exams. Microsoft Azure Certification validates an individual cloud expertise and skills. Now let us move on to our next topic and see some of the benefits of Azure Certification. With an Azure Certification, you validate your cloud skills in your selected domain. You will earn the credibility, and your present or your future employee will know for sure that you have worked on Azure and have the skill as you mentioned. The next advantage is you will have higher salary packages. Business Wire has estimated that Azure course certification have raised their wages by 20 to 40%. Payscale.com also announced that based on the position and job description, those credited by Microsoft Azure could get a salary of $128,000 per annum. With the Azure certification, you can pursue a wide range of career options. You can become a cloud architect, a developer, or solution architect, or even AI engineer. There are many options. And in addition to this, the certification enables you to work with different industry at different locations. The next advantage would be it provides a proof of commitment. To get an Azure certification, you should be able to commit yourself to it. You would have to sign up for a course, study, and then only pass the exam. That would imply that you can commit your time and resources towards achieving your goal, and that you're dedicated to improving your career objectives in the long term. These were some of the benefits of Azure certification. Now let us move on to our next topic and see what are the types of Azure certification. First, we'll take a look at different Azure certification based on job roles. So first we have developer certification, who designs, builds, and tests cloud solutions. Second, the system administrator, who implements, monitors, and maintains Microsoft solution. Third, a solution architect, who expertise in compute, network, storage, and security. Fourth, we have the data engineer, who designs and implements the management, monitoring, security, and privacy of data using the full stack of data services. Fifth is data scientist, who applies machine learning techniques to train, evaluate, and deploy models that solve business problems. And then sixth, we have the AI engineer, who use cognitive services, machine learning, and knowledge mining to architect and implement Microsoft AI solutions. On seventh, we have DevOps engineer, who combines people, process, and technologies to continuously deliver valuable products and services to its company. Eighth is a security engineer, who implements security control and threat protection. He also manages identity and access and protects data, application, and networks. And last, we have the functional consultant, who leverages Microsoft Dynamics 365 and Microsoft Power Platform to anticipate and plan for customer needs. Microsoft Azure certification have 4 levels of certification. First is the fundamental level, second is the associate level, third is expert, and we have specialty. Now, specialty certification is a certification based on a particular domain. Now let us move on to our next topic and see some of the major job role based certification. Now before we get into any major role based certification, I would like to talk about a fundamental certification, which is Microsoft Certified Azure Fundamentals, or AZ900. Now this certification is intended for candidates who are just beginning to work with cloud-based solutions and services, or who are new to Azure platform. This certification will provide an opportunity to prove your knowledge of cloud concepts, Azure services, Azure workloads, security and privacy in Azure, as well as Azure pricing and support. Candidates who take this certification should be familiar with general technology concepts, including concepts of networking, storage, compute, application support, and application development. The AZ900 certification is the fundamental certification which can be used to prepare for any other Azure role-based or specialty certification, but it is not a prerequisite for any of them. Now let us see some of the major role-based Azure certification. We have the Azure Administrator Associate, or AZ104. Candidates for the Azure Administrator Associate certification should have subject matter expertise in implementing, managing, and monitoring an organization's Microsoft Azure environment. The responsibility include implementing, managing, and monitoring the identity, governance, storage, compute, and virtual network in a cloud environment. They also have to monitor and adjust resources wherever and whenever needed. They often serve as a part of larger team dedicated to implementing an organization's cloud infrastructure. For this certification, a candidate should have at least 6 months of hands-on experience administrating Azure. Along with that, they should also have strong understanding of core Azure services, Azure workloads, security, and governance. The next certification is Azure Developer Associate or AZ-204. Candidates for the Azure Developer Associate certification should have subject matter expertise in designing, building, testing, and maintaining cloud applications and services on Microsoft Azure. The responsibilities include participating in all phases of cloud development, from requirements definition and design to development, deployment, and maintenance to performance tuning and monitoring. Azure developers should participate with Cloud Solution Architect, Cloud Administrator, and clients to implement solutions. A candidate appearing for this certification should have at least 1 or 2 years professional development experience and experience with Microsoft Azure. Next, we have an expert level certification, which is Azure Solutions Architect Expert or AZ-303 or 304. Candidates for the Azure Solution Architect Expert certification should have subject matter expertise in designing and implementing solutions that run on Microsoft Azure, which would include aspects like compute, network, storage, and security. The responsibilities include advising stakeholders and also translating business requirements into secure, scalable, and reliable cloud solutions. They should partner with Cloud Administrator, Cloud DBAs, and clients to implement solutions. A candidate appearing for this certification should have advanced experience and knowledge of IT operation and also know how decision in each area affects an overall solution. These were some of the major role-based certification. Now let us move on to our next topic and see an overview of the exam guide. First, we have the exam format or question types. Microsoft continuously introduces innovative testing technologies and question types. Your exam might contain questions like multiple choices, repeated answer choices, short answers, mark review, drag and drop, labs, and so on. The time limit for different examination is, for associate and expert job role exams, you have 130 minutes to complete it. For job role fundamental exams, you have 60 minutes to complete it. For associate and expert job role exam that contains lab, you have 150 minutes to complete it. Now talking about the cost for the exam, for the fundamental exam, it would cost you $99. For the associate and the expert level exams, the cost is $165. And you can write the certification exams in either English, Chinese, Korean, or Japanese. Now the fundamental certification can also be written in Spanish, German, or French. Now let us move on to a last and important topic, which is how can you prepare for the certification. First, start with the basics. So if you're not 100% sure which certification to start with, I would recommend you to start small by taking the AZ-900 Azure Fundamental Certification exam. This will help you understand how Microsoft exam work when not being too deep into technologies. And after you have experience taking the Microsoft exam, this will help you understand how Microsoft exam work while not being too deep into the technology. Having experience taking the Microsoft exam, it will also help you focus on the actual topic and not on the testing process. The next step is to understand the exam content. The first thing to do after you decide which exam you're going to write is to see what you're asked during the exam. Every Microsoft exam page has the skill measured in the exam. This list is very accurate and helps you focus and study the right content. The page will also have some training and courses to prepare for the exam. You should also understand the different question types asked in the exam, which will help you in the certification. The next step is to take hands-on learning courses on Microsoft Learn for free. Microsoft Learn is a free learning platform for a lot of different Microsoft technologies. It provides you with various learning paths depending on your job roles or the skills you're looking for. Most of the learning paths gives you a hands-on learning opportunity so that you can develop practical skills through interactive training. The next and the most important step is hands-on experience. The best way to learn and pass the Microsoft Azure exams is by having real hands-on experience working with the technology. While Microsoft Learn gives you some free hands-on learning modules, there is also Azure Free Account. The Azure Free Account will provide you with 12 months of free Azure services, so you can work on various Azure services for free.
Now, the next step which will help you prepare for the certification is reading the Microsoft documentation. It will help you understand the topic better which might appear in the exam. As I've mentioned before, read the skills measured on the exam page. Look up for the specific Microsoft documentation pages and read through them, and then try them out in the tutorials. You can also refer some books from Microsoft Press. You can find Microsoft Azure documentation and Microsoft Press in Microsoft Azure Certification official page. After this step, you can also take up a practice exam. Some of the Azure certification have practice examination along with it, which is very similar to the actual certification examination.
Now let us understand what you will get after you sign up for Azure free account. So basically you get many things for 1 year, which includes $200 credits for first 30 days, popular services free for 12 months, more than 40 other services which are free all the time, and 750 hours of virtual machines, which includes Windows and Linux, and you can create up to 250 GB SQL database. Apart from this, you can get other services like free dev test labs, free load balancers, free batch jobs, free SQL server, etc. Now we'll see how to create an Azure free account. For this, you require a phone number, a credit card, a GitHub, or a Microsoft account to create your Azure free account. The best way is you can create a Hotmail or a Outlook email ID, then you can use the same email ID and password to sign up for the Azure free account. So firstly, you need to sign in through the Microsoft account using your Outlook, Hotmail, or any ID. And after that, you need to follow the couple of steps. That is, you need to first fill out about you, and then you will go through a verification by phone, and then you go through the verification by card, and finally you sign up. In the first step, that is about you, here you fill up your basic details, that is first name, last name, email ID, and phone number. Then followed by next step, that is identity verification by phone. So here you give your phone number and you will receive an OTP, and you need to just type your one-time password and just verify your phone number. So once you're verified, you move on to the next step, that is identity verification by card. Here you fill up your all credit card details followed by cardholder number, then credit card number, its expiry and CVV and your address. Once all it is done, then they charge you around 2 rupees just for your verification. They charge you 2 rupees and it is deducted. Once it is deducted, you move to the next step, that is like accepting the agreements. So you need to just tick mark all the agreements and finally you sign up. So once all this process is done, then you are ready to start with Azure. So this is how you create your Azure free account. It's very simple and super easy. So now let us know how to create an Azure free account without a credit card. So can we do this? So the answer is yes. Yes, you can. You can create an Azure free account without a credit card. But for this, you need to have a school account or a required school email ID. So you basically log in as a student. In this case, if you log in through a student account, so you will receive only 100 credit points, and you also get various other services like 750 hours Windows virtual machine, and you can create up to 250 GB SQL database, and you also get machine learning free workspaces, SQL Server Developer Edition, that is also for free, and lots of AI and machine learning features. This is how you create your Azure free account without a credit card. Now let's move on to the next topic, that is, can we delete a credit card? So many of us had a doubt that can we actually delete our credit card? So here in this picture you could see that I have a payment method, and here the delete option is disabled. So why is this so? In this case, you cannot delete a credit card as there is only one payment method option. If you really want to delete a credit card detail, then you need to add one more payment method. So you can click onto this add icon and you can add your new payment method. Once the payment method is added, then your delete option gets enabled. Then after that, you get the access to delete any one of your credit card details. So this is how you delete a credit card detail. Next, how to cancel subscription. So it is very easy to cancel the Azure subscription. So for this, you just need to go to cost management section. There you get go to subscription option. Once you click on to the go to subscription, you get all the details of your current subscription. So, and you can also find the cancel subscription option there. So once you click on to the cancel subscription, they will ask you the type of subscription name and you need to provide a reason why are you canceling the subscription. So you just give the reason, prescribed reason of your own, and then just click on cancel subscription. So once you click on to the cancel subscription, they will ask you the type of subscription and the reason why you want to cancel the subscription. So you can give your details accordingly and click on cancel subscription. So this is how you can cancel your Azure subscription.
So let us just go ahead and take a look at what this Azure portal does. Before I start about Azure portal, I would like to inform you that we would be opening Azure's portal and then we would be understanding what this portal is, what are the services it helps you with, and how it actually relates or combines all the stuff that cloud has to offer to you. So to do that, let me just quickly switch into the console part and we can just get started with the remaining part as well. So guys, what I've done is I've gone ahead and I've switched into Microsoft Azure portal. So for people again who are completely new to cloud computing, they might ask as in what is this Azure portal and how do I get to this portal? So this is what the link is. It is portal.azure.com. If you are completely new person to this particular page or this website, you would be required to sign in and create an account. Now, as you can see, I already have an account here. It is a fresh account. The reason I've chosen a fresh account is I wanted this dashboard to be clean so that we could go through certain pointers. However, there are certain applications that are running which would help us to understand certain pointers which otherwise you wouldn't have. So this is a perfect account for me. Apart from that, if you need to have this account, as I've already mentioned, you would have to go ahead and create a particular account. How do you do that? You visit this link, that is portal.azure.com. Once you do that, it would ask you to sign in and put in certain details. So when you do sign in or sign up, you'd have to enter certain details like your email ID, contact details, and why do you want to use this account. One pointer you need to consider is Microsoft Azure would ask you to enter your credit or debit card details. Now, do not worry, they do not charge you unnecessarily. What happens is this is a free tier account where Microsoft Azure would give you certain credit limit, maybe 12,000, 15,000, something like that. I do not remember the exact number, but it is somewhere around 10 to 15,000 in that range. 10 to 15,000 Indian rupees, because I am based in India right now, so I'm talking about Indian rupees. When you talk about it in dollars, I think it is somewhere around $200. So based on where your account exists, in that local currency, you would be given certain amount, which you can spend for 1 month and use all these services for free. So yes, you have sufficient time to explore all the resources. What Microsoft Azure does is it asks you to enter your credit card or debit card details. That is, once you exceed these limits, you might be charged because all these services have a certain cap on that. Don't mistake it for the fact that you'd be charged, because these limits are fairly high and probably you won't be charged in any way, but still you would be wanting to get through the documentation as in how much would you be charged. But before that, I would suggest that you actually go ahead and enter in all these details, create an account, and once you have an account, probably you can go through the pricing models as well to avoid getting billed in case if you actually go ahead and exceed these limits, which is very less likely to happen. So that being said, we have an account. If you do create an account and sign in, this is what your interface would look like. And this is something we call it as the Microsoft Azure portal. So let us try to understand what does this portal has to offer. What are the components that are there? Now, as you can see on the screen on your left-hand side, you have all the services that are listed. Now, these are the most commonly used services. When I say services, most of them are domains, as in these domains have more services under them. So domains and the services that you can see here on this part, there is an option called as create a resource, using which you can actually create these resources as well. Then you have this dashboard. It is blue in color for now. Let me see whether the color changes. Yep, as you can see, the color has changed. So if you double click on this dashboard, the color would change. So you can probably customize it to meet the needs. For now, let me just stick to the standard version, which is this. So you have the freedom of changing the color, and all the stuff that happens, the applications you launch, you can actually go ahead and have a picture of these things on your dashboard. How do you do that? Probably you can choose first of all which dashboard do you want to use. If you have multiple dashboards, you can do that. As you can see, this is one dashboard which has certain things pinned here. You can unpin those things and you can pin in all your applications to this dashboard. You can click on those applications and you have an option of pinning them to the dashboard. Next thing that you can do here is when you actually launch an application, there is this notification panel where you would be notified as in what has happened. If you've launched an instance maybe and you want your virtual machine or your application that is running on top of it to be on your dashboard, here you would be given an option. Do you want to pin it to the dashboard? And you can say yes, and immediately it gets pinned on the dashboard. Now, what benefit does this particular thing serve? I mean, what would I get if I actually go ahead and pin it here? The thing is, based on your business model, I mean, this is a fairly simple demo, so we do not have too many applications that we are talking about. But as your business grows, probably you might be dealing with a number of servers, a number of applications. So you might want particular information which is readily accessible to you. So you can probably pin those things on your dashboard. You get stats on those dashboards. If there are certain insights, you can actually have a plugin for analytics, which gives you reports and all those things. It readily integrates with Power BI, which is a very powerful data visualization tool using which you can actually have all the insights that you need. So yes, this is what the dashboard is. You have all the options here. You can create a new dashboard. You can upload files, download files. You can edit it, share the stuff that is there on your dashboard. You can probably maximize the screen size as well, clone certain dashboards and delete it here and here. So when you talk about dashboards, you have all the features. Now this is your Cloud Shell, guys. So what does a Cloud Shell do basically? So when I say a Cloud Shell, as I've already mentioned, you have your portal using which you can launch applications and you can do all the stuff right away. But at times you might be required to use command prompt. You might be required to hard code certain things. And how do you do that? You click on Cloud Shell where you can use it through the command prompt medium as well. Cloud Shell is the command prompt which is provided by Microsoft Azure. Apart from that, you have settings where you can actually go ahead and modify the settings. As you can see, this is the theme. You can change the theme here as well if you want. Some other features which you would want to explore, you can just go ahead and explore all the settings, delete certain settings, private dashboards as well. That boils down to your requirement. If you are unable to figure certain things on yourself or on your own, you'd want to actually go ahead and check in what the support has to offer to you as well. Feedback, you can submit feedback whether you're happy or not. And this is your account. If you click on this link, whether changing your passwords and stuff like that, all those things would be taken care of here. So guys, yeah, this is pretty much the dashboard. I mean, you can click on these services and you can just explore those services. If you have a particular requirement, you can type it here. Say if I type Azure bot service, if there is something or any service that is related to this, any documents as well, that would be popping up here and you can actually go ahead and direct or redirect yourself to those services from this mode as well. So yep, this is pretty much the interface, guys, the portal which I wanted you people to see. But let's not keep it this basic for now. What I'm going to do is I'm going to go ahead and create something. So if I click on this create option, it gives me an option of the stuff. I mean, I can choose, say, for example, for now it says Windows Server VM, which means that it would launch a virtual machine, guys, which is Windows Server 2016 VM. Now, let me tell you what a VM is for people who are completely new. This might be basic for people who have some experience of cloud computing and they might wonder as in why am I talking about these small little things, but probably we have people around who are completely new. So for them, I might get into the details of certain basic topics as well. So when you talk about a virtual machine, what we do is suppose I am running a particular application and it is supported by a particular operating system, say Windows in this case. So I want my architecture to support that particular operating system, right? But when you talk about larger applications, you might not always work on a particular environment. Your environment might change. So what cloud computing does is it readily lets you launch these virtual machines that can deal with different environments. And yet all these virtual machines can be under one network and they can stay connected under one VPC or one virtual network, basically. So yes, you can run multiple environments. You can have multiple applications running on different platforms and stuff like that. So this is one service that lets you do that. That is virtual machines offered by Microsoft Azure. And you have something called as web app, which lets you launch web applications. It is more platform as a service kind of an application. So what is a platform as a service application? Here, a complete platform is provided to you by a vendor. You just enter in certain details and it does everything for you. It launches virtual machines. I talked about having different environments, right? So when you click on a virtual machine and create one using Microsoft Azure, you have to specify details like the security group, IAM users, what network it lies under, and then you have to go ahead and manually install softwares, run your applications on top of it. But when you use something as platform as a service, what it does is it launches all this platform already. So your VM basically, which I talked about, is your infrastructure as a service where just the infrastructure is given to you, and on top of it, you do everything. But in PaaS, your vendor does everything for you. They launch this instance in the background, all the services that I mentioned, as in assigning security groups, security, IAM users, assigning it a network. All these things are taken care by a vendor. Even the platform that you choose, that is set up by your vendor. All you do is you just put in your data there. So this is platform as a service. So when you talk about Microsoft Azure, your web apps, basically when you create a web app, it is a PaaS service. All you have to do is just go ahead and enter a name, say sample app for me. You have to select the subscription. For now, it is the company's account that I'm using. It would create a resource group on its own, as you can see. And then all I have to say is create. So it has selected an operating system. Whether it wants to use a code or a Docker image, it is up to it, right? So it would take care of everything that is happening here, guys. My application would be launched right away. As you can see, I have been notified already that the deployment is in progress. It might take maybe half a minute or minute and a half maybe for this deployment to complete. I mean, all the processes that I talked about, those are happening in the background right now. And once those processes complete, I can actually go ahead and launch my application. So this would be a very basic application, guys. And as I've already mentioned, when you have a dashboard, it would ask you, do you want to pin your application to the dashboard? And if I say yes, it would pin it there directly. Let's hope that it happens quicker. See, it says pin to the dashboard. I would say yes. And there you go. It has been pinned to the dashboard. I can delete it, unpin it, and do whatever I want to. I can click on it and the application would open for me. So this is what the interface does. It gives me certain options, guys. I can check in the activity log, what all has happened in this application. If I click on this icon, it would give me the information. The operations, see, this is the operation name, that is write sites. So it has written a site. Access controls, who gets to control this application in particular. If you need a quick start guide, you can come here. Deployment slots, you can take a look at that as well. Application settings, you can click on this and you'd be getting all the settings. If you want to make a change to that, you can do that as well. The version, what application are you using and stuff like that. Configuration preview, click on this, certain other details would be given. So what framework are you using and stuff like that. Authentication process, guys, if you click on this icon, it would give me details about that as well. So if I scroll down, I come here, I have quite a few other things which I can actually look at. So if you are interested in these things, you can just come here and explore as in what is happening here. So this is pretty much it. I mean, the application has been launched. So if you take a look at it, it would give you details. What is the resource group that you're using? What is the URL? Where is it located? It is located in central US, guys. So see, I'm based in India right now and I've launched an application at a data center based in USA. So that is what you can do. And if you click on this link, it would tell you that your application is up and ready. So yes, a simple application has been created. So this interface, that is Microsoft Azure's portal, is fairly easy to use, fairly nice to use, and there are quite a few things which you can do. I've talked about certain basic things only. There are quite a few things that you can explore. I would suggest that you do go ahead and explore all these resources. As you can see that this has been done. If you want to take a look at some of the services here, you can actually go ahead and say all services, and it would give you details about all the services, all the resources. Yes, you click here and you have all the resources that are available to you. You can actually go ahead and modify your search as well. You can decide which resource group you want to view your data into. For now, I have these many resource groups that are there, which are running because this is an account that belongs to someone else. So this is my resource group. I can actually go ahead and select which resource groups I want to use to shortlist this data. Here's the information about all the resources. You can modify them, delete them, work on those, and do all the stuff that is required. If you go back to the dashboard, you would be taken here. If you open, you have all the other information again, diagnosis, application insights. You can install certain plugins that give you all these insights as well. For now, one more thing that you need to know is if there are certain applications that might charge you on the longer run, You'd want to get rid of those resources once your usage is done. You can just go ahead and delete those resources as well. Type the name of the app. It says it is sample app for me if I'm not wrong. There you go. You can just go ahead and delete this application and it will delete that application for you guys. It's fairly simple, guys. The application has been deleted as well.
Let's start out with what's version control. So to understand what is version control system, we need to understand first why we need a version control system. So we'll see why do we exactly need a version control system. So for that, let's take a scenario where there are 3 developers working remotely on a web application or a mobile application. Now for simplicity's sake, let's just assume that it is a streaming application and one of them is working on a streaming page. Let's call them developer 1. Developer 2 is working on a user information page and developer 3 is creating the payment portal. Now all 3 of them are done with their respective pages at 10 o'clock, 11 o'clock and 12 o'clock respectively. Now the thing is, all 3 developers are working in isolation. There may be their own changes, there may be changes in somebody else's page. They're all kind of adding some new files or modifying older files, changing the source code or something like that throughout the course of this project. But how exactly are they going to collaborate considering that they are working remotely? The solution to this is a version control system. With this system, I'll tell you what happens. At 10 o'clock, developer 1 uploads all the files regarding the streaming page. With a version control system, this modification is recorded and updated to one central directory or folder. So every time you're modifying an older file or adding a new file, it creates a snapshot of the latest version or the latest update of the changes that you've made or all the files that you've uploaded. So the snapshot of your update at 10 o'clock is saved, and then when developer 2 adds their user info page, this modification is also saved as a snapshot. Now there are 2 snapshots saved, and finally the payment portal page is added, and this is the last modification done at 12 o'clock, and this is the most recent snapshot saved, along with other snapshots of other updates and modifications done throughout the course of this project. Every change in your project, a snapshot is created and your entire project is saved that way. And these snapshots are actually known as different versions, which are basically the state of your project at a particular time or at the current time. It means that it will contain the kind of files your project is storing at one particular time and what kind of changes you have made so far between the previous version and this particular version. And this is exactly how a version control system works. So version control system basically is a system that records changes to a file or a set of files over time so that you can record specific versions later. These versions are recorded in a repository and they can be recalled anytime from these repositories during the course of your project. So version control systems essentially are of 3 types. Now the local version control system is one of the simplest forms of VCS and has a database that keeps all the changes of the files under revision control. So all the files are saved by this one user and they manage all of the files. But it's actually really hard to maintain the changes of the file and you can accidentally replace one or the other file that you need. It also needs something known as RCS or revision control system, which keeps patch sets or the differences between updates in a special format on your disk. All of this, your local version control systems maintains all the track of all the files within your local system. As a user, you can track specifically versions later, and it basically works as an independent standalone system for an application. So your applications like spreadsheets and word processors have this control mechanism. So that's one type. Apart from this, you also have your centralized version control system, which basically uses a central server to store all the files and enables team collaboration. So it's not one local system, but multiple systems which work on a single repository to which users can directly access as a central server. So the repository is a central server that could be local or remote, which is directly connected to each of the programmer's workstation. And the third kind of VCS is a distributed version control system. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In a distributed version control system, every contributor has a local copy or a clone of the main repository. So everyone maintains their own local repository, which contains all the files and the metadata present in the main repository. And they can push or commit or update the main repository if and when required. Now we are going to cover more on the latter two version control systems further in the session. So now let's try and understand in depth what's the difference between a centralized version control system and a distributed version control system. As I had mentioned before, in a centralized version control system, each programmer working on a branch on a project has absolute access to the central server. So the centralized version control system uses a central server to store all the files, and everybody on the team can directly access the central server as it is one single repository. So if you have 3 workstations, workstation 1, workstation 2, workstation 3, all of them can directly commit to the repository and get updates from the repository, which is your central server. The repository here indicates a server that could be local or remote, directly connected to each programmer's workstation. Every programmer can extract or update their workstations with the data present in the repository, or can make changes or updates or commit in the repository. And every operation is performed directly on this repository. Even though this seems pretty convenient when we are just talking about 3 people, to maintain a single repository like this has some major drawbacks. One of them is that it's not locally available, meaning every change that you have to make, you will have to be connected to a network to perform any action. Also, in any case, the central server getting crashed or corrupted will result in losing the entire data of the project. Also, another small thing which is revertible, but is if one person accidentally makes some unwanted updates, instead of his or her local system, they will be making that changes directly in the central server. So recovering that part back will be again a time-consuming process. This is where distributed version control systems come to the rescue. Now, these systems do not necessarily rely on a central server to store all the versions of a project file. In the distributed version control system, each and every contributor has a local copy or a local workstation clone of the main repository. That is, everybody maintains a local repository of their own which contains all the files and metadata present in the main repository. You will understand it better if you take a look at the diagram. As you can see, every programmer maintains a local repository or a local copy on its own, which is actually the copy or clone of the central repository on their local hard drive. They can commit and update their local repository without any interference from one another. And then they can update their local repositories with new data from the central server by an operation called pull. Once they are done with their bit of the code, they can affect the changes of the main repository by an operation called push from their local repository. Now, this system or this act of cloning an entire repository to your workstation and making all the changes on a local repository gives you a couple of advantages over a centralized version control system. First of all the operations except push and pull are very fast because the tool only needs access to the hard drive and not a remote server. Hence, you do not always need to be connected via a network connection, or you always do not need an internet connection. Committing new change sets can be done locally without manipulating the data on the main repository. Once you have a group of change sets ready, you can push them all at once. So you complete your set of code on your local system and then you push all the files once and for all into the main repository. Third, since every contributor has a full copy of the project repository, they can share changes with one another on wanting to get some feedback before affecting the changes in the main repository. So this enhances the essence of collaboration amongst a development team. And finally, if the server gets crashed at any point in time, the lost data can be easily recovered from one of the contributors' local repository. And that is why distributed version control system has been picking up popularity over the past decade. So why version control is important? First of all, it helps collaboration. It allows remote development, shared workspace, and real-time updates. All versions of your code are preserved, hence it helps you manage versions of the same code. Easy rollback from current version. Suppose a part of your project has been headed to a wrong direction, you can easily roll back from the current version to the last version which was stable. Now, because you can reverse faulty updates, you can save time and hence it reduces downtime of your project development. And finally, it improves visibility. You can analyze and compare different versions, and that gives you like a 50-foot top view of your entire project, which just accelerates your product delivery. So now that you have a bare sense of what is version control and why do you need version control, let's understand one of the most popular version control systems that exists today, and that is Git. So Git is a distributed version control tool that supports distributed nonlinear workflows by providing data assurance from developing quality software. So basically what it does is that it lets you and your team of developers work together on the same project remotely from anywhere across the world. Your team members can work efficiently on files and easily merge their changes into one source without the fear of losing or deleting anything of importance due to the easy rollback feature. Git is primarily used to manage your project comprising of a set of code or text files that you may want to change from time to time. Now, Git is an integral part of DevOps. DevOps, as most of you might have the idea of, is the practice of bringing agility to the process of development and operations. A couple of years ago, it was this entirely revolutionary ideology which swept IT organizations worldwide, boosting project life cycles and in turn increasing profits. DevOps promoted communication between development engineers and operations participating together in the entire life cycle, from design through development process to production support. Now, in the entire life cycle of DevOps, starting from planning of the projects to its deployment and monitoring, Git plays a vital role. When it comes to managing the code that collaborators contribute to the shared repository, this code is extracted for performing continuous integration to create a build and test it on the test server and eventually deploy it to production. Tools like Git enable communication between the development and operations team. When you are developing a large project with a huge number of collaborators, it is extremely important to have communication between the collaborators, between the developers while making changes in the project. Commit messages in Git play a very important role in this particular collaboration or communication amongst the team. The bits and pieces that we deploy or update lies in this version control system, such as Git. To succeed in DevOps, you need to have all the communication in version control. Hence, Git plays an extremely vital role in succeeding at DevOps. And due to this very reason, Git has earned way more popularity compared to other version control tools available in the market, such as Apache Subversion, concurrent version systems, and Mercurial. If you compare the interest of Git by time with other version control systems, you shall realize that larger companies' products are generally developed by developers using Git all around the globe. And some famous names out of them are Facebook, Yahoo, Zynga, Quora, Twitter, eBay, Salesforce, Microsoft, and many, many more. Now, lately, all of Microsoft's new development work has been in Git features. Microsoft migrating .NET and many of its open source projects on GitHub, which are managed by Git. One of such projects is the LightGBM. It's a fast, distributed, high-performance gradient boosting framework based on the decision tree algorithms, which is used for ranking, classification, and many other machine learning tasks. Here, Git plays an important role in managing this distributed version of light GBM by providing speed and accuracy. So basically, to enable version control, Git is your go-to solution. It's fast and suitable for handling massive code bases scattered across multiple developers, which makes it the most popular tool used today. Now that you know about Git, a terminology we'll be using a lot while talking about Git and GitHub is a repository. Now, repository, or a repo as it's most commonly known as, is a directory or a storage space where your projects can basically live. It can be local to a folder or your computer, or it can be a storage space in another online host such as your GitHub. And in this particular space, in this particular directory, you can keep your code files, text files, images, you name it, all of it inside a repository. Through the course of this, we shall also be talking about something known as GitHub, which is nothing but a central repository, the kind that we spoke about when we discussed centralized versus distributed version control systems. There's a central repository, and that is where all of your code will live. You have your local repository where you'll make the changes, and there you have the central repository to which you will push all of the changes. Yeah? And the central repository is something that all of the developers involved in this particular project, in a certain project, have access to. All right, moving on, let's discuss a few Git features which make it so popular amongst organizations as well as individuals. First of all, it's economical. It's free and open source. Git is released under GPL's General Public Licenses, open source license, so you don't need to purchase Git. It is absolutely free, and since it's open source, you can modify the source code as per your requirement. Second is its speed. Now, since you do not have to connect to any network for performing all of the operations, it completes all the tasks really fast. Performance tests done by Mozilla showed it was an order of magnitude faster than other version control systems. Fetching version history from locally stored repository can be 100 times faster than fetching it from the remote server. So the core part of Git is written in C, which avoids runtime overheads associated with other high-level languages, which makes it extremely fast compared to other version control systems. Next is that Git supports non-linear development. Git supports rapid branching and merging and includes specific tools for visualization and navigation of a non-linear development history. A core assumption in Git is that a change will be merged more often than it's written, as it is passed around various reviewers. Hence, branches in Git are very lightweight and is only a reference to a single commit. With its parental commits, the full branch structure can be constructed. Next, let's talk about the robustness. Nearly every single task in Git is undoable. Git gives each developer a local copy of the entire development history and the changes copied from one repository to another. These changes are imported as additional development branches and can be merged and deleted and recovered the same way as a locally developed branch. Next is the snapshots, which are recorded changes made to a file rather than the file itself. Followed by which you have integrity, which means no changes can be made without Git recording it. Since every contributor has their own local repository, on the events of a system crash, the lost data can be recovered from any of the local repositories. You will always have a backup of all of your files, and none of the changes made to the central repository will go unlogged by Git. Git uses the SHA-1 or the secure hash function to name and identify objects within its repository, and every file, every commit is checksummed and retrieved by its checksum at the time of the checkout. The Git history is stored in such a way that the ID of a particular version, a commit in Git's terms, depends upon the complete development history leading up to that commit. Once it's published, it's not possible to change the old versions without it being recorded. Then it's a distributed system, which means every user has their own copy of the repository and the data is stored locally. Git gives each developer a local copy of the entire development history, and the changes are copied from one such repository to another. These changes are imported as additional development branches and can be merged in the same way as a locally developed branch. And finally, it's easy branching. Now, branch management with Git is very simple. It only takes a few seconds to create, delete, and merge branches. Feature branches provide an isolated environment for each change to your code base. So when a developer wants to start working on something, no matter how big or small, they can create a fresh new branch which is not interfering with the main branch, which ensures that the master branch or the main branch always contains production quality code. So any little experimentation that you want to do or little things that you want to try out can always be on a separate feature branch instead of the changes made to your master branch. Because ultimately, your master branch should contain your publishable product. So now that you know the basic features of Git, let's try and understand what the basic workflow of Git is, or how does Git work. So the basic overview of how Git works goes like this. You basically create a repository or a project with a Git hosting tool like Git or Bitbucket. You copy or clone the repository to your own local machine or your working directory. You add a file to your local repository and commit the changes, which basically means you save the changes. Then you push the changes to your master branch. Then you make changes to your file and commit. Then you pull the changes to your local machine. You create a branch or a version, make a change, commit the change, same process, open a pull request, and merge your branch to the master branch. Now, this is a little complicated listening to it like this, but once we get on to our demonstration, I think things will be way more clear. You can still take a good look at this diagram, but if you don't get it, don't worry. I will be explaining these operations one by one when we get to the demonstration part of this Git tutorial. Moving on, let's get to the good part, the hands-on section, starting with the installation and setup of Git. Now, there are two ways in which this goes. First of all, for Windows users, you need to install Git Bash for Windows. And for Linux users, you'll have to start by updating the package index and then install Git using the terminal. So first of all, for our learners using Windows, you'll have to log on to gitscm.com/downloads and then click on Downloads for Windows button and then run the executable file and follow through till you finally install Git Bash. I'm not going to install it completely as I already have Git Bash downloaded, but I'm still going to open the page to show you guys. All right. So the latest source release is Git 2.30.1 on the 8th of Feb, and you can just click on this button. The moment you click on this button, it's going to start downloading Git for you. And once you have the executable file, all you have to do is open it or run it in your own system, right? Next, for people using Linux, this is an example considering you are using Ubuntu. If you're using CentOS, a lot of the commands don't change, but instead of apt install, you will be using yum install for CentOS. So for that, now I'm going to open my terminal on a virtual machine. So here I have running an Ubuntu machine using the Oracle VirtualBox. So I'm going to start by running an update. All right, this is going to take a while. Kindly be patient. So here I have my Ubuntu running on a virtual machine. So to install Git on your Ubuntu machine, you have to start by updating. So this will take some time. We're going to use sudo apt update. If you're using CentOS, you will be using yum instead of apt. Let's clear that out, and then we're going to install Git. And then you can look for the Git version. Yeah? All right. Now that we have our Git installed, let's go ahead and look at the operations and commands that we are going to take a look at today. you have your repository setup, which include the commands init, clone, config, and alias. Then you have your save changes operations, which have your add, commit, diff, and stash. All of these commands we are going to go on and off and look at collectively mostly. Then we are going to look at the inspect operations, your inspect repository operations, of which the git status command is something we are also going to look at throughout this demonstration right from the beginning. So apart from that, you have your git log, git tag, and git blame commands. So you have your merge rebase command. So let's move on to our first set of git operations. First of all, you have your git init command, which basically creates a new empty git repository. Now this can be used to convert an existing unversioned project to a git repository or initiate an absolute fresh git repository. Now most other git commands are not available outside of the initialized repository. So this is usually the first command that you will run in a new project. That is, if you're using git bash. So when I run git init, it reinitializes an existing git repository, which I already have here. Now what this does is it reinitialized my existing git repository in this particular directory, in this .git directory. Yeah. What git init does is that it creates an empty git repository or reinitializes an existing one, like it did for me right now. It basically creates a .git directory with subdirectories and template files. And when you run the git init command in an existing repository, it will not overwrite the things that are already there. It'll rather pick up the newly added templates. So that's the repository initialized. You can go ahead and create some files in the directory or repository, whatever you call it. Now that is about initialization. Now, what about if there was an existing repository on Git that you had to act upon, that you had to make updates to, that you had to add files to, things like that? That's where you use the git clone utility. Yeah. Now you have the git clone utility, which you use to target an existing repository and create a clone or copy of this particular repository on your local machine. Now this is one of the features provided to you by a distributed version control system, as we had discussed before. So this is a blank file called Edureka rep with just the readme text file. Let me just go ahead and copy this. And then I can just git clone and paste its HTTPS URL. And as you can see, it's cloning this into Edureka rep. And now if I change directory to Edureka rep, you can see the readme file is right there. Yeah. So we're basically going to work off of this particular repository today, Edureka rep. Yeah. So now that we created a clone, moving on, we have the git config command, which basically is a convenience function that is used to set up your git configuration values on your global or local project level. This command is basically used to modify your configuration text file. So if I typed git config global user.email, and here I type, so there I gave in my email ID as the global user email ID. So if I ask for what the global user email ID is, it will return my ID back to me. Yeah. Basically, these configuration levels, like your username and your user ID, correspond to your .git config text files. Now executing this basically will help you modify the configuration text file. Git uses this series of configuration files to determine non-default behavior that you may want. Yeah. So the first place Git looks for these values is in the system-wide configuration file, which contains settings that are applied to every user on this system So basically, if you pass the option to your git config, it will read and write from this file specifically. And the next place the git looks is the config/git config file, which is specific to each user. Now you can make git read or write to this file by passing your global option, which is what I did. And the final command in the setup operations that we are going to look at is an alias. Now, alias, as the name suggests, is basically used to create shorter commands that map to longer commands. They enable more efficient workflows when you obviously have to use lesser keystrokes to execute a command. There are these lengthy commands which obviously kill a lot of your time. So these aliases you can use to shorten those commands. And these are also something that you will create via the git config command. There isn't really a direct way or a direct command of creating aliases. Yeah, this is just something I wanted to add in here along with the git config command. Like a very common alias created is CO for checkout or anything else, CK for checkout. So yeah, this is something that you can do using the git config command, just creating aliases. Moving on, let's look at operations that you use to add changes and save changes to your Git repository. Now, the first two commands here that we're going to look at are git add and git commit. Now, this combination is basically used to create these snapshots that I was talking about initially in the session, right? So basically what you do is first, you use the git add command to add a change in your current directory or your working directory. And you add that to the staging area. It tells Git that you want to include a particular set of updates or changes in a particular file in the next commit. Then what you do is you move on to git commit after making the changes to your working tree. Then you use the git commit command, which captures a snapshot of your project's current state. So basically, you use add to update the index using the current content found in your working tree, and then you basically prepare the content in the staging area for the next commit. Then you run the commit command to take that snapshot of your project's current status. Now remember, this is very important and you have to do it each time. You must use the add command to add any new modified files to the index. You can't directly commit anything without adding it to the stage area first. Now what I did was I quickly went ahead and added 3 files to my repository Edureka rep. So if I go into this repository, you can see there are 3 files, Edureka file 1, file 2, file 3. Now let's see if these files are in my index or not using the command git status. Now git status basically displays the state of the working directory and the staging area. It will list all the modified files which are ready to be added to the local repository. It lets you see which changes have been staged and which haven't, which files are being tracked by Git and not. So if I typed git status, you can see on your main branch, you have 3 untracked files, which are the 3 files that I just added, Edureka file 1, 2, and 3. These are not added to the index yet. This means I cannot commit these changes unless I added them explicitly to the index. So now we are going to add these 3 files. This command will update the index using the current content, which is found in your working tree, as you can see in front of you. And then it'll prepare the content in the staging area for the next commit. So either I can just git add and put in the directory name, or I can just use git add with an extension of a, which means all, and this will add all of these files to the index which are in the directory but not updated in the index yet. Yeah, now I've done that. Let me go ahead and use git status again, and you can see all of these file names are written in green, and you can see changes to be committed written here, which means all of these changes are ready to be committed. They are added to the index. Now these files are added to the index. You're ready to commit them. Now, as I had mentioned before, We're going to commit them, and committing refers to recording the snapshots of the repository at any given time. So your committed snapshots will never change unless it's done explicitly. So I'm going to clear this, and we're going to commit this by typing git commit and then adding a tag or a message called committing 3 files. Let's try this out. As you can see, 3 files changed, 3 insertions. You can see our Edureka files 1 to 3 have been committed. The git commit command has committed the changes in the 3 files in your local repository. Now, if you want to commit a snapshot of all of the changes in your working directory at once, you can always go with commit-a. Now, let me add a couple more files to my directory just to show you the difference between your files added to the index versus the ones that are not. If I type ls again, you can see there are 2 more files over here. As you can see, I have 2 other files. I'm just going to add the Edureka file 4 and now the file 5, and then I'm just going to git commit committing files. And as you can see, only one file changed, only one insertion happened, and that only happened because Edureka file 5 is not added to the index. And even if I use the extension A, I cannot add Edureka file 5 because that has not been added to your index. Now if I just go ahead and add Edureka file 5, voila, the change has occurred in our Git repository. Now if I typed git status, there are no more files to add or commit. Our branch is ahead of the origin or main branch by 3 commits. And you can use git push to publish your local commits. Now what is git push? This is something we will cover later in this session. Now understand that before you affect the changes made to the central repository, you should always pull changes from the central repository to your local repository just to get the most updated version of your branch. You'll get all the work of your collaborators that have been contributing in the central repository. For that, you use the pull command. Now, as you can see, there's nothing to commit and your working tree is clean. There are other commands like the git status command, which you could use for similar purposes. For example, you have the git log command, which only operates on committed history. It basically will display to you the committed snapshots and will let you list the project history, filter it, and search for specific changes. So if you typed git log, it's going to show you all the commits that have happened since we started with this git file. Okay, so you can see at the bottom, your original main, there's your initial commit, right? Then our first commit where we committed 3 files, then we committed the 4th file, and finally when we committed file number 5, right? These are all the commits, including the initial commit, the first one. Yeah, along with the author and the date and time. Remember when I told you about everything is recorded when you're using Git? This is what I meant. You can always access who made commits at what time and what commits were made when you use a version control system such as Git. Now at a point like this, I think it's crucial to mention one more command, which is the git tag, and it's used to basically capture a tag in history or a point in history that is used for a marked version release, right? So it's basically like a branch that doesn't change, and after being created, they have no further history of commits. Yeah, so that is one. And another one is git blame. Now the git blame function displays of the author's metadata attached to a specific committed line in a file. It's used to examine specific points in a file's history and get context as to who the last author was that modified that line. So if I went back and typed git blame Edureka file 5.txt, it's going to show who the person is that is to blame, who committed this particular file or made this particular change, right? It'll also, if you paid attention, give you the commit number. As you can see, this E9D63EFO commit number. This also has this E9D63EFO, which is the first few characters of this particular commit number. Yeah. So now that you know how to check the status of the changes and see who made the changes, it's time that you understand how you fetch changes from your remote repository to a local repository, and how you push commits from your local repository to your remote repository. So here we are going to look at two commands called pull and push. Now, first of all, you have the git pull command, which fetches changes from your remote repository to a local repository. Basically, it merges upstream changes in your local repository, which is a common task in Git-based collaborations. But at first, you need to set your central repository as the origin using the command git remote add origin, and I'm going to add the link to my central repository, which is this. And as it says, the remote origin already exists. Now that your origin is set, and now we're going to pull our main branch. So I'm just going to type git pull origin main, and it says we are already up to date. Now, certain number of tutorials or documents that you might be following might even give you the command git pull origin master, in which case you're working on the master branch. Now, to know which branch you're at, you can just use the command git branch vv. Yeah, I'll tell you which branch are you working on. Yeah. So yeah, we are working on the main branch, and we are already up to date with the branch, since my local repository was already updated with files from the main branch. This is the message of an up-to-date branch. Now you can also use git pull origin and your whatever branch name. Here I'm using main. That's a mistake on my part. Maybe I was trying to clear the screen. All right. So here, even if I pull from the branch using git pull origin and the branch name to my local git repository, you can see it's already up to date. So now my local git repository is now all updated with the recent changes. So now it's time to make the changes to your central repository by using the push command. So we're going to use the push command. This command transfers commits from your local repository to your remote repository, and it is basically the opposite of your pull operations. Pulling will import commits to your local repositories, whereas pushing will export commits to your remote repositories. It's going to ask you for your username, and password before it lets you push into your main branch there. So I've put in the username and password for my GitHub account, and with that, this has pushed the changes from my local repository to the remote repository along with all the necessary commits and internal objects. Now this has created a local branch in your destination repository. The use of git push is to publish your local changes to a central repository. After you've accumulated several local commits and are ready to share them with the rest of the team, you can then push them to your central repository by using the git push command. Now the files which have already been committed previously in the commit section and they were all push ready, you will use git push origin master to reflect these files in the master branch of your repository. All right. So let's go ahead to our repository and see if changes have been made. And yes, you can see all of our files on our GitHub repository. You have Edureka file 1, 2, 3, 4, and 5. All the 5 files that we had created on our local repository. Yeah, You have all these 5 files and the README file here. Here also you have the README file and all the 5 files that we had created. Now at this point in this Git tutorial, I hope you have understood the basic commands of Git. You have pulling, pushing, adding, committing, things like that. Now let's take a step further and understand the 3 basic commands of parallel development. Here I'm going to be talking about branching, merging, and rebasing. So first of all, let's talk about merging. Now, merging is a way to combine the work of different branches together. This will basically allow you to branch off, develop a new feature, and then combine it back in. As you can see in the diagram, it shows you 2 basically different branches, new branch and master. Now, when we merge the work of the new branch into the master, it creates a new commit, which contains all the work of the master and new branch. Now, if we merge the 2 branches with the merge command, as I had mentioned before, Git allows you for easy branching, which means you have parallel branches with your master branch that help you carry on your individual work while not interrupting your main product, which is your master branch or your main branch. So branches in Git are nothing but pointers to specific commits. Yeah. So Git generally prefers to keep its branches as lightweight as possible. Now there are basically 2 kinds of branches via local and remote tracking branches. A local branch is just not the path of your working tree. On the other hand, the remote tracking branches have special purposes. Some of them are linking your work from your local repository to your central repository and automatically detecting which remote branches to get changes from when you do a git pull. So you can check what your local branch is by using git branch. So you know you are at your main branch. And the one thing you should understand, one thing is like a main mantra of people who use Git are branch early and branch often. Yes. So to create a new branch, you're going to use a command git branch and your branch name. And in this case, I'm just going to use a branch name Edureka images. All right. And here you can see this diagram shows the workflow of a new branch that is created when we create a new branch. It originates from the master branch itself. So since there's no storage or memory overhead with making many branches, it's usually easier to logically divide your work up than having big chunky branches. Hence, the branch often part. Now let's see how to commit using branches. Now branching includes the work of a particular commit along with all parent commits, right? So as you see, the new branch has detached itself from the master or the main branch, and hence it'll create a different path. So we are going to git check out the branch name, which in our case is Edureka images. And then we are going to git commit. So you have untracked files, Edureka images, and nothing added. So you made that branch. Now, merging is a way to combine the work of different branches together. So basically what this does is, now that we've branched off to something known as Edureka images, you can go ahead, add files to it, develop a new feature, and then combine it back into your main branch. Here you can see 2 different branches. You have your new branch and your main branch. And when we merge the work of a new branch into the main branch, it creates a new commit, which contains all the work of the main branch and the new branch. So now if we merge this branch, as you can see, it's already up to date. It's important to know that the branch name here should be the branch that you want to merge into the branch that you're currently checking out. So make sure that you are checked out of this destination branch. So let's just merge all the work of the branch Edureka images into your main branch. For that, I will first check out my main branch and then merge Edureka images with git merge Edureka images. And as you can see, all the data from the branch Edureka images has merged into the main branch. Now notice that merging in Git creates a special commit that has two unique parents. Now this is one way of merging into the main branch. There's also another way of combining the work between two branches, which is called rebasing. Now rebasing takes a set of commits, copies them, and stores them outside your repository. The advantage of rebasing is that it can also be used to make linear sequence commits. The commit log or the history of the repository stays clean if rebasing is done. Now our work from the new branch is placed right after master, and we have this nice linear sequence of commits. This command doesn't copy but moves all our work from the current branch to the master or the main branch. They look like they've been developed sequentially instead of having developed parallelly. So if I just did another branch called git branch Edureka images 2, and then maybe git checkout, okay, then we git commit this, and then I could just git rebase main, and your current branch will be up to date. This command basically moves all of your work from your current branch to your master branch, and it'll basically look like it has been developed sequentially instead of having developed parallelly. Now, apart from these, there are certain operations that you ought to know. Firstly, archiving your repository. You can use this command. It stores all of your files and data in a zip file rather than a .git directory. This creates only a single snapshot, omitting version control completely though. This comes in handy when you want to send these files to a client for review who doesn't have Git installed in their computers. Apart from this, you can also bundle your repository, which basically turns your entire repository into a single file. This pushes the master branch or the main branch to a remote branch, only contained in a file instead of a repository. You could alternately change the repository, clone the repo bundle, create a copy, and use git log, but that is like 5 commands instead of 1. Why not just use 1 command? And finally, stashing uncommitted changes. When you want to undo adding a feature or any kind of added data temporarily, we can always stash them temporarily. You can use git status, stash status, and then you want to reapply the changes you stashed using git stash apply. Having said that, let's move on to another very important topic in this Git tutorial. Let's go through a brief introduction to SSH. Now, what is SSH? What is an SSH key? Now, an SSH key is an access credential for Secure Shell Network Protocol. It's basically an authenticated and encrypted secure network protocol and is used for remote communications between machines on an unsecured open network, for remote file transfer, network management, and remote operating system access. So basically, it's typically used to log into a remote machine and execute commands in it. But this also supports tunneling, forwarding TCP ports, and X11 conditions. It can transfer files using associated SSH file transfer or secure copy protocols. It provides you several alternative options for strong authentication and protects the communication security and integrity with very strong encryption. It's a secure alternative to the non-protected login protocols and insecure file transfer methods such as FTP. So basically, how do you create SSH keys? You start by using the command ssh-keygen, and then you'll be prompted to enter a file in which to save the key. So home, Edureka. Then we're going to enter a passphrase. I'm just going to leave it empty again. And you can see our identification has been saved in the file that we specified. And we have something known as a key fingerprint. And finally, what we have to do is add the new SSH key to the SSH agent. And then you will see identity added. And that's it. You have created an SSH key.
the need for GitHub. It is extremely important for software developers to work on a web-based platform to share their projects and collaborate with other developers. This platform must be a version control system, that is, it must enable multiple people to simultaneously work on a single project. Each person edits his or her own copy of the files and chooses when to share those changes with the rest of the team. This application must also be capable of hosting millions of programmers and hobbyists that download and evaluate each other's work. GitHub is one such platform of choice for developers that can host multiple programmers and review their code. GitHub has several competitors. For instance, GitLab. GitLab is an open source web interface and source control platform based on Git, whereas Microsoft Team Foundation Server is an enterprise-grade server for teams to share code, track work, and ship software for any language, all in a single package. Bitbucket, on the other hand, stores all of your Git and Mercurial source code in one place, with unlimited private repositories. So what really makes GitHub so powerful and popular among developers? GitHub is an open source platform, and the community is really what fuels it. Moreover, GitHub is the platform of choice for developers from various large corporations too. Microsoft is the #1 contributor to the system, but there are also Google, SAP, Airbnb, IBM, PayPal, and many others. Exposure and insight that you can get on GitHub are simply unmatched by any other platform. Here you can discover code written by others, learn from it, and even use it for your own projects. Versions control on GitHub works very much like Microsoft Office or Google Drive. It simply tracks all the changes made to your code and who makes them. You can always review the detailed change log that neatly hosts all of the relevant information. Using GitHub eliminates the need for complex corporate security solution because everything is on cloud. The platform protects code branches, verifies commit signing, and controls access. Now that we know why we need GitHub, let us understand what is GitHub. GitHub is a Git repository hosting service that provides a web-based graphical interface with many features. A repository is usually used to organize a single project. Repositories can contain folders, files, images, videos, spreadsheets, anything your project needs. Let's say, for example, a team wants to work on a particular project. Here they can simultaneously write and update their code to a central repository which is present on GitHub. So GitHub is a highly used software that is typically used for version control. It is helpful when more than just say one person is working on a project. For example, a software development team wants to build a website and everyone has to update their codes simultaneously while working on this project. In this case, GitHub helps them to build a centralized repository where everyone can upload, edit, and manage the code files. Most software projects have a bug tracker of some kind. GitHub's tracker is called Issues and has its very own section in every repository. Issues basically are a great way to keep track of tasks, enhancements, and bugs for your project. Moving on, people often get confused between the terms Git and GitHub. Now let me clearly explain the difference between them. Git is simply a version control system that lets you manage and track changes within your project, whereas GitHub is a cloud-based service that lets you manage Git repositories. So basically, Git is the tool and GitHub is the service. Now that we know the difference between Git and GitHub, let us move on and understand how these two work hand in hand. We already know that Git is a version control tool that will allow you to perform all kinds of operations to fetch data from the central server or push data to it, whereas GitHub is a code hosting platform for version control collaboration. GitHub is basically a company that allows you to host a central repository in a remote server. Now, without any further ado, let's get started with the demonstration on how to use GitHub. So for this demonstration, we're working on the website version of GitHub. There's another version of GitHub that is the desktop version, which you can download it to your personal computer. So we're simply going to search for GitHub in our search engine. The first link will lead you to the official website of GitHub. So I'm going to click on that. So this will redirect me to the main homepage of GitHub. As you can see, there is a search GitHub option. There are also two buttons that says sign in and sign up. If you're new to GitHub, you can simply enter in your credentials, that is a username, email, password, and sign up for GitHub. But if you already have an account like I do, I'm simply going to click on the sign in button and it'll redirect me to a page where I have to enter the credentials, that is my email address and password. I'm going to do that now. And I'm going to click on the sign in button. Now, this is the main page of my account. As you can see, I have no repositories. It's all new, it's all fresh. But if you're not new to GitHub, you can view all of your repositories on the left-hand corner. Now, before we move on, I'm going to explain you all the features that are present within GitHub. So you can see a search bar here. So the search bar will allow you to look for profiles, certain keywords, look for different kinds of projects that are available on GitHub. All of those can be done using this bar here. And you can see 4 options next to the bar that says pull requests, issues, marketplace, explore. Pull requests we'll learn later on in this session, but the issues and marketplace we won't be discussing in this video for now. The explore button, on the other hand, is an extremely important and interesting button. So once I click on that, it'll redirect me to a page with some activities that are going on around in GitHub. You can see here they're trending repositories, they're trending developers. Basically, this is a feed that will allow you to interact with developers and other people, collaborators from all around the world, basically. In Instagram too, you have an explore button, which will allow you to interact with different people from all around the world. So the same concept is implied in the GitHub explore button too. So you can explore topics, you can explore trending repositories, developers. Basically, it's an interaction with other people from different parts of the world. So I hope that's clear. Now, the most important part of the session are the 3 buttons that are available in the right-hand corner of the navigation bar. So you can see there's a bell icon, there's a plus icon, there's a pixelated icon on the right-hand corner. So the bell icon allows you to read notifications of your activities that occur in GitHub. So that's what it really is. You can see the inbox will allow you to view all of the notifications. You can also view the unread notifications by clicking on this unread button. As of now, I don't have any notifications, so there's nothing available. You can also group these notifications by the date or repository by clicking on this group by button here. You can also view your saved notifications by clicking on here. And the done button, on the other hand, will let you mark all of your notifications that you're done with, your previous notifications. So these are the 3 important buttons you'll have to know in this bell icon. And the filters are not necessary as of now, so I'm not going to discuss that. This button, on the other hand, will allow you to manage your notification settings and your subscriptions too. So that's all for this bell icon. The next important button is this plus icon. As you can see, there are 5 drop-down options that appear here. The first one being new repository, followed by import repository, new gist, new organization, new project. So new repository we've already discussed previously in this session. A repository is a place where you create your files for your project. It's basically a storage space, right? So your repository can directly interact with your Git, right? So the new repository option will allow you to make files, a repository, to your GitHub account, right? The Git, on the other hand, the tool that which we use to make local repositories in our personal computer, can be directly pushed on. The local repositories can directly be pushed onto your GitHub account. So that's what the new repository button allows you to do so. But the new project, on the other hand, is a place to track issues, features, and other tasks that are related to the code within the repository. You can also connect with the DevOps build and deploy process, assign people to tasks, and so on by using this button. That is the new project button. So the difference between the new repository button and the new project button is that projects in GitHub are only a part of GitHub, but not Git. But the new repository option is a part of GitHub and Git. So that's the main difference between new repository and new project. I hope that's clear. So the next button will drop me down some interactions that I can make with my profile. So if I click on this your profile option, it will redirect me to a page where I can edit my profile. I can really create my identity using this page. So here, if I click the edit profile, I can add a bio about myself. I can add the company in which I'm working in. the location at where I am, the website, Twitter username, etc. All of that I can add here, all of the information about myself. I can also view the repositories I'm working on currently, or the repositories I've worked in the past, projects that I'm working on, the packages, and the entire contributions I've been making on GitHub from the last year. So basically, it allows me to build an identity, or it'll help me build my profile on GitHub. So I hope that's clear. Now, if I click on this button and if I want to sign out from a profile, I can simply scroll down and click on the sign out button here, and this will sign me out of my account. So that's all for getting started with GitHub. These are the basics on what GitHub is and what each of the button and options really do. Now, if I want to move back to the main page of my GitHub profile, I can simply click on this Octocat. That's GitHub's logo. So I'm just going to click on this Octocat logo, and here I'm back to my main page. Now, before we move on and work on the different operations and options within GitHub and learn different things about GitHub, I'm going to give you a brief overview on how to download the desktop version of GitHub. So I'm simply going to search for GitHub Desktop on my search engine, and I'm going to click on the first link that's available on this page. Now I can simply click on this button that says download for Windows 64-bit. That's compatible to my current version of my personal computer. If you have a Mac, you can simply click on the Mac version and download it to your desktop. But as I've already mentioned previously that we're going to work on the website version, so I'm going to simply switch back to this. Now let's quickly move on to the next part of the session. Create a repository. So firstly, let us understand what a repository is. It is simply a storage space for the correct project that you're working on. GitHub is a very popular central repository that allows you to share your files, whereas Git allows you to create local repositories that are present on the system you are working on. So you can basically push your local repository into GitHub and share it with other collaborators via the central one. Now that we know what a repository is and how it works, let's go on to the demonstration part and create our first repository. So you can do this in two ways. Either you can click on your create repository button that is present on the left side, or you can, as I've already mentioned in the previous part of the session, you can click on to this plus icon and you can click on the new repository option. So this will redirect you to a page that says create a new repository. You can add your repository name. I'm going to name my repository as Edureka, and it's available. All of your repository names must be unique from one another to identify them easily. You can also add a description, which is optional. I'm just going to add the description. This is my first repository. And a description allows people or other collaborators to understand what your repository is all about. But as a good developer or a good programmer, you would definitely want to add a description and give an overview of what your repository is all about. There are two options now available that says private or public. Now you can choose your repository to either be public or private. So the private one lets you decide who can access your profile, whereas the public one lets anyone view and access your repository, but you can choose who can commit to it. That's the difference between public and private repository. I'm going to let my repository be public as of now. Now, if you scroll down, you can see that you can initialize your repository with three options. The first one being add a README file. The second one being add a git ignore file. You can always choose add a README text file to your project, which often contains information about the project and other necessary details the user must be aware of when he or she is accessing that particular project. Now, I want a README file for my repository, so I'm going to click on this button here. That's going to check it. The next option is add a .git ignore file. So this file will let you ignore a list of files when the user is pushing files to GitHub. That's what this option really does, but I'm going to let this be unchecked for now. For your repository to truly be open source, you will need to license it, so others are free to use, change, and distribute the software. You can simply click on choose a license option and pick the required license for your project. There are several licenses like MIT, GPL, Apache License 2.0, BSD, etc. But for this repository, we don't really need a license, so I'm going to untick this too. And now you can see there's a piece of information that says this will set master as the default branch, but I'm going to ignore this for now. I'm going to explain about branches later on in this session. So this is all you have to do to create your first new repository. You add a name, you choose a description, you add an optional description, you let your repository be either public or private, and you initialize your repository with either of these three options. And I'm simply going to click on my create repository option. Now this will redirect me to a page with all the information and the files that are currently present in my repository. You can see here my repository name is present here with the optional description that I gave. And the number of files, currently we have only just one file, that's the readme text file, and that's present here. So this is all we have. Congratulations, you just created your first repository. Now you can see there are some options that says issues, pull requests, actions, projects, wiki, security, etc. We don't have to really talk about all of these right now. We will just learn about one option that says code here. So this is really important. If you click on this button, you can see that there's a link that is available here, an HTTPS link. So if you copy this link and paste it on your Git terminal that's present on your computer, you can download this entire project directly to your local system. So that's what the link is for. I hope that's clear. And the next option that says open with GitHub Desktop will allow you to open this entire repository in your GitHub Desktop version. And you can also, the last option that says download zip will allow you to download this entire repository in the form of zip files. So all of your project files will be within that zip file. So that's all you have to really know about your repository. And I'm going to click on the README text file that's available. It will take me to another page with some extra information about that file. You can see currently we have 2 lines and the memory space that is allocated to this file. So we currently have 2 lines, that is Edureka, and this is my first repository. And you can also see the number of contributors to this project. That is just one, that's just me for now. And you can view the history of the commits or the changes that have been performed in your file. So we'll come back to that part later on this session, but you can move back to your main page of this repository by clicking on the name button here. So Edureka is the name of my repository, so I'm going to click on that. So now I'm back to the main page of my repository. Before we learn how to create our first branch, let us understand what branches are. Branches allow you to work on other features that can be included and merged with the master branch if required. So what is the master branch? The master branch is the main branch where your project resides on. So all of the changes, all of the activities that you do with your main project lies or is on your default branch that is named as the master branch. So what really GitHub allows you to do is it allows you to create additional branches. So on these additional branches, you can work on the other features or you can experiment with your project. And if you're happy with this, you can simply merge these features to your main branch, that is your master branch. This is what branches are really for. So they simply allow you to work on other features. That's what branches are. So let's move on to the demonstration part and look at how we can create our own branches. So now if you look on the left corner, you can see a button that says master. So currently we're on the master branch, and there's only one branch, and the master branch, as I've already mentioned, is the default branch. So when you create a repository, you're automatically creating a master branch. So this is where your project will be residing on. And now if you want to create another branch, say let's name this branch 1 branch. So this is what I want to name my additional branch. I'm simply going to name it and I'm going to click on the enter button. So it will redirect me to a page. So this is the exact replica of your master branch. And you can work on this branch. You can work on any other feature, or you can add something, you can remove something, you can really experiment on this branch. And if you're happy with this, you can merge back this feature or the experimentation that you've been working on to your master branch, right? So you can see there's a README text file. It's exactly the same. There's the name of your repository, the description of the repository. You can click on the README text file and everything's the absolute same. You can quickly switch back to the main page. But the only difference is that you're currently on a branch named branch 1 branch. You're not on your master branch. Now, if you want to switch back to your master branch and work on it, you can click on this button and you'll find the master here. You can click on that and it will take you back to your master branch. Here you can work on your project. So there are currently 2 branches. You can see that, and everything's normal. Everything looks simple. That's all for branches. It's really easy. I hope it's clear. So you can look for branches here on this bar here that's present here. You can also create new ones. in the same option. So that's all for branches. Let's move on to the next part of the session. Make a commit. Now, what are commits? Commits simply record changes to one or more files in your branches. So basically, they save the changes that you're making in your project. Git always assigns each commit a unique identification, which is called SHA or hash, that identifies the specific changes. So for any changes are made to your project files, you can simply go back and look at the version history or the history of each commit you've performed on your project files. So that's what really commits are all about. It's extremely easy. Let's go ahead and make our first commit. Now I'm going to switch to my branch 1 branch and I'm going to make my first commit. I'm going to click on my readme text file. That's the only file currently in our repository. So we'll make the change in the readme text file. There are 3 really important icons that are present in the right corner, as you can see. The first one is a PC icon that says open this file in GitHub desktop. So if you click on this file, this entire file will open in your GitHub desktop version. The next one, that is the pencil icon, will allow me to edit this particular file. That is my readme text file. And the third icon is a bin icon, which will allow me to delete this file. Now, what we'll be working on is the pencil icon. That's the edit this file option. I'm going to click on this and I can simply view a space or a file that will allow me to make changes to my readme text file. I'm going to add another line here that says this is my first commit. This is what I want to add to my readme text file. And if I want to preview the changes, I'm going to click on this preview changes button. You can see that this is my first repository. This is my first commit. This is my first commit is the additional piece of information that will be adding to my readme text file. And it's highlighted in blue, so we know that that's the additional information. I'm happy with this change. I'm going to switch back to my edit file. I'm going to scroll down. And if I want to add a description about the change that I'm performing to my file, I can do that. A good programmer would always add a description to the change that he's making to the project file. So other collaborators, when they view the commit or they view the change, they can read the extended description and understand what the change is about. So that's a good habit that you must follow. But as of now, we're not going to do that. So I'm going to leave this blank. As you can see, there are 2 radio buttons that are currently available. The first one says commit directly to the branch 1 branch. This will allow me to make the change or save or make the commit directly to my branch 1 branch only. So the change that I'm making currently is only implemented to my branch 1 branch. The second option allows me to create a new branch for this particular commit and start a pull request. We're not going to talk much about this option right now, but the first option is extremely important. So we'll let this be stuck on to the option that says commit directly to the branch 1 branch. And I'm going to click on the commit changes options. And this will simply implement the entire change to the file. You can see that the change is implemented. The additional piece of line that says this is my first commit is added to my readme text file. Now, the interesting part is if I switch to my master branch, the change is not implemented in my master branch. So the change is only currently present in my branch 1 branch. And now if I want to view the history of the changes that I've made, I've already mentioned in the previous part of the session that the history button will allow me to do so. So I'm going to click on this history button and you can see that I made my first commit 23 minutes ago and I made my new commit 41 seconds ago. And there is also a hash number, unique hash identification number that allows me to distinguish between both of these changes. So all of my commits that I'll be making on this branch will be available here. So that's the main point of a version control system, isn't it? Understanding and keeping a record of all the changes that we're performing in our files and our projects. So this gives full justice to the word version control. So that is what GitHub is all about. Now that we learned how to make our first commit, let's move on to the next part of the session. Open and merge pull requests. So what are pull requests? Pull requests let you tell other developers about changes you've pushed to branch in a repository on GitHub. So once a pull request is open, you can acknowledge and review the changes with collaborators and add follow-up commits after which your changes are merged into the base branch. So there are 2 ways to create a pull request. The first one being pull request from a forked repository, and the second one being pull request from a branch within a repository. currently in this demo, we will work on the second one, that is pull request from a branch within a repository. Now I'm simply going to switch to my demo part. Okay, now currently I'm on my master branch. I'm going to click on this pull request option that's here. Now it says branch 1 has had recent pushes 3 minutes ago, compare and pull request. I'm not going to click on that. I'm going to simply click on the new pull request option here. So this will allow me to compare the changes. There's a base branch and a compare branch. The base branch is the master branch, and the compare branch, I will compare my master branch to my branch 1 branch. So this notification says that the merge between the branch 1 branch and master branch is definitely possible. So it's a green signal. So if I scroll down, I can view the difference between both the branches. So the left-hand side indicates the information that is present on the master branch, and the right hand indicates the information that is present in my branch 1 branch. Plus sign indicates the additional information that is present in my branch 1 branch. I'm happy with this. So I'm simply going to scroll up and create the pull request. I'm going to click on that. I can also leave a comment and I can preview the change. That's not necessary for now. So I'm going to go ahead and create the pull request. Now this will redirect me to a page. So this page says that the pull request has been opened. And now I can choose to merge this pull request. That is, I can merge the branch 1 branch to my master branch. So it says this branch has no conflicts with the base branch. Merging can be performed automatically. And that's good news, right? So I'm going to click on merge pull request, and I'm going to confirm my merge, update my readme text file. I'm happy with that, so I'm just going to confirm it. Now it says pull request successfully merged and closed. You're all set. The branch 1 branch can be safely deleted. I'm not going to delete the branch. I'm going to compare both of the branches and see if my master branch is exactly the same as my branch 1 branch. So I'm going to click on this Edureka. I'm going to go to my main page of my repository. So my master branch has the additional piece of information that says this is my first commit. Now if I switch to my branch 1 branch, it has the exact piece of information. So the information that was present in my branch 1 branch has been successfully implemented to my master branch. So that's all for the pull request part 2. We've reached the end of the demonstration part. Now let's quickly look at the case study of how Microsoft implemented GitHub. I'm pretty sure most of you have heard of Microsoft. Microsoft Corporation is an American multinational technology company. It develops, manufactures, licenses, supports, and sells different computer software, consumer electronics, personal computers, and other related services. So initially, Microsoft was against the use of the open source because they held very tightly to the internet protocol. They were completely hesitant to adapt to this new concept of sharing code to the entire world. But in 2010, they rethought this entire scenario, and now Microsoft is one of the biggest contributors to open source. Today, about 2,000 to 25,000 Microsoft engineers maintain TypeScript, .NET, Windows Terminal, DARP, Helm, and more than 1,000 other open source projects. So first what they did was they released new processes in measured containment. But later on, they released only licensed software. So here, developers can learn from the company's source code, but they couldn't really build on it. Eventually, the stigma died, and now even closed code like .NET is open source under an MIT license. Teams realize that they need to accept contributions to get feedback and learn from other developers. To organize and understand this approach, Microsoft created their Open Source Programs Office, which enables distribution and centralization of knowledge. So the OSPO provides the resources and maintainers to manage thousands of repositories and contributors effectively on GitHub. Even though Microsoft invests in its tools, they expect other individuals and organizations to lead the way. Microsoft believes that GitHub's value isn't in any one feature, but its entire community. GitHub is the place to collaborate, it's where everyone is, and where most of the entire world's open source is already happening. It's not just a feature, but the whole thing.
So guys, let's first talk about why we need continuous integration. Let's talk about a scenario where we are not using continuous integration. Now, when we work in a development team, there are multiple developers. Now, all the developers work on different components for a project or for a code. A developer A may be writing code thinking scenario, let's say Python 1.0, and developer B will be writing code thinking of a scenario 1.2, 1.3, and so on. One of the biggest challenges that we face in an industry is how to make sure that all the developers' codes get collaborated and that we are having properly release getting deployed. That is the biggest challenge in the industry. Now, another challenge that most developers fail is debugging. Now, whenever you write a code, there are a lot of bugs and issues. Now, the code is often written thousands and thousands of lines. Now, if you don't have any proper continuous integration mechanism or a packaging mechanism, you'll see it takes days, even weeks and months to debug your code to make it 100% bug-free. Now, that is a challenge that really makes the development process very slow. So, how to test the code? Now, testing used to be a monotonous task. Now, there are teams used to spend months of a life cycle to make the code, complete the test code, and make sure it's bug-free. Now, what used to happen is, guys, two things. One is you are not able to deliver on time, and secondly, business never see value coming out of the IT. If businesses see IT not adding value, IT is not delivering product on time, they will start rethinking and giving a second thought. Why do we need to invest so much money in the IT industry or in the IT software? These things were hampering big time in the development and release of modern day deployment software cycles. In the modern day world, we want to make sure our deployment cycles are robust, we're able to get the main need of the market and deploy the product as soon as possible. But with this approach, we're not using the CI tools. It used to take 6 months to develop a product, deploy a product, and make it bug-free. Now things change drastically when we start using continuous integration. Now, using continuous integration, we can deploy codes at the quickest. Amazon, for instance, deploys code every 11.6 seconds. Now, how is that possible if you ask? It's because they are using the continuous integration mechanism. Using CI tools like Jenkins, where we can automate the process like building, packaging, deployment, testing, and so on, so that we can do all these things with the click of a button in a matter of seconds. CI process helps us to deploy multiple releases parallelly. Now, in one day, we can do thousands and thousands of releases without impacting our environment and making sure these releases are in line with our requirement. The CI tool has an awesome notification mechanism where it notifies instantly of any success or failures happening, so that if I have to debug the code or troubleshoot it, I will know exactly at the pinpoint location where it is failing. You can do multiple notification management mechanism like an email, an SMS, any ITSM tools. Now all those modern ways of notification are possible using the CI tools like Jenkins. Now we integrate these CI tools like Jenkins with modern day build and packaging tools like Maven and Gradle, so that we can automate the common problem which developers spend most of their time on. Now, developers spend half of their life cycle like packaging their code, code review, code deployment, unit testing. Now, all those things can be automated and can be done with the click of a button using these CI tools. Now, what is continuous integration? Now, we have talked about how it helps to save time, how it helps to save the energy, and how it helps to make release more frequent, and it helps us to streamline the process. Now, what actually is continuous integration? Now, if I go traditionally, continuous integration is basically, you can say, a process that helps us to combine or make smoothen the automation of tasks like compiling the code, doing the testing, and deploying the code into our life cycles. So how does this continuous integration work? So developers who works on projects generally commit their code in any version tools like GitHub, GitLab, Gitbucket, SVN, etc. So using continuous integration, we pull the code from the version control system like Git, for example. Now we automate the process like code compiling, code testing, code review, and then finally deploy the code in the lowest lifecycle environment. You can say continuous integration is sort of a development practice where developers pull the code from the version control system and make the code deploy in the lower lifecycle environment. Now the beauty of using these CI tool is we can automate the process in such a way that whenever developers make a new commit or a new change in the version control system tools, we can create a sort of a pipeline, and the pipeline automatically picks the code from the VCS tools and compile it and then deploy the software. Another good thing about it is it does not require any human intervention. So once I have set up a pipeline, then I don't need to worry about running the code again and again or making any changes. It automatically happens in a fully automated process, as I mentioned a while back. Now we can use the process whenever a new commit happens, or you can run it on a scheduled basis or something. Now CI or continuous integration was first time proposed in 1991 as part of the Extreme Program concept. At that time, it was not adopted so well, but in the modern day industry, it has become the bread and butter of smoothing up release or for our development process. In a modern day world, continuous integration can be say as a practice of merging all developers, working copy to a mainstream where you can develop and deploy the code multiple times in the same day with as many changes as possible. Now there is no limit of how many lines of code. It can be tens and thousands of lines of code which can be compiled multiple times throughout the duration. Let's see a case study where we try to see how things change for an organization after it adopted to the CI or continuous integration mode. Here we have picked up an example of Adobe to see how it helped in the development process. Adobe realized at some point at the time that they have not released very frequently. When this happened, their market percentage share was down as they were not following the continuous integration approach. Now they were using the native method of compiling the code, debugging the code, testing the code, because of which they were noticing that it used to take up to 6 months release updates. Now 6 months was a long duration, whereas their competitors were releasing very frequently, which was helping them to capture the market share. Adobe decided some point at a time that they need to change their software development and deployment strategies, and they tried to adopt the continuous integration mechanism. Once they adopted the continuous integration mechanism, they found that the response time was a lot better and a lot faster. Now they were able to deploy the updates more frequently with every time a change was made by a developer or new release was being released. And it helped them reduce the response times, and they were 60% more faster. The development teams were getting more effective, and they were able to really deploy losses far more in a better and structured way than what they were doing without using CI. You can see how CI helps industry. Amazon is the best case scenario. Amazon in modern day scenario deploy codes every 11.6 seconds, almost 5 times every minute. Now this is all possible using the continuous integration. Now what is Jenkins? Now we've talked about what is CI, we've talked about why we need CI. Now let's talk about what is Jenkins and how does Jenkins fit in this particular picture. Now Jenkins is an open source automation server which helps us to automate the process of development relating to testing, deployment packaging, and others. It is a server-based system that run on software, Apache Tomcat. Now it supports VCS store like Git, Bitbucket, etc. It also supports build automation tools like Apache, Maven, and it helps to make and facilitate our continuous integration and continuous delivery process. Now Jenkins was first released in the year 2011 and it's completely open source software as a part of the MIT license. Jenkins is a plugin based profile. In Jenkins, you have got plugin which basically used to interact with different tools and components. In Jenkins, plugins are primarily released in language other than Java. Plugins are available to integrate Jenkins with most version control system tools and most databases. Using these plugins, we set up purposes, for example, unit testing. Now you can do compiling, you can do packaging. Now you can create some reports. Now you can do some logging. Now all these things are possible using plugins and Jenkins. Another important component that we've talked about in Jenkins, apart from plugins, is Jenkins notification, which we call it as Mailer. Using Mailer, guys, we can configure email notification. For instance, you can configure scenario. For example, you want mail notification when build is successful. Now all these things can be done using Mailer as the Jenkins component. Another important component in Jenkins is the SSH agent. Jenkins also follow a typical master-slave topology. Now, why do we need a master-slave topology and a CI tools like Jenkins? Now, when you work in the organization, we have got multiple teams which you want to build and deploy their own pipeline or deploy their own software project codes. Now, teams don't want the piece of code to be run on a server which is owned by some other teams. So what we can do is we can set up a master-slave topology where Jenkins may run on a server X. But you can connect multiple other servers which will act as a slave. So when you are deploying a code, executing a pipeline, you can run those codes on those XYZ servers. Now this is the beauty of using Jenkins master-slave topology. Now another good thing about Jenkins is Jenkins can be deployed on any operating system. In Jenkins, you can use in a Windows mode, a Linux mode, a Mac mode. Now all these Jenkins jobs can be deployed on any operating system. It is not at all dependent. Now both master and slave needs to be of the same operating system. Another important core component of Jenkins call is JavaDoc. This is our plugin in Jenkins which basically is a part of Jenkins core that helps us to publish results like build action, build directory, what is the expected build output. All those things that we see in Jenkins, they all are happening using JavaDoc. Now let's talk about security injection. Apart from that, Jenkins have other sorts of authorization like project-based strategy, metric-based authorization, which help us to make Jenkins more secure. We'll talk more about this when we talk about the Jenkins overall. So as you can see on the diagram, Jenkins is pulling code from the source code control system like Git, Bitbucket, etc. To start deploying it in Jenkins, we have got a notification management system using Mailer, where if the build is successful, we get a WAR file or a zip file. We can define how we want the build to be created, and if it is a failure, it will send the notification management to a developer that something happened wrongly with the specific code lines and you need to rectify your codes. Now that is the beauty of using Jenkins. So Jenkins is still the bread and butter in the industry. There are some Jenkins competitors also in the market like GitLab Jenkins and some others. But by default, Jenkins is the to-go tool for the CI industry. So far we've talked about Jenkins. Now let's talk about what is pipelining in Jenkins. Now let's say I want to deploy a code. The code may have certain steps like first step I'm building the code, second step I'm compiling, then code reviewing, then packaging, then deploying. So how do I automate a combine of all these steps which can be executed in one go? Now to deploy all this scenario, we've created a delivery pipeline. Now pipeline is nothing but it's a combination of different steps or different tasks that we need to perform in order to deploy our code. Now using a pipeline instead of doing this task or code deployment manually, we combine them and deploy them as a sort of one common approach of a delivery pipeline. Now there are multiple ways on how you can create a pipeline. The two most common ways or common approaches of using a pipeline, as you can see from scenario, a declarative approach. And the second one that is used in the industry is a scripted approach. This particular is an example of a Jenkins pipeline script. Here you are saying we are first doing a stage called build stage, where we will be combining multiple tasks. Like first we are using Java, then we are printing something called echo hello pipeline. Then we are using Maven as the build automation tool and try to deploy a package. And then we are doing a shell script output of what all things are present in that particular directory structure. This is a typical example of syntax of how to create a pipeline in Jenkins. Now let's talk about the two predominant pipelines that are used in the IT industry, scripted and declarative. Now let's talk about what is scripted and declarative and how they are different from each other. A scripted pipeline is a traditional Jenkins pipeline approach, and a declarative pipeline is a modern day pipeline approach that is used in the industry. In a scripted pipeline, the syntax was first strict, while in declarative pipeline we use something called as groovy syntax. When you use a declarative pipeline, you can get a code from any version system tool like Git. You can create something called as Jenkins file, and you can download Jenkins file from a virtual constant tool, and that can be used to run your Jenkins code. When you use a scripted pipeline, you define a code something called as a node block. But one declarative pipeline will define a code in a pipeline block, as we can see in the previous example. Now let's talk about what is Jenkins file and how it can be used. Now Jenkins file are like a text file where you define your entire structure and syntax of your Jenkins. You know only how to download the file, and in particular, you can just give the part of your Git repo. If it is true, then get the credential, the private repo, and it can pull all the contents from there and just execute your code. It is a modern deployment mechanism that we use when we work with a Jenkins pipeline. Using Jenkins pipeline, we use certain things which help us. Let's talk about this. First is code review. Now you do a Jenkins pipeline, you can easily review your code. Your code can be reviewed by multiple developers before being executed. Now how that works is in Jenkins file, they are stored generally in a version control tool like Git. You can put something called as a pull request for a code review. Now different members of your team can review the code before you actually pull the Jenkins file and deploy it. Now you can do an audit trail or refer to as a long audit. You can log each and every step's output that is being executed as part of the Jenkins file and can see what is happening when the Jenkins file is getting executed. It's sort of like a verbose log. Then you can find a single place to store all your data or all your outputs. You don't need to have developers scattered here and there and writing their own codes for executing a Jenkins pipeline. Whole organization can approach a Jenkins file methodology where code can be stored in a VCS tools, and from there the code can be downloaded and can work as a single source for your entire pipeline. Now let's talk about the Jenkins workflow in particular. How does Jenkins workflow work? Jenkins workflow always start with a version control system, or you can say a source code repository. Multiple developers collaborate and they put their code in a source code system like Git, from where Jenkins tries to pull the data from that source control system. For your system, there is no mandatory or the source code needs to be Git. It can be Bitbucket, SVN, whatever your organization uses with Jenkins server. Now we execute tasks like build, deploy, compiling, packaging, code reviewing. Now all these things happen using Jenkins server, where your Jenkins actually installed was running. Now Jenkins server can be any operating system. It can be a Windows machine, Ubuntu machine, Linux machine, or a Mac as well. It can be any operating system of today's modern world availability. Using this Jenkins server will execute our different tasks and scenarios. In Jenkins server, we use the mail functionality for the feedback mechanism. We notify developers the commit or the code deployment successfully or it is a failure. It also has some challenges. Now what can be done using the feedback mechanism? Possibly using the Jenkins server. So using Jenkins server, we always first deploy the code on a lower lifecycle environment. That is recommended standard practice. So what we do is we first deploy a QA server on a testing server, and once the code deployment is successful on the lower life cycle, then we go ahead and deploy the code on a production server. That is how the entire Jenkins workflow, mainly particular, interact first. Now guys, let's talk about the Jenkins installation and how to install Jenkins in a machine. As you all know, Jenkins by default run on 8080. So please make sure that if you're using any VMs in your organization, the port 8080 firewall settings are open and configured so that it can be accessible. I will get into some of the prerequisites required for installing Jenkins post, which will go ahead and install Jenkins on a Windows box. Now there are a few first configuration that needs to be done, and I'll be covering those as well. So once I have Jenkins installed and configured properly, I will get into the user administrative part, then create few users, and I will get into some of the plugins for setting up various kinds of access permissions for these users, and I also put in some of the freestyle jobs. Freestyle job is basically nothing but a very simple job, and I will also show you the powerfulness of Jenkins by scheduling this particular job to run based upon time schedule. Then I will also connect Jenkins with GitHub. Now GitHub is a source code repository where I've got some repositories put up there. So using Jenkins, I will connect to GitHub, pull up a repository that is existing on GitHub onto the Jenkins box, and then run a few commands to build this particular repository that is pulled from the Jenkins sending out emails. Now it's a very important configuration of Jenkins or any other continuous integration server for that particular matter. Now, whenever there is any notification that has been sent as a part of either build going bad or by being good or building propagate to some environment and all these scenarios, now you will need the continuous integration servers to be sending out notification. So I will get into the bit of details of how to configure the Jenkins for sending out emails. Now, I will also get into the scenario where I will have a web application such as a Maven-based Java web application, which will be pulled from the GitHub repository, and I will deploy it into the Tomcat server. Now the Tomcat server will be locally running on my system. Eventually I will get into the other very important topic, which is the master slave configuration. It's a very important and pretty interesting topics where distributed builds is achieved using a master slave configuration. Now all this can be very easily based up using a plugin. So this is what I'm going to be covering as a part of this tutorial. Now, Jenkins is a web application that is written in Java, and there are various ways in which you can use and install Jenkins. Now, I've listed the popular 3 mechanisms in which Jenkins is usually installed in any system. Now, the topmost one is a Windows or a Linux-based services. So, if at all you have a window like the way I have, and I'm going to use this mechanism for this demo, so I will download the MSI installer. So, whenever you start as a service, it goes out and nicely install all that is required for my Jenkins, and I have a service that can be started or stopped based upon my needs. Any flavors of Linux is one of many other ways of running Jenkins in downloading this generic WAR file, and as long as you have a JDK installed. You can launch this WAR file by the command opening up a command box prompt or shell prompt defer to later on Linux box specifying jar and the name of this WAR file, typically bringing up your web application. And you can continue with your installation. Now, the only thing being, if at all you want to stop using Jenkins, you just go ahead and close this prompt, even into a Control C, and then bringing down this prompt, and in Jenkins server, And then you also have the other older versions of Jenkins where run popularly using this way, in which you already have a Java based web server running up and running. So you kind of drop in this WAR file into the root folders or the HTTP root folder of your web server. So Jenkins will explore and kind of bring up your application. All user credentials or user administration is all taken care by the Apache or the Tomcat server or the web server on which the Jenkins is running. This was a very old way of running, but still some people use it because if they don't want to maintain two servers, now if they already have a Java web service which is being nicely maintained and backup, now Jenkins can't run a test to it, alright? So either ways, it doesn't matter however you're going to bring up your Jenkins instance, the way we're going to operate Jenkins is all going to be very, very same or similar, but the subtle change in terms of user administration. Now, if at all you're launching it through any other web server, which will take care of the user administration. Otherwise, all the command or all the configuration or the way in which I'm going to run this demo is going to be same across any of these installation. All right. As I mentioned earlier, Jenkins is nothing but a simple web application that is run in Java. So all that is needed is Java, preferably JDK 11 or 17 with a 2 GB RAM, which is a mint RAM for running the Jenkins. And also, like any other open source tool sets, when you install JDK, ensure that you set in the environment variables. Now Java home to point in the right directory. Now this is something very specific to JDK. Now, but for any other open source tools that I've installed, there is always a preferred environment variable that we got to set in, which is specific to that particular tools that if you're going to use. This is a generic thing that there is for you to know. Now for any other open source project, because the open source project discover themselves by using the environment variables. So as a general practice or a good practice, always set these environment variables according. So I already have a JDK 17 installed on my system, but in case you do not, what I will recommend is just navigate to the browser, to the Oracle homepage, just type in your search for install JDK page, then you'll have the accept the license agreement. Now what I will recommend is just navigate on your browser to the Oracle homepage and just type in your search install JDK. Now you're gonna navigate to the down here and install the 64 installer, that is the .exe. Now let me show you once I've installed what I've done with regards to the path. So if you get into these environment variable, so I have just set in the Java home variable. Now you can go back to your this PC, go to C programs, go to Java, and then copy this part, then click in the environment variables. I'll select the first one, that is the edit the system environment variable, and we click on the environment variables and we'll set a path here. As you can see here, Java home, and we'll go down here on the path. So this is the path for your Java home screen. So simply click on edit and click on new, and we will just paste the path which we have just copied from the install.exe Java. So I've already installed it, as you can see there, C program file. So I simply click on OK. So the only difference between the system variables and the user variables for daemon is this is control the whole system of the JDK, the system variable. So we want to edit in the system variables. So the path I've been changing here is in the system variables. All right. Now the home variable is where I have the SQLs and program friend of the JDK 17. Now you see this is my Java home. All right. Now one thing to do is ensure that in case you run Java or Java C, for a command, you ensure that you also add the path into this path variable, right? So if you see somewhere, I will say there you got the colon program files. Now you click on that and I'll show you the bin as well, which I've copied and pasted here as well. Okay. So simply just go back. So that's how you get the bin. Copy this path and paste it here, which I've already done it. So I'll just simply click on OK, OK, and OK. Now let me minimize the screen as well. So the next thing we need to do now is go to CMD to check if your Java has been installed on your system. So you simply type on Java space / version, and you can see I already have Java version 17.0.5 installed in my system and it's up and running. So as you can see the runtime environments, and it's a 64-bit server. This is a VM virtual machine. Okay, so as you can see, Java is installed in my system and is up and ready. So the next thing we need to do now is install Jenkins. I'm just canceling that out. Type in jenkins.io. Now, as you can see, this is the homepage of Jenkins. All right. So you can even read the documentation, or you can simply click on download. Will take you to this page. Now here you can see the hardware and software requirements, then what packaging is required for downloading the installing Jenkins. So this is the part for, on the left hand side we have the LTS, and on the other side we have the, which is a more stable, and on the right hand side we have the regular weekly releases. So we'll definitely go for the stable LTS download, which is a long-term support, which is released every 12 weeks, whereas the regular releases changes weekly. So I'll be going ahead and scroll down and click on window. So as you can see, there are different parameters where you can have on Dockers, then you have Ubuntu, then you have the CentOS, Fedora, or the Windows, like I'm going to install in this case in this demo. Then, but we have different aspects as well, like the FreeBSD, the CentOS, Mac OS, etc. So as you can see on the first stop, we have the .var. We can even install that and unzip that. But in this case, in this demo part, we'll simply click on Windows. So go on ahead and click Window, guys. Now you can see the download has started. So we just wait a few seconds until it's done installing the MSI. And as you can see, it's done. So this is my download in Jenkins instance. So what I'll be doing now is simply click on next. Now, as you can see, guys, on top here, it's written the Jenkins run on localhost 8080. So keeping that in mind, click on next. As you can see, this is where our Jenkins is installed. That is in C and program files and by the name Jenkins. So you can always change this location where the Jenkins has been installed. But in this case, I'll rather keep it on the C drive itself. So the next thing you need to do now is we'll run server as a local system so that we don't have to put any administrator or the password. And so the next step now is we test the port. So as you can see, you got a green tick mark. So we'll click on next. Now you can see here that it has failed because there is no compatible Java version 11 or 17. But as you can remember, guys, we have already installed Java 17 and we have already verified that we're using the command prompt where it has shown us the version Java 17. So what you need to do is simply click on change and select the Java 17 from Java 8. So simply click on Java 17, JDK 17, as you can see, click on next and click on the install part. Done and dusted. So I've already told you that Jenkins run on the localhost 8080, right? So we're gonna go localhost 8080 and hit on enter. Now, as you can see, please wait while Jenkins is getting ready for work, right? So this will take a few minutes and then you'll be having to provide the credential of the administrator. All right. So just give it a few minutes while it's starting up. All right. Now you have to provide the administrator password, right? So you can go ahead and go down out here. You can see the password is in the C and goes to the program data, then Jenkins. Then we have a .jenkins, then a secret, then you'll find the initial admin password. So we need to head out there. So what we need to do is we'll go down there. So I'm just going to minimize the screen now, minimize it once again. And as you remember, we go to the C. So you can see right where it is. I'll just show you, minimize the screen here so you can see and do it along with me. So you can see this in PC, then scroll down to C disk. Okay, this thing popped up, sorry. It's in this, so you have a program data, right? As you can see here down, there is no program data, right? So what you need to do is it's in the hidden file. So what you need to do now is click on the three buttons and view, click on show and click on the hidden items. Now let's see if it's there. Scroll down, program data, you can see at the last. Yeah, simply click on that, double click on it. As you can see, then we have to go to the folder name as Jenkins. Yeah, you can see on the top, Jenkins and .jenkins. Then we need to search for secrets. There it is, folder. And as you can see, there's an initial admin password. Now you simply click on that. We'll try with the notepad so we can copy. So simply copy that and paste it in the administrator password and click on continue. So in this case, I will not save it in my computer or system. So there are two installation plugins available, which is custom by Jenkins. One is they have suggested plugins, and the other one is you can select the plugins which you want to be installed. So in this scenario, I'll simply click on the install suggested by the Jenkins. So what happened is the plugins are all related to each other. So it's like the typical RPM kind of a problem where you try to install some plugins and got a dependency which is not installed, and you get all those issues. In order to get rid of that, what Jenkins recommends is that there are a bunch of plugins that is already recommended and they are good to go, right? So just go ahead and blindly click on that recommended by the plugins, which is suggested or custom by the Jenkins. And as you can see, these getting started process is going ahead. So it'll take a few minutes depending on your internet speed or on the system. Now you can see all these plugins are installing it for you. So it will take a few minutes time. So let's just wait till we get all the plugins installed in a system properly. So this is a good combination to kind of begin with, and keeping that in mind, Jenkins need a lot of bandwidth, right? Now in terms of network, so in case you know your network is not so good, it'll make for a few of these plugins will kind of fail, and these plugins are all unavailable on openly or mirrored site, and sometimes some of them may be down. So do not worry, in case some of these plugin kind of fail to install, you get an options to kind of retry installing them, but just ensure that you at least at the most 90 to 95% of all of these plugins are installed without any problem. As you can see, we are almost there. It's around 60% to 70%. Now once all these plugins are installed, now my plugin in the installation is all good. There's no failure in any of the plugin. So after that, we've got to create this first username, that is the first admin user. So you need to give in the username, then the password, then you have to confirm your password, give it your full name and your email address, right? So we'll start it by giving the username. I'll keep it plain and simple. Now you got to remember these password and the confirm password, because if you kind of lose or you don't remember the password of the Jenkins, it'll be really hard to get back your account. So try to keep it as simple as possible, and keeping in mind that you have to remember the password, because getting back this account will be really difficult. All right, so I'll be putting the password as well. Give it my full name. Okay, my A is small, and go to the email address damandla.namare@edureka.co. All right, so once it's all done, so just simply click on save and continue. So click on never, don't want to save the password. And as you remember, I've told you by default Jenkins run on localhost 8080, right? So you can simply click this, or you can copy this, or just write save and finish. You can even copy this link, save and finish. Now start using Jenkins. All right, now that's kind of complete my Jenkins installation. As you can see, it was not that tough at all. Now the Jenkins is installed correctly. Now let me quickly walk you through some of the very minimal configuration that is required. Now these are kind of the first time configuration that is required. So, and also let me warn you, the UI is a little hard for many people to wrap their head around, especially the window guys. But if you're all a Java guys, you know how painful it is to write UI in Java. You kind of appreciate how the effort that has gone into the UI bottom line. It was a little hard to wrap your head around. It becomes like start using it, possibly you start liking it all right? So I will get into some of these important ones, something called as configuration system, or the configuration a system. This is something kind of put in your configuration to complete your Jenkins instance. Now few things to kind of look out for. This is the home. Now configure system is where you kind of put in the configuration for your complete Jenkins instance. Now a few things to keep a lookout is the home directory. All right, now this is a Java home where all the configuration, all the workspace, anything and everything regarding Jenkins is stored out here in the system message. Now in the system message, you can put in some of the message on the system. You can just type anything you want, probably show up somewhere here on the menu. Now the number of executors is a very, very important configuration. This just lets Jenkins know at any point in time how many jobs or how many threads can be run. So you can kind of visualize like a thread that can be run on this particular instance. As a thumb rule, if at all you're on a single core system, the number of executor you should be good enough in case at any point if there is any multiple jobs that kind of get triggered at the same time. Now in case the number of executor are less compared to the number of jobs that are out there to open up the new, so you don't need to panic, because they will get queued up and eventually Jenkins will be get up and running. So just keep that in mind that whenever a new job kind of gets triggered in the CPU usage and the memory usage. In terms of the disk, it's like a very high of the Jenkins instance. So that's something you gotta keep in mind, all right? The number of executors for my system is kind of a good label. For my Jenkins, I don't want any of these usage. So how do you want to use your Jenkins? This is good for me because I only have a primary server that is running. So I want to use this as low as possible. All right. As you can see, it's 2. Now this is usage. So I can leave everything to default. So what I want is I want this SMTP server configuration. Now Jenkins will be sending out some emails. What I've done here is I've configured the SMTP details of my personal email details. In case you are, in your organization, you want some sort of an email that is like an email ID that is set up for a Jenkins server. So you can specify the SMTP server details of your company so that you can authorize Jenkins to kind of like send out emails. But in case you want to try it out like I have configured my personal email ID, which is of the Gmail for sending out notification for the same TP server, will be the SMTP Gmail. So it's right as username as so we have used the SMTP authentication and then we give the password. Now you can just send out an email to see if at all this configuration works again. Now Gmail will not allow you to allow anybody to send out notification on your behalf. So you just have to lower the security level of your Gmail ID so that you can allow programmatically somebody to send out email notification on your behalf. So I've already done that. So let's see if this works. Let's test it again since I've entered the wrong password. Let's see if this works or not. And it has given me a password has not accepted. So now as you can see, since my Gmail has not been set up, so what you have to do is you have to lower your security level of your Gmail ID so that you can be allowed to test your email configuration. All right. So simply click on save. So now we're heading back to the dashboard. Now we should go to the global tool configuration. Now look at the scenario where Jenkins is a continuous integration server. Now it does not know what kind of a code base it's gonna pull and what kind of tool says is required or what is the code that is going to pull in and how it is going to build. So you'll have to put in all the tools that is required for building the appropriate kind of code that you're going to pull in from like a source code repository. So for example, in case your source code is a Java code, and assuming that you have because this demo, this is my laptop and I put all the configuration, JDK, everything on my laptop because I am a developer and I'm working on the laptop, but my country's integration servers will be known as a separate server without anything being installed on it. So in case I want Jenkins to like run on a Java code, and I need to specify the JDK location of this out there. So okay, since I've already have the JDK installed and have already put in the Java home directly or rather and the environment correctly, so I don't need to do it. So now if at all you want the Jenkins server to use Git, now as you know that Git is a command bash or the command prompt for running Git and connecting to any other Git server. So you will need Git to be installed on that particular system. Now Gradle and Maven, if at all you have some Maven as you want to do this in any other tools that you're going to install on your system, which is your continuous integration server. So you'll have to come in here and try to configure it. And in case you have not configured, then Jenkins will not be able to find these tools for building your task. So since I don't want to install anything, we'll go back to manage system. Now you can see the configure global security. You can see this an SSH server. Now what does this mean if you ask me? Jenkins own user database. So this is nothing but the security access control which is set to Jenkins own user database. So this mean is Jenkins by default it uses files system where it stores all the usernames which hashes up like these username that kind of stores them as of it. So as of now, Jenkins is configured to use in your own database, assuming that you're running an organization. So you will probably want to, have some sort of LDAP server, which will in turn have a control of your access to your Jenkins repository. So you will specify your LDAP server details, the root TN password, or the managed TN. So the LDAP, as you can see, or the LDAP, which the Jenkins itself will tune in for your specific servers. Now you have the manager DN, the manager password. Now all these should be filled, all these details should be filled in case you want to connect your Jenkins instance with your LDAP server or any of the authentication server that you have in your organization. But for now, since I don't have any of these things, I'm going to use its own database. That's good enough, right? So I'll simply the Jenkins own user database. So I will set up some authorization methods. So for now, let me not get into any of these details of this. And just be aware that Jenkins can be connected for authorization to an LDAP server, or you can have Jenkins managing its own server, which is happening as of now. Let me put in a very, very simple job. All right, so let's create a new job in this video. So simply click on new item. Simply you can add any item name here. So the most important here are the freestyle and pipeline. Now for the first demo, we'll click on the freestyle job and click on OK. So in the description, you can write anything in your description. This is an optional thing. So you can say this is my first job demo for. So in this demo, I don't want it to connect it to any source code for now. So I'm just going to leave it to none. Now we don't need to write any build environment as well. Now in this build step, we simply click on execute Windows on. So since I'm on the window box, I will say execute window bash command. All right. So what do you want to do? So let me just echo something. Echo hello world. This is hello. Welcome to my first demo job in Edureka. Then we'll specify the date and time as well. So put in date, colon as time as well. So you can see it's a very, very simple command. You just have to put an echo and we have something along with the date and time. So we'll keep everything as simple as possible. So we'll save this job. So once it is shipped, so you can see there's a build history. So once you have saved this job, the job name comes up here. As you can see, project first job. By mistakenly, I've written double T in my first job. Now as you'll see here, there's a builds history. So there is nothing as of now because I've put in a job. I have not yet run it. All right. So let me try and build it now. Now you can see there's a number, my first job. So you will see a date and you will see the time since I've clicked twice. So if I've come 1 and 2. Now if you click on this, now you can see the console output. Now if you click on this, now you can see this, and this is the output that is run. Hello, welcome to my first demo job in Edureka, along with the date and along with the time. Now if you see this, now if we navigate this, we go back to here. Now, as you can see, there's a folder created as jobs, right? So this is the directory what I was mentioning earlier regarding Jenkins home. If you can just open it up wider, you can see this folder jobs. So this as mentioned earlier regarding Jenkins home. So all the job related stuff, it's specific to this particular Jenkins installation is all here. Now all the plugins that I install, the details in each of those plugins can be found here, right? So the workspace is where the jobs that I've created, whichever I'm running would, there'll be an individual folder specific to the jobs that has been put up there. All right. So one job, one quick run. That is how it looks like. So the workspace is where all the jobs that I've created, whichever I'm running, would, there'll be an individual folder specific to that jobs that has been made up. All right. So as you can see, there's a first job that we have just created just now. So one job, one quick run that we have done. That is how it's look like. It's pretty simple. Now let's go back. So let us put on a second job. So we can go back to dashboard, click on new items and say second job. Let's get the spelling correct this time. Second, I wrote second first again. Second job, and I can put a semicolon here, underscore. Second job. We click on freestyle again. Click on OK, and you can say this is my second. So I just want to demonstrate the powerfulness of the automation server and how simple it is to automate a job that is put on the Jenkins, which will be triggered automatically. Now remember what I've said earlier about Jenkins, because at the core of Jenkins is a very, very powerful automation server. All right. So my second job. This is my second job, which will be triggered automatically. Okay. So in the build step, we'll bash down. Then we'll write here echo again. So let's say here something as second job is going on here. The tools, with the tools of an automation tool. And then I'll give some date as well. Date, put in the time. But this time I'm going to demonstrate the powerfulness of the automation server that is there. So if you see here, there is a build trigger. So build can be triggered using various triggers that is there. So you'll get into the GitHub trigger or a hook or a webhook, which is kind of triggering. So we'll see that later on. But for now, what I want to do is I want to ensure that this job that I'm going to put in will be automatically triggered. Let's say every minute I'm on this job to be run on its own. So we'll put as build periodically and we will set the time. Now, if you can see here, there's a bunch of help. If you want to go through it, you can go through it. Let's just put out very simple regular expression for scheduling this job every minute. All right. So 5,000 is all I'm going to put in. 1, 2, 3, 4, 5. Now let me save this. Let's go back. So when you build periodically, is now you can see here. Now we just copy that. And now how do we check if it gets triggered every 15 minutes? So I just don't do anything but wait for 15 minutes. And if everything goes well, Jenkins will automatically trigger my second job in 15 minutes. Now you can see here, it's still processing. So we have to wait for 15 minutes. Now we can go through all those commands of the scheduling time. So you can see how many stars required for each minute or for each hour. Now as you can see, it's done. You can just go and go here and go to console output. Now you can see the finish is success and you have this. Now we can go back and copy this and see if they're on your it's already there. You can go to workspace. You can see your second job has also been created automatically by Jenkins. Now that I have my Jenkins up and running, a few jobs that have been put up here on my Jenkins instance, I will need a way of controlling access to my Jenkins server. This is where I will use a plugin called a role-based access plugin and create a few rules. The rules are something like a global rule and a project rules for a specific role. I can have different rules and I can have user who have signed up or the users from my create kind of assign to these roles so that each of these users fall into some category. This is my way of kind of controlling access to my Jenkins instance and ensuring that people don't do something unwanted. All right. So first thing first, let me go ahead and install a plugin for doing that. So we get into manage Jenkins, then we go to manage plugins. We will plugins, install plugins. We have advanced settings. So these are the available plugins, and then if you go to install, these are the installed plugins. Now let's go and search for a role-based. Now you can see here, base authorization strategy. So this will happen is it enables user authorization using a role-based strategy. Now roles can be defined globally or for particular jobs or nodes selected by a regular expression. This is the plugins everyone. So we will install it without restart. So it's success. It looks good. Looks good. Now waiting for this. Yeah, success. Done now. So go back to the top page. Now one thing to remember guys is Jenkins is running on a Java using a Java instance. So typically many things will work the same way unless inherently you want it to restart. So but a good practice is whenever you do some sort of a big installation or a big patches on your Jenkins instance, just ensure that you can restart it. Otherwise there will be a difference in terms of what is installed in the system and what is there on the file system. So you'll need to flush out few of those settings later on. But for now, these are very small plugins. So this will run without any problem. But otherwise, if at all, there are some plugins which they will need to restart, you can kindly go ahead and restart your Jenkins instance. But for now, I don't need that. So it looks good. I have installed the plugins. So where do I see my plugins and install the plugins? Which is specific to the user control to the access control. Now let's go to the configure global security. Now we can go ahead and check the authorization. You can see here authorization role-based strategy popping out here, right? As you can see, the role-based strategy has been installed and has been shown here. This is because of my installation of my role-based plugin. So this is what I would want to enable because I already have my own database set up, and for the authorization part in that sense that you can do what I'm going to install. I mean, I've already installed a role-based strategy, right? Now I'm going to enable that strategy. So we'll simply click on role-based strategy, okay, and click on save. So now I'm going to enable that strategy. All right, now I will say, okay, now I've installed the role-based access plugin. Now we'll need to just set it up and check, I will go ahead and create some roles, and it shows that I've assigned users as per these roles. So let me go to manage the configuration, manage Jenkins, and let's see how we can create our roles. Not here as well. So we can do manage and assign roles for creating a roles. Okay. Now you'll only be able to see this once and only when you have installed those plugins. Now I've enabled the plugins. Now I've enabled the role-based access control as well. Now we'll go ahead and create some rules for this particular Jenkins instance. So first I will manage roles. So this is at a very high level, which is a global role. Now there are some role to add which you can add by yourself, some item roles for some projects or something. So let me create a role that's kind of visualized like a group. So we'll create our own call the developer. Typically the Jenkins instance or the CA instance are kind of owned up or controlled by a QA guys. So that's why I'm creating a role called developer, and I'm adding this role at a global role. So I will add this here, and then I can click read as well. So we've given this administrator, right? So we add this. So as you can see here, you will see this develop a rule that there is each one of these options that you can hover here and sort of see what kind of permission you have given it to this developer role that you have just created. So you can read and write, then you can create some changes. We have given a permission as credential, which you can create. Then you can delete, then manage the domains. So this kind of help or the permission that they're giving it. So these are some kind of sort of a help for a permission specific. So you want to see it's like how it sounds a little different, but I would want to give you a very little permission for the developer. So from an administrative perspective, I just want him to have a read and write kind of a role credentials. Okay, let's say read and write, and I can allow him to view as well. I don't want him to create agents or give him some delete. No, I don't want him to configure, build, provision, or connect or disconnect anything. So I'll just give him a read and a view. And I don't even want him to have access to my workspace as well. So I'll just give him now for run. So I won't even give him the access to that. Now we can give view as well. I don't want him to delete. And what am I doing here is just creating a global rules for the developers. And I've given him a very limited roles, in the sense that I don't want this developer to be able to run any agents, nor create jobs or build jobs or cancel jobs or configure jobs at the maximum. Right? So I just want him to read that is already put up there. Okay, so I would save now and create a rule. That is done. Now that I've created a rule. Now I still don't have any users that is in there in the system. So let me go ahead and create some users on the system. So we'll go back to manage Jenkins and go to manage users. Now let me create another user, okay, by clicking on plus users, and we'll say this one as a developer. Give him some password and name him as develop23, and email, and just simply give my email here and click on create users. Okay, 1-2. So we have created. Now this developer 1-2 is a user that I've configured, but still yet I have not set any rules for this particular user. So I will go to the manage and gain and will give him the manage and assign roles. So now we'll go manage and assign roles, and we'll assign role. So what you're gonna see, what I'm gonna do now is I'm gonna assign a role that is specific to that particular developer. So I'll find that particular user and assign him, or means the developer role that I've already configured the rules. Okay, so this is the role that we have created. So we will search the user that we have just created, developer 1-2. Now I've assigned this. So go ahead and save the changes. Now let's go ahead and check the permission of this particular user by logging on to my main account and logging back as the developer one. Now let's log out from here. Log out and say developer 1. Now, if you remember, this role was created with very less privilege. So there you go. I have Jenkins, but I don't see a new item. I can't trigger a new jobs. I can't do anything. I see these jobs. However, I don't think I'll be able to start this job. Now, I don't have the permission to set forth at the maximum. So what I can do is look at this job, see. So this is a limited role that was created, and I've added this Damanang Lamare. to that particular role, which was a developer role, so that the developers don't get to configure any of the jobs because the Jenkins instance is owned by a QA person. He doesn't want to give developer any ethnicity or right. So the rights that you set out by creating a developer roles, or any user who's tagged as a part of this developer role will get the same kind of permission. And these permission can be, fine grained. It can be a project specific permission as well. But for now, I just demonstrate the high level permission that I've set. So let me quickly log out of this user and get back to my admin account. So because I need to continue my demo with the developer roles that was created. Now, one of the reasons for Jenkins being so popular, as I mentioned earlier, is the bunch of plugins, but it's got plugin for connecting anything and everything. Now you can find the Jenkins plugins, then you will see the index over here. There are so many plugins that are there. All of these are wonderful plugins. Whatever connectors that you will need if you want to connect Jenkins to the AWS instance, or you want to connect Jenkins to a Docker instance, or any of those containers, you will have a plugin. You can go and search up if you want. If you want to connect Jenkins to Bitbucket, simply click on Big. So as you can see, these are available. So bottom line, Jenkins without plugin is nothing. So plugins is the heart of Jenkins for you to connect, or in order to connect Jenkins with any of the containers or any of the other sets of tools, you will need the plugins. Now, if you want to connect or you want to build a repository which has got Java and Melvin, you will need to install Maven and GTK on an instance. Now, if at all you're looking for a Microsoft build, you will need to have MS Build installed on your Jenkins instance, and the plugins that will be triggered MS Build. If at all you want to listen to some server-side webhooks from GitHub, you will need a GitHub specific plugins. You want to connect to Jenkins, to AWS, you need those plugins. Now, if you want to connect Docker instance that is running anywhere in the world, as long as you have the URL, which is publicly reachable, you just have a Docker plugin that is installed on your Jenkins instance. So if you want to connect to a Docker instance that is running anywhere in the world, as long as you have the URL which is publicly reachable, you just have a plugin that is installed on your Jenkins instance. Now, SonarQube is one of popular statistic code analysis, so you can connect a Jenkins build. You can build a jobs on Jenkins and push it to a SonarQube and get SonarQube to run analysis on that and get back the result in Jenkins. Now, all of these works very well because of the plugins. Now with that, let me connect our Jenkins instance to a GitHub. So now let us connect our Jenkins instance to a GitHub. Now I already have a very simple Java repository up on my GitHub instance. So let me connect Jenkins to this particular GitHub instance and pull out a job that is put up there. Right. So this is a very, very simple and repository is called Hello Java. And this is what is there in the repository. This is a simple class file. It's just got some one line of system .out. So this is already present on github.com at this place, and this will be the URL for this repository. So I will pick it up. So what I'll do is I will connect my Jenkins instance to go to my GitHub and provide my credential and pull out this repository, which is on the cloud hosted in the github.com, and get it to my Jenkins instance and then build this particular Java file. Now I'm keeping the source code very, very simple. It is just a Java file. Now, how do I build my Java file? How do I compile my Java file? I just say java.c and name. Now, the name of my class file is hello Java. And how do I run my Java file? I will say Java and hello. Okay. So remember, I don't need to install any plugins now because what it all needs is a Git plugin. So Git plugin, which is already installed on this system. So let us go back, create a new items. We'll create a first job here. Let's say this is a Git first project. Now let it be a freestyle. Okay. Now we'll go to the source code management. Remember, right? We always have been keeping it on none. So in this part, we'll put it as Git. Now, as you remember earlier in examples, we do not use any source code because we were just putting up some echo kind of jobs that did not need any integration with any of the source code system. So now let us connect this. So I'm going to put up my source code and it will show up because the plugin is already there. Now I've already copied the HTTP address from the GitHub and simply paste it here. Now what is the credential? So simply add that. If you add credential this time, so I'll just click and cancel. So if we just add Jenkins, so we'll add a username here. Now, if there are any errors in terms of not able to Jenkins to be able to find the Git or the git.exe, or if the credentials are wrong somewhere down here, so you'll see a red message, okay? Like something is not right. So for now, it's okay. Now I'm gonna build trigger. Now, what will be there as a part of my build step? Because this repository just have the Java file correct, hello Java. So in order for me to build this, I will say execute window bash command, and I'll say Java, hello Java, Java. Now let's save this. Okay, so let me try to run this. Okay, build now. Click on this. Console output. Great. Now as you can see here, there's a lot of executed Git on the behalf. It goes on there to provide my credentials, and so it pull all my repository and my default. Now we'll pull up the master branch. This is there on the post string, and it kind of builds this whole thing on Java C hello world. Finish, and it's given me a success. So it's kind of build this whole thing Java C hello to Java, and it runs this Java hello world. And there, as you can see, this is the output. It's there, and here you can see if you want to look at the content that was created on the repository. Now if you can go there into my workspace like I've showed earlier, you can just simply click here, and you can already see here it's been created Git first project and say hello. Now as you can see, it's already there. Now if you can go back, as you can see, and simply close that. Now what it did was Jenkins on your behalf went over all the way to GitHub, pulled this repository from there, and then it brought it down to your local system on my Jenkins instance. Now it's compiled it and it ran this particular application. Now that I've integrated Jenkins successfully with Git, simply within the Java application,
now let's start with the Docker use case. Imagine that you're working in a fast-paced IT department where issues keep popping up, asserts go untracked, and changes need approval. That is where IBM Control Desk comes in. It streamlines IT service management by centralizing incident, problem, and asset management into one easy-to-use platform. And it helps in solving problems faster with automation and intelligent workflows to improve service quality and keep things running. Let me tell you all what is IBM Control Desk. IBM Control Desk is an IT service management tool that helps manage and also support users and IT infrastructure. It builds on IBM Maximo Asset Management, a platform originally designed for managing physical and IT assets. Did you all know that even IBM faced challenges? IBM Control Desk, while a robust IT service management solution, faced several challenges in traditional environments. The deployment process was often complex, requiring extensive configuration and manual efforts that prolonged setup times. Its architecture was resource-intensive, leading to inefficiencies and also higher operational costs. Scalability was another significant hurdle, as adapting to increasing workloads required to major architectural adjustments, limiting its responsiveness to business needs. Additionally, maintenance and upgrade process were frequently causing downtime and increasing operational overhead. And also, the traditional on-premises setup was lagged, and flexibility of modern cloud-based solutions, making integration with other tools more difficult and highlighting the need for a more modernized approach, such as containerization to improve performance, scalability, and ease of management. Imagine managing thousands of IT assets and services without scalable infrastructure. This is where the IBM Control Desk was before Docker. So, let's ever think why Docker was introduced into IBM Control Desk. In the IBM Control Desk case study, Docker was introduced to address the challenges associated with managing traditional IT service management applications. IBM Control Desk, a complex and resource-intensive platform, often faced issues with scalability, high resource consumption, and complex deployment process in traditional environments. Docker helped overcome these challenges by containerizing the application components, allowing for more efficient resource use, easier scaling, and simplified deployments. By using Docker, IBM Control Desk could quickly adapt to changes, reduce operational overhead, and also improve performance, aligning with modern DevOps and cloud-native practices. Here is a simplified explanation of the setup described, where a single VM on Red Hat Linux with 2 CPUs and 4 GB RAM hosts both the IBM Control Desk and the DB2 database. Application files are shared via NFS, that is making them accessible to Docker for container deployments. Here comes another step, that is building Docker images. They decided to strictly follow what is stated in the Maximo Asset Management. That is, Maximo Asset Management is a comprehensive software solution developed by IBM that helps organizations manage their assets effectively throughout their lifecycle. That is, it is a part of an IBM Watson IoT, that is Internet of Things, platform, and it's widely used in industries such as manufacturing, utilities, and also transportation and facilities management. A team built a Docker image for IBM Control Desk, like generating the WAR files and also for the UI. Using Docker files, server.xml, and also jvm.options, they built images for various applications including UI, cron, MEA, BROS, and also API. Since JMS wasn't provided, they created it from scratch. Based on the WebSphere Liberty docs, the service portal image built from the Node.js included certificates for secure communication. Next is that they deployed containers. Containers were deployed on an Ubuntu machine with 4 CPUs and 32 GB RAM. Each application had a container connected to a Docker network for inter-container communication. Docker Compose managed all resources using Docker Compose.yml for configuration, including environment variables and host settings. The streamlined approach enhanced scalability, simplified management, and improved integration for IBM Control Desks. Let me tell you what Docker brought in change. Docker transformed IBM Control Desk by enabling containerization, improving resource efficiency and scalability. It simplified deployment, reduced downtime, and made updates easier through the component isolation. This enhanced system flexibility, reliability, and overall performance, making IBM Control Desk more agile and responsive. So, here is a condensed version of 4 points. First is the efficient containerization. Docker improved IBM Control Desk's resource efficiency and scalability by containerizing its components. They also streamlined deployment, enabled faster setup with fewer errors and reduced downtime. Easier maintenance too. Docker isolated components, which made updates and maintenance more manageable and flexible. Enhanced agility work. Docker was also an enhanced agility that made approach for IBM Control Desk more agile and responsive to business needs, optimizing operations. Now let's see the overall solution bought. Involving Docker in IBM Control Desk bought a comprehensive solution by containerizing its application components, which improved resource utilization and scalability. This approach allowed faster and more consistent deployments, reducing setup errors and minimizing downtime. Docker also enabled seamless updates and maintenance by isolating different components, enhancing the system's flexibility and reliability. Furthermore, the streamlined modular architecture simplified operations, reduced operational cost, and increased responsiveness, ultimately transforming IBM Control Desk into a more efficient and agile IT service management platform. Let's see the key benefits bought. First is enhanced scalability. Containerization optimized resource and also simplified scaling as demand grew. Efficient deployment. Docker streamlined deployment, reducing errors and downtime for a more reliable setup. Simplified maintenance. Isolated components enabled easy updates, boosting flexibility and reliability. Last is the cost-effective operations. The modular setup cut costs and also improved responsiveness, making IBM Control Desk more agile. The result bought by this use case was, this article showed a case study using container technology to leverage the native support of WebSphere Liberty profile with the IBM Control Desk product. So, they found that they have more traditional product to container to evolve it toward a cloud-native-like architecture without any need of touch the code. That is, there were also no impact at the application level. This case study showed how container technology was used to transform IBM Control Desk into cloud-native-like architecture without changing the application code. Despite being a traditional product not originally designed by the microservices, containers allowed the IBM to modularize its components, mimicking microservices and improving scalability and flexibility. The process involved identifying dependent modules, that is by updating build scripts, deploying each module in its own container, setting up communication between them, and testing the setup. This approach shows that even traditional application can be modernized with containers, making deployment easier and more efficient. Now let's see why Docker is so necessary. First, Docker is portable. That is, they run app consistently across any environment. Second, they are lightweight. Containers use fewer resources than VMs, that is the virtual machines. Then their efficiency, faster setup times and better resource utilization. Next comes the scalability. Easily scale apps using container orchestration. Then is the consistency. Same behavior from development to production. DevOps integration has streamlined CI/CD pipelines. Next is the isolation. Securely run multiple applications on the same host. Last is the simplified dependency management, that is, package all dependencies in one container. Now, let's see the prerequisite to learn Docker. Docker simplifies creating consistent environments across workflows. But to fully harness its power, you'll first need a solid grasp on Linux, command line tools, and also the containerization basics. The three main programming languages needed are Python, JavaScript, and Golang. And the additional prerequisites needed are version control, that is, understanding Git or another version control system can be beneficial for managing code changes in Docker projects. Then is the networking concepts. A basic understanding of networking concepts like IP address, ports, and networking protocols can be helpful for configuring Docker networks. Last is the operating system. Familiarity with command line interfaces like CLI and basic system administration concepts. Next, let's see what is a container. A container technology was launched in 2013 as an open source Docker engine. It leveraged existing computing concepts around containers and specifically in the Linux world. Primitives known as C groups and also namespaces, Docker's technology is unique because it focuses on the requirements of developers and systems operators to separate application dependencies from infrastructure. A container is a lightweight, isolated unit that packages an application and its dependencies. It also ensures it runs consistently across different environments. Now let's see why Docker uses containers. Docker uses containers for its portability as it runs the same anywhere. Then for its efficiency that uses fewer resources than virtual machines. Then comes the scalability, where it can easily scale applications. Last is its consistency, that ensures the app behaves the same in all environments. Now, let's see what is Docker. A Docker is a platform that enables developers to design, develop, and deploy testing to manage applications in isolated, portable environments known as containers. Containers allow you to package an application and all its dependencies like libraries, configurations, etc. into a single unit, ensuring that app runs consistently across different environments. Next, coming to the benefits of Docker. The benefits of Docker are consistency, which runs applications the same way across development, testing, and production. Efficiency, Docker containers use fewer resources than VMs. They also run faster to start and also use less memory and storage. Scalability, Docker is commonly used in cloud environments and microservices architecture, making it easy to scale applications horizontally. Simplified CI/CD. Docker helps automate and streamline continuous integration and continuous deployment pipelines. We will look at the virtual machines versus containers and their differences. The architecture of the virtual machines is that VMs run on a full operating system on a hypervisor, and containers share the host OS kernel but isolate applications. The resource usage of the VMs are heavy, requiring more CPU, memory, and storage as they run separate OS instances. But containers are lightweight and efficient since they share the host OS. The start time of the VMs take minutes to boot, but the containers start in seconds. The portability of VMs are less portable, tied to OS and hypervisor. Containers are highly portable and run consistently across different environments. The performance of VMs have more overhead due to virtualizations, but containers offer near-native performance with minimal overhead. The use cases of the VMs are full isolation, legacy apps, and heavy resource needs. But in containers, we have fast scaling, microservices, cloud-native apps. Containers are ideal for lightweight, scalable deployments, while VMs are better for complete isolation and resource-heavy applications. Moving on to Docker components. The core components of Docker are, first is the Docker engine. This is the heart of a Docker, responsible for building, running, and managing Docker containers. It's available for Windows, Mac OS, and Linux. Docker images. These are the blueprints of containers containing the application code, libraries, and dependencies required to run the application. Last comes the Docker containers. Instances created from Docker images. They are lightweight, isolated environments where applications run. Now let's learn the architecture of Docker. Docker follows a client-server architecture that allows applications to be packed into containers. It consists of several key components working together to manage, build, and run containers efficiently. Here is an overview of Docker's architecture. First, let's learn about the Docker client. A Docker client is a primary interface for users to interact with Docker. Users issue commands like docker build, docker run, and docker pull, while the client translates into API calls that are sent to the Docker daemon. The client can communicate with either the local Docker daemon or the remote one. The key role of a Docker client is they send commands to the Docker daemon using the REST API. Next, let's see about the Docker daemon, or it's also known as the Docker engine. The Docker daemon is the core service running in the background on the host system that manages Docker objects like containers, images, networks, and volumes. The daemon listens to API requests from the client and also handles all the container management tasks such as creating, starting, and stopping containers. It is responsible for executing the container lifecycle, including pulling images, building containers, and ensuring their isolation. The key role for the Docker daemon are it executes commands, managing containers, images, and networks. Next is a Docker image. A Docker image is a read-only template that contains instructions for creating a Docker container. Images include everything needed to run an application, like code, libraries, environment variables, and configuration. The key role of a Docker image is that they are blueprint for creating containers. Docker container. A container is a runnable instance of a Docker image. Containers are lightweight and isolated, but they share the host OS kernels, making them efficient compared to virtual machines. The key role of a Docker container is that they are lightweight, portable, and isolated instance of an application. Next comes the Docker registries, that is a Docker hub. Docker registries are repositories that store Docker image. The most common registry is the Docker hub, a public registry maintained by Docker. Developers can push their custom images to a registry or pull pre-built images for use of their projects. Registries can be public or private, allowing organizations to manage and store their proprietary container images securely. The key role of a Docker registry is that they store and distribute Docker images. Moving on to the Docker Engine REST API. Docker's Engine API allows programmatic interaction with the server Docker daemon. The API can be accessed over HTTP, enabling developers and servers to manage Docker programmatically. All the communication between the Docker client and the daemon happens via the API. The key role of a Docker Engine REST API is that they enable automation and remote management of Docker through the REST interface. Docker Volume. Volumes allow data to persist beyond the lifecycle of a container, providing a way to store and share data between containers or with the host system. They are commonly used to store the database files or other data that are needed to persist even if the container is destroyed or recreated. The key role of a Docker volume is they have the persistent storage for containers. Last comes a Docker network. A network is a group of two or more devices that can communicate with each other either physically or virtually. A Docker network is a virtual network created by Docker to enable communication between Docker containers. If two containers are running on the same host, they can communicate with each other without the need of ports to be exposed to the host machine. They may use the Docker to manage Docker host in any platform manner, regardless to whether they run Windows, Linux, or the combination of two. The key role of a Docker network is to manage communication between containers and external networks. Now let's see the development workflows of Docker. Docker enhances development workflows through, first is a containerization, having packages, application, and dependencies into lightweight, portable containers, ensuring consistency environments across development, testing, and production. Next is the local development. Enables developers to replicate production environment locally, speeding up testing and debugging. Next comes the continuous integration or the continuous deployment, which integrates with CI/CD pipelines for automated build, test, and deployment process. Last is the version control. Supports versioning of images, allowing easy rollback and management of application versions. Now we'll see how to install Docker on our Ubuntu machine. Now let's start with installing Docker on our Ubuntu machine first. Now in order to install Docker on Ubuntu, there are some prerequisites. I would advise you to go to Docker's Install Docker Engine on Ubuntu. Click on the first link that you can see, Install Docker Engine on Ubuntu. Here you can see the documentation and check for all the prerequisites that are specified there. Once you're done with the verification, you can move ahead with the installation process. We'll be using the following: install using the apt repository process to install Docker on our Ubuntu machine. First, open the terminal on your Ubuntu machine. Now let's set up the Docker's apt repository. To do that, first we need to add the Docker's official GPG key. We begin by running a simple apt get update to refresh the package lists. So let's type sudo apt get update. This will refresh all the package list that is needed. Be patient until the packages are getting refreshed. So next we'll install CA certificates and curl on our machine. For that, let's copy and paste the command on our terminal. So as you can see that it's getting installed, type S to continue the installation. CA certificates in our command is a digital certificate that ensures your machine can communicate securely over the internet by verifying the authenticity of websites. The curl is a tool used for transferring data with URLs, allowing us to download files from the internet, such as Docker's GPG key. So now let's move to the next command, that is, we'll be creating the directory for storing the key rings. So for that, let's copy and paste the next command to the terminal. Now let's also add Docker's GPG key to it. We'll download Docker's official GPG key using the following command. Now let's also type the command to ensure that the GPG key can be read by the system. So we'll copy and paste from our documentary and paste it on our terminal. Next, let's add the Docker's repository to APT sources. So for that, we'll add the Docker's repository as the APT sources, and this step will allow Ubuntu to know where to find Docker's packages. So the command we just ran adds the Docker's repository to our APT sources list. This command will specify the architecture of our machine to ensure compatibility. This part will extract the code name of our Ubuntu release, making sure we download the correct version of the Docker. Now, let's also update the package list again. Now that we have added the Docker's repository, we'll run another apt get update command to refresh the list of available packages from this new source. So as you can see, the reading package list is done. Now we'll install Docker by running the command below. This installs Docker Engine, Docker CLI, and the essential Docker tools on your system. Enter S to continue the installation. So be patient until the Docker's installation is getting installed. In our Docker installation command, we have Docker CE, that means Docker Community Edition, the main Docker engine. And the Docker CLI means the command line interface for Docker. Container.io is the core container runtime for Docker. And the Docker BuildX plugin is a plugin for building Docker images. Docker Compose plugin is a plugin to manage multi-container application. So let's be patient until all the packages in the Docker is getting installed. Finally, we can verify whether Docker was successfully installed by running the Hello World image. So let's type sudo docker run hello world. This command pulls a test image from Docker Hub, runs it inside a container, and displays a confirmation message. If the installation was successful, you should see the Hello from Docker message, indicating everything is working perfectly. There you have it. We have successfully installed Docker on our Ubuntu machine and verified it with the Hello World image. Let's clear the screen. Now that we have successfully installed Docker, let's clear our terminal and explore what happens when we simply type Docker. When you run this command, you will see a list of all available Docker commands. This list is incredibly useful when you're unsure about which command to use. There's also a brief description next to each command that will help you understand its purpose. Now let's go over some of the common commands. First is run. It creates and runs a new container from an image. This is one of the most frequently used commands in Docker. It allows you to run a container based on an image, which can be pulled from a registry or built locally. Next is the execute command. It allows you to execute a command in a running container. This is useful when you need to interact with a running container, such as opening a shell inside it. The ps command, that is the list containers. This command shows you all the containers that are currently running or that have been stopped. Next is the build. This command allows you to create a Docker image from a Docker file, defining the environment and dependencies of your containerized application. Next is pull. It allows you to download an image from a registry. Use this command to pull images from a Docker registry like Docker Hub. Push. It uploads an image to the registry. If you want to share your image with others, you can push it to a public or private registry too. Images. Images are the list of images. This command shows all the Docker images that are available on your local machine. Login. Authenticate to a registry. Use this when you need to log into a Docker registry, for example, Docker Hub, to pull or push images. Logout. This allows you to log out from a registry. This logs you out from the Docker registry too. Search. Search Docker Hub for images. This allows you to search Docker Hub for pre-built images based on your requirements. Next is a version. Show the Docker version information. It provides details about the version of the Docker you're running. Last is the info. It will display system-wide information. This command gives you detailed information about your Docker installation, including how many containers and images are present, your storage driver, and other system-wide stats. Let's start by checking the Docker version. If you're not similar with the version you're running, you can simply use this command, that is the Docker version. When you're running this command, it displays the current version of the Docker on your system. In case it shows a version 27.3.1, which is the latest version. Similarly, we can check more detailed system-wide information using the info command. So let's type sudo docker info. This info command provides extensive details about your Docker setup, including the number of containers, images, and other resources being used by Docker on your system. So as we progress through this tutorial, we'll dive deeper into many of these commands and understand how to use them in real-world scenarios. Now, moving forward, we'll build a Docker image using Dockerfile and run that image on your local host as a container on your system. And we'll also open a web browser to see our web page hosted after running the container. So, the first step is to create a directory for our project. We'll use the following command, that is mkdirectory, myapp. This creates a directory named myapp. So here you can see that myapp is seen. Next, we'll move into this directory using the cd myapp. Now we'll create a file named index.html. So for that, we'll type the command, that is touchindex.html. Once the file is created, we'll open it using the nano editor and write the content into the file. So I will be typing here, subscribe to Edureka. Then press Ctrl+X followed by Y to save and press enter to confirm the file name as index.html. To verify the content inside index.html, we will use the command, that is cat index.html. So here you can see that subscribe to Edureka is also visible. Our next step is to create a file named Dockerfile. For that, we need to type the command as touch Dockerfile. Then type ls to see. So here you can see that our Dockerfile in index.html is visible. After creating the Dockerfile, we'll open it in the nano editor and write some instructions into it. So let's type from Nginx. So Nginx is an open source web server that is widely used for serving static content, load balancing, and also acting as a reverse proxy. In this case, we are using it to serve our index.html file. Next, let's type copy index.html /user share nginx/html. So the copy instruction will allow you to copy our index.html file from the current directory into the HTML directory, which is the default directory where Nginx serves its web pages. If your index.html file is in a different folder, you will need to specify the correct file path in the Docker file. The Docker file is essentially a text file with set of instructions that Docker uses to build an image. So by typing cat Dockerfile, you can see the content that we have written in the nano editor. So next, we'll need to make sure that the Docker is running. If Docker is not running, you can start it with the following command, that is sudo service docker start. If needed, you can also stop the Docker by typing sudo service docker stop. So press Q to exit the status display. As we have stopped the Docker, let's start the Docker again. So let's type the command as sudo service docker start. We can also see the status by writing the command sudo service docker status. So here you can see that a Docker is active and it is running. Now let's proceed to build our Docker image. We'll use the docker build command, that is docker build -t myapp. Let's write the command for the build. that is docker build -t my app and a dot. Docker build is a command that builds a Docker image based on the instruction provided in the Docker file. And the T flag is used to tag the image with a name. In this case, it is my app. This makes it easier for reference later. And the dot after my app refers to the current directory, in which the Docker file is located. So by running the build command, we can see that the error is occurred. So the error shows that the permission denied while trying to connect to the Docker daemon. It means that we need to connect as a super user. So let's type the command as sudo su and then write the command for build. So now you can see that my Docker is getting built. Be patient because it might take time. Now that we've successfully built our image, now it's time to run the Docker. Now let's type the command that is docker run -d -p 6969 :80 my app. -d flag runs the container in detached mode, meaning it runs in the background. And the p flag is used to map ports. In this case, we are mapping port 6969 on a local machine to port 80 inside the container, which is the default HTTP port for Nginx. This command essentially starts a container from my app image, allowing us to access our web page on the local host via port 6969. Now to check the container is running, we use the docker ps command. This will list all the running containers and you should see the my app container running. Finally, to see what we have hosted on the container, open a web browser. Here we'll use Firefox. So on the search bar, let's type localhost 6969. So when you visit to this URL, you should see subscribe to Edureka displayed on the web page, confirming that our Docker container is serving the content successfully. Now, going back to our terminal, now that we have successfully built and run our Docker image locally, let's move ahead and push this image to Docker Hub, where it will be publicly accessible and stored privately in your Docker Hub account. If you don't have a Docker Hub account yet, go to hub.docker.com to create one. It's a simple sign-up process. Once you have created your account, we can proceed with logging into Docker Hub from the Docker CLI. Now, to push our image to Docker Hub, we first need to log in to Docker from the terminal. We can do that using the docker login command. So let's type docker login -u and give our username -p with our password. The U flag is specified for username and the P flag is specified for the password. So once you're logged in successfully, the Docker will display a message confirming the login. Before pushing the image to Docker Hub, we need to tag our local image with a name that includes our Docker Hub username. This ensures that a Docker Hub knows which repository the image belongs to. For that, let's type the command that is docker tag my app, the username, my app : and then the version tag. Here my app : latest is the name and the version tag for the image. We are tagging this image as latest to indicate it's the most recent version. Now we can push our Docker image to Docker Hub using the docker push command. So let's type docker push with the username and the version tag again. This will upload the my app image to your Docker Hub repository. Docker will display the progress as it pushes the image layers. And once it's complete, you will see the confirmation message. So let's be patient unless the image is pushed. So here you can see a confirmation message telling that it is pushed. So after you have pushed the image to the Docker Hub, you can log out of your Docker Hub account from the CLI using the docker logout command. For that, let's type docker logout. This is useful when working on the shared machines or environments where you don't want your credentials to remain stored. To verify that our image is now available on Docker Hub, we can use the docker search command. This command allows you to search the Docker Hub for images. So for that, let's type the command as docker search, username, and my app. So here you can see all the images that we have published. So once the image is on the Docker Hub, We can pull it to any other machine or even to a current machine to ensure that it works as expected. The docker pull command allows us to download the image from the Docker Hub. So let's type the command as docker pull with our username and the image name with the version tag. This command will download the image layers from the Docker Hub to your local machine. So here you can see that our image is pulled successfully. After pulling the image, you can run it on your local machine, just like we did earlier using the docker run command. So now we can open our web browser and visit, typing the localhost 6969. You should see the same, that is subscribe to Edureka page, confirming that we have successfully pulled and run the Docker image from the Docker Hub. And that's it. You have successfully learned how to push an image to Docker Hub. Search for it, pull it, and run it on your local machine. Now that we have learned how to work with individual containers in Docker, let's introduce Docker Compose. Docker Compose is an essential tool when you're working with multi-container applications. Instead of managing each container individually, Docker Compose lets you define and manage all the services your application needs in a single YAML file called the dockercompose.yml. So here we have the command to install Docker Compose. The option -L makes the curl follow, redirects, ensures that it reaches the final download URL. And the uname-s part dynamically inserts the operating system name, such as Linux or Windows. And the uname -m inserts the system architecture, that is whether it is 64-bit or 32-bit. This ensures the correct version is downloaded for your system. The Docker Compose option specifies the output location where the Docker Compose binary will be saved. In this case, it is user local bin Docker Compose. Once the binary is downloaded, apply executable permissions, that is sudo chmod +x command. To verify that Docker Compose has been installed correctly, let's check the version. So let's type the command as docker compose version. So here you can see that the Docker Compose version is v2.29.7. That is the latest version. Now that we have installed Docker Compose, let's create a simple Docker Compose file. This file will define two services, a web server having an image of Nginx and a database that is Redis. So first, we'll create a new directory named Docker Compose file. So let's write the command for it, mkdir Docker Compose file. Then we'll go inside the directory. So type cd Docker Compose file. Inside this directory, we'll create a new file named dockercompose.yml using the touch command. So let's type touch dockercompose.yml. Next, we'll open this file with a nano editor and add the following content. So let's type services, web that uses the Nginx image, and the other file is the database which uses the Redis image. We'll save the file by pressing Ctrl+X, then Y to confirm and save, finally enter to confirm the file name. Before we run the file, let's check if it's valid using docker compose config command. This command checks the syntax error or misconfigurations in the YAML file. So let's type the command docker compose config. If the file is valid, you will see the content printed out. Now we are ready to run our services. To start both Nginx and Redis containers, we'll use the docker compose up command. We'll run it in the detached mode so the containers run in the background. So let's type docker compose up -d. So once the containers are up, we can verify by listing the running containers using the docker ps command. You will see two containers running, Nginx and Redis, which were defined in our dockercompose.yml file. Now to stop and remove the containers, we can use the docker compose down command. This command will bring down all the services defined in our docker compose file. So let's type docker compose down. Now let's modify our docker compose YAML file to expose a port for Nginx service so we can access it from our browser. So open the file again with nano. We'll add the following lines under the web service to map ports 8080 on our local machine to port 80 in the container. After making this change, let's validate the file again by typing docker compose config. If the file is valid, we can now run it again using the docker compose up command. If the file is valid, we can now run it again using the docker compose up command. Since the Nginx and Redis images are already downloaded, it will skip downloading and simply start the containers. Now let's go to the browser and type localhost 8080. So you'll see a default Nginx welcome page confirming that our container is running and accessible on the port 8080. Once you're done, you can bring down the containers again using docker compose down command. Docker compose comes with several useful commands. To see a list of available commands, we can use the help command. So let's type docker compose --help. You will see a list of commands like up, down, config, ps, and many more. These commands allow you to manage your Docker Compose services easily. So, that's a quick introduction to Docker Compose. We have seen how to install Docker Compose, create and validate a Docker Compose.yml file, run multiple containers with a single command, map ports for service access, bring containers down when they are no longer needed.
So let's start this session by first understanding why one needs Azure Virtual Machine. So first thing is, of course, the cost saving, the pricing criteria. So we can shut down and stop the virtual machines if not in use. Stopped virtual machine will not incur any charge. Restarting the virtual machine will maintain its state based on persistent disks. Second, the boosted scalability. So we can scale up and down or in and out the virtual machines. Auto scale features is also there to support based on some metrics. For example, scale out to 5 instances when CPU utilization is greater than 70% for more than 5 minutes. Third is alerts. So we can trigger actions and alerts based on metrics of computing resources consumed by a virtual machine. Fourth is we can have a better control, or say more amount of control. So with Azure Virtual Machines, developer have more control over the development environment, which is very helpful in case of building a highly secure architecture for a complex solution. Developers can choose operating system, networking, storage connections, etc. to build a sandbox solution. Lastly, easy diagnostics means Azure Virtual Machine provides the facility to troubleshoot issues with options like remote debugging, event logs, IIS logs, application logs, etc. Moving ahead, let's understand in brief what is Azure Virtual Machine. So for that, we are going to first understand what is a virtual machine. So a virtual machine is a computer file typically called as an image which behaves like an actual computer. It is one of the files which contains everything. It runs in Windows, Linux, etc. This gives you a flexibility that you can run multiple machines in a physical computer. Each system can have a different operating system. Each of these virtual machines provide its own virtual hardware, which includes CPUs, memory, hard drives, network interfaces, and other such devices. Now let's understand what is Azure Virtual Machine. So Azure Virtual Machine is one of the services provided by Azure to create your own instances. So it can be used for various ways like development and test, applications in the cloud, and also for extended data center. It is to remember that when you are running Azure Virtual Machine, you must pay for the compute time on a per minute basis. The pricing of this is based on the size, operating system, and any licensed software that has been installed in it. In order to avoid corresponding charges when you are not using it, it is to be saying that you change its state to stopped, that is deallocated. Now let's understand some of the key features of Azure Virtual Machine. So first is isolation. So each of these networks work independently. When creating a virtual network, you can divide them into segments. You can configure the virtual network to use your own DNS servers. Second is virtual network connectivity. So it can be connected to each other, enabling resources in any virtual network to communicate with resources in any other virtual network. Third is internet communication. So by default, when you are launching any instances in the Azure Virtual Machine, it can access the internet. As and when you need, you can enable inbound access to specific resources. Fourth is on-premises connectivity. So a virtual network can be connected to an on-premises network, enabling resources to communicate between each other. Then there is Azure's resource communication. So resources which falls under Azure Virtual Network can communicate with each other using private IP addresses, irrespective of the resources are from different subnets. They provide default routing between subnets. On-premise networks operating system, you don't have to configure and manage routes. So the next one is routing. So Azure's routing can be optionally overridden by default through configuring with your own routes or by propagating BGP route through network gateway. And the last one is traffic filtering. So network traffic can be filtered from resources in a virtual network by source IP addresses and port. So now let's understand the Azure virtual machine architecture. Azure was initially named as the project Red Dog by Microsoft. The brain behind the project Red Dog is Mr. David Cutler. In initial days, it was a custom version of Windows, and the goal was to boot from a virtual hard disk. So for that, let's first try to understand the main components of Azure Virtual Machine. So first is Fabric Controller. So one of the most important components in Azure Virtual Machine architecture is this is one of the pillars based on which the architecture works. Fabric Controller basically owns all the resources. The placement of the nodes, load balancing, scalability as per requirement, update, patch management, everything is owned by this segment. As the user creates their own instance of virtual machine, all the tasks like provisioning or the deprovisioning along with the supervision of all the nodes is taken care by the Fabric Controller. In brief, we can say that this is the backbone of the Azure Virtual Machine system. So next is the patch management. So patch management workflow is a major advantage of the Azure system, as this module makes Azure easy to manage and stay updated across all the nodes. In Azure system, hosts are image based, therefore there is no need to update all the nodes one by one like a legacy system. Here, Azure basically delivers updated VHD at one place and the entire system of nodes gets updated. A typical update takes place every 4 to 6 weeks, which ensures security and system stabilization. Microsoft here ensures that the updates are tested and verified before it gets rolled out to the nodes. Third is partition. So Azure Fabric Controller has a couple of partition types, and they are update domains, fault domains. These partitions help Azure Virtual Machine to maintain its availability and resilience. The partitioning helps maintain zero downtime, minimum failures, and constant availability. So the first is update domains in partition. That is, it is the strategy that ensures the upgradation of the servers without taking it down. Then Microsoft Azure system distributes instances into a few update domains. Here, every update domains work as a logical unit. One update domain gets upgraded at a time. The upgrade process gets completed when all the update domains are processed. Azure makes sure that the upgrade is completed with the minimum impact on the running services. Then there is fault domains. Fault domain is nothing but a single failure point. Fabric Controller ensures that isolated hardware failure does not happen by distributing the instances to multiple fault domains. This will prevent the malfunctioning of the system due to any single component malfunction. Then there is Azure Compute Stamps. So Azure divide things into multiple stamps, and each stamp has its individual Fabric Controller. Azure has two kinds of stamps: compute stamps and storage stamps. The Fabric Controller is also distributed in multiple branches. Azure generally has 5 replicas of Fabric Controller, and they are all in synchronization to replicate the state. In these 5 instances, one is primary and the information is passed to primary by the control panel. Now, primary instances make sure that same instruction has been passed to the secondary instances. Now, the last one are like some other virtual machine components. So, apart from these, there are 3 other important components of Azure Virtual Machine. They are computer, storage, and networking. So Microsoft Azure also has a capability to monitor the health of the virtual machines in place, and if any issue is found, there is an option to auto recovery. This service is known as service healing. As the Fabric Controller has the capability to detect the failure, therefore this task is carried out by the Fabric Controller to detect failure and trigger auto recovery. So this was all about the components of like the main components of Azure Virtual Machine. Now let's understand the architecture of how to run a Windows virtual machine on Azure. So provisioning a virtual machine in Azure requires some additional components beside the virtual machine itself, including networking and storage resources, as we recently talked about the other virtual machine components. So let's understand this step by step. The first is the resource group. Resource group is a logic container that holds related Azure resources. In general, group resources based on their lifetime and who will manage them. Then there is a virtual machine. So you can provision a virtual machine from a list of published images or from a custom managed image or virtual hard disk, like what we say as VHD file, uploaded to Azure Blob Storage. So Azure offers many different virtual machine sizes. If you are moving an existing workload to Azure, start with the virtual machine size that's the closest match to your on-premises server. Then measure the performance of your actual workload in terms of CPU memory and disk or input or output operations per second, and adjust the size as needed. So generally choose an Azure region that is the closest to your internal users or customers. Not all virtual machine sizes are available in all regions, so keep that in mind. Then there are disks. So for best disk input output performance, we recommend like premium storage for that. Go with premium storage, which stores data on solid state drives, means SSDs. So cost is based on the capacity of the provisioned disk. IOPS and throughput also depend on disk size. So when you provision disk, consider all the factors like capacity, IOPS, and throughput. We also recommend using managed disks. So managed disks simplify disk management by handling the storage for you. Managed disks do not require a storage account. You simply specify the size and type of disk, and it is deployed as a highly available resource. The operating system disk is a virtual hard drive stored in Azure storage, so it persists even when the host machine is down. We also recommend creating one or more data disks which are persistent. So virtual hard disks used for application data. When possible, install applications on a data disk, not the operating system disk. So some legacy applications might need to install components on the C drive. In that case, you can like resize the operating system disk using PowerShell. The virtual machine is also created with a temporary disk. This disk is stored on a physical drive on the host machine. It is not saved in Azure storage and may be deleted during reboots and other virtual machine lifecycle events. Use this disk only for temporary data such as page or swap files. Then there is a network. So the networking components includes the following resources like virtual network. So every virtual machine is deployed into a virtual network that can be segmented into multiple subnets. Then there is network interface. In short, we say it as NIC. The NIC enables the virtual machine to communicate with the virtual network. So if you need multiple NICs for your VM, be aware that maximum number of NICs is defined for each virtual machine size. Then there's public IP address. A public IP address is needed to communicate with the virtual machine. For example, via remote desktop means RDP. So the public IP address can be dynamic or static. The default is dynamic. Then there is a network security group, where we say at NSG, which are used to allow or deny network traffic to virtual machines. NSGs can be associated either with subnets or with individual virtual machine instances. Then there are certain operations, so that includes diagnostics. So enable monitoring and diagnostics, including basic health metrics, diagnostics, infrastructure logs, and boot diagnostics. So boot diagnostics can help you diagnose boot failure if your virtual machine gets into a non-bootable state. Create an Azure storage account to store the logs. A standard locally redundant storage account is sufficient for diagnostic logs. Then there's availability. So your virtual machine can be maybe affected by planned maintenance or unplanned downtime. You can use virtual machine reboot logs to determine whether a virtual machine reboot was caused by planned maintenance. For higher availability, deploy multiple virtual machines in an availability set. Then there are backups to protect against accidental data loss. So use the Azure backup service to back up your virtual machines to geo-redundant storage. Azure backup provides like application consistent backups. Then there is stopping a virtual machine. So Azure makes a distinction between stopped and deallocated states. You are charged when the virtual machine status is stopped, but not when the virtual machine is deallocated. In the Azure portal, the stop button deallocates the virtual machine. If you shut down through the operating system while logged in, the virtual machine is stopped but not deallocated. So you will still be charged. Then there is deleting a virtual machine. So if you delete a virtual machine, the virtual hard drives are not deleted. That means you can safely delete the virtual machine without losing data. However, you will be charged for storage. To delete the virtual hard drive, delete the file from blob storage to prevent accidental deletion as a resource log to log the entire resource group or like log individual resources such as virtual machine. So this is all about the major components and how they work in synchronization with each other to form a virtual machine. So this is how the architecture looks like and how it works of Azure Virtual Machine. Now that we have a theoretical as well as an architectural understanding of Azure Virtual Machine, let's try our hands on it on how to create a virtual machine and how to connect it. So you can just go to the Azure portal. Here you see all the services which you have recently used, and you can just directly go search for virtual machines from here. Go to the virtual machines. Here you see there's no virtual machine being created till now, so you can just go to create. So subscription Azure Labs we have, and then resource group we have to give. If you already have a resource group, just give or create a new one from here. Resource. You can give a name as well. I'm going to give VM demo 01. Area is Central India, so yeah, region I'm choosing Central India, which is nearest to me, and also my consumers are nearest to me. That's the region I'm selecting. So always keep in mind while you select the region, select a region which is near to you and also to your consumers. Then in availability options, requirements, security type standard, Windows 2009 data center generation 2, right? Azure, no, not required. Size, then we have to choose. Yeah, I can go with B1, or you can like select any other size. You can see for all the sizes, so you can select any one of them. Like right now I'm using B1. I can use B2s as well, so I will just select B2s. That has 2 virtual CPUs and 4 GB of memory. Then I will be creating a username. So Azure admin is good for me, and I will give a username as well. It should be alphanumeric along with special character with 1 capital letters as well. So keep that in mind while creating the password. Password matched. So let's go to the next step. Public and more not selected. Now selected report. So RDP 3389 you have to select if it's not selected. So yeah, now let's go to the disk. No thanks, not required. Then select whichever is viable for you, like SSD or HDD standard one. It also like the price was also dependent on which option you are going with. So I'm going with standard SSD right now. Next, networking. Nothing is required. If you want to change anything as per your requirement, you can change that to management. Auto shutdown, if you require enable, like if you enable auto shutdown, it will auto shutdown. That's depend on you. Right now I don't require that. So go to the next one. Extensions and everything is there. So I'm selecting an extension here for myself. You can also like select which one is required for you. I require Microsoft entire malware. Go next. So then I just have to create that. So I've created next text. If you want to add any text, you can. It's up to you. And then you can just go to review and create. So here you will actually get the price. Right now I'm not getting because I have a different kind of an company based account. But if you have any personal account, then you will be getting the total price of your virtual machine you're going to host, right? So you can recheck all the information you've selected for, all the services you have been selected, sub services, and then you can create it. So the virtual machine is getting deployed. So here you can see deployment to resource group is in progress. So now you can see the deployment is complete. So you can just go to your resource from here. Let's see what all is created. We can see a virtual machine is created, public IP address is there, a network security group is created for security purposes, then there's network interface being created, then a storage disk is being created, and as well as the virtual network. As we have understood, all these things are required on virtual machine architecture. You've understood, right? So that's all being created. So we can go to a virtual machine. Now you can see here status, it is running right now. Location, every like region location, you can see it's showing Central India, and you can see the public IP address as well here. So all this is here. You can actually like copy the public IP address and directly connect it through your remote desktop connection by pasting it here and connecting it, or you can just go to connect and go to RDP, and here you can like download the RDP file, the personal RDP file. Just for that one thing, remember you have to go back to that. You have to copy the IP for that. So you can see the IP is copied. So let's open the RDP. Yeah, go to connect. Yeah, so for that same IP, the RDP has been downloaded, so we don't require IP to paste. So you can just give the username and ID that we have given while creating the virtual machine. So that was and then the password credentials. Yes. So we have created the virtual machine and now we have connected it as well. So here is your service manager which has been opened, and here how your virtual machine is being created. So virtual computer is being created. Here you can see the dashboard, all the things like add roles and features, whatever you want to add, and get from here, or you can create your local server given all the requirements. You can create a local server as well and come to this PC, and here you can see all, like, this is the storage. You have got temporary storage and main program storage. So this is how we can connect the virtual machine. I hope you have understood it. So stop this session. Yeah. So I've closed the virtual machine, and I can even stop it from here. If I go here and stop, so that it stops, like the charging cycle gets stopped. You won't be charged for running the virtual machine here. So through this we can like save our cost. It is under process. It is getting stopped. Takes a little while. See, you can see the status as deallocating. Deallocating means it's getting stopped. So you can see it's successfully stopped, and after that you can even delete the virtual machine. So the virtual machine is getting deleted, and through this billing cycle was still going on for, because we had a virtual machine with us, so it got deleted. So virtual machine is, you can see, is deleted. Still other things are still there. If you want to delete the resource group as well, you can completely delete the resource group. You just have to type the resource group name. So delete. So all the services which are being under this will be deleted along with the resource group. So you can see, and just come to home, and now you can see there is no. Okay, let me go to the VM resource. The resource not found because it got deleted. Okay, let me refresh it once again. So yeah, there's no resource group anymore. So this is all about the virtual machine and how to create it, as well as how to delete it, and all the concepts behind it. So next is the pricing options. So for pricing option, you can just simply go for Azure Virtual Machine pricing. Let's see the pricing structure, how the pricing works for Azure Virtual Machine. You can see, like, you can select whatever the operating system you want to choose. You can choose that from here. Just a sec. Yeah, everything is there. You can choose as per your requirement. Like right now I'm going with I'm going with Windows OS only, and category I can choose like whichever I want to. Right now I'm choosing general purpose only. Pricing is getting updated here. You can see BS series, AV2 and standard, D2A assistant, all the standards are there. On the basis of that, pricing differs. And now if I choose the VM, just a second, Windows OS, choose the category that is general purpose. Then I have to choose the VM series. It is suppose I'm going to choose BS series, and then the region. Suppose I choose mine Central India. Currency, no in rupees or dollars, it's up to you. Like suppose I'm going with dollar only right now. I'm displaying prices by hour or by month, you can see, and then you can come to see the prices, right? For B1s, because we have choose the B1s, right? BS series. So B1s, that is the price dollar wise. Similarly, if you could go with a different series, like suppose we say this V5, then you can see the prices got changed. This is how it gets changed. So this is how you can look for the prices and go as per a requirement.
Let us start by taking a look at the definition first. Now, if I talk about the definition, this is what we have. It is Microsoft's multi-tenant, cloud-based directory and identity management service that combines core directory services, application access management, and identity protection into a single solution. Now, there's so many terms in it and so many things to understand. Let me simplify this definition so that you understand it in a much better way. To do that, I would be giving you an example. Think of it in this way. Suppose I am a cloud vendor, or not a cloud vendor, I am a service vendor and I reside on a cloud. That means I have a particular application that runs on cloud. Now, this service is used by quite a few customers. Plus, there are quite a few organizations that I have to interact with. Now, in this case, all these medias or customers and organizations, they have to communicate with me. So how do they do it? Well, what they would do is they would go ahead and create an account, or maybe have some user IDs through which they can actually communicate with me. Now, this is okay if the number is countable or manageable. Suppose there was a situation where we had a number of people and the number of people was constantly increasing. Suppose I have somewhere around 1,000, 2,000 people. Now, these many logins and these many credentials, managing all these can be a huge problem. Let me give you an example. How does this happen exactly, or what problems do you face normally? Suppose I have 10 organizations. Now, to log into all these or give access to all these 10 organizations can be a huge problem. Why? all these organizations might have different kind of accesses. Based on that, I have to set in different security protocols as well. If certain organizations have an easier protocol, what if they get an access to other organizations as well, or to the data that other organizations have to correspond to? In that case, it can be a huge problem. Apart from that, I might have n number of customers, and keeping track of so many customers can again be a problem when you talk about creating credentials. So all this is a huge problem. So what happened was Microsoft Azure, it went ahead and created something called as Azure Active Directory. It is nothing but something that acts as a middleware. It takes care of all the sign-ins and all these things. How? Now the users will have a single sign-on process. That means they would sign in only once. Plus, they can have access to the applications that are there, which I provide them. Now, this intermediary, that is your Active Directory, what it does is it federates all the responsibilities of taking care of access and all those things. That is, the way I set all the rules, it just incorporates those rules, and accordingly it gives access to all the users, thus simplifying all the complexities that I would face otherwise. So this is what an Active Directory exactly is. It basically goes ahead and simplifies all the signing in and user authentication processes, or identification processes rather. Now, as we move further, we would be discussing quite a few other terms, and you'd be having a clearer picture as to what I'm saying exactly. But meanwhile, you just bear with me and let's move further and try to understand what are the other points that we need to talk about. Okay, yes, I did miss out on this point. What Microsoft Azure does is it also gives you something called as a better platform where developers can develop their applications with a lot more ease. Again, as we move further, we'd be understanding this point as well. So what is the exact difference between Windows AD and Azure AD? Let's try to understand that as well. Now, when you talk about Windows AD, that is Active Directory, these are the layers it has to take care of. You have something called as your domain services, you have your lightweight directories, you have your federation services, certificate services, and rights management services as well. Now, these are so many things to take care of. When you talk about your Active Directory with Microsoft Azure, it combines all these layers into two. Firstly, you have your Windows Azure Active Directory. Now, it is something that takes care of all the services that surround or revolve around identity problems. That is, when you talk about identification management, this is the part that takes care of it. That is your WAAD. And then we have the other part where you have to actually go ahead and communicate with other organizations. I gave you an example of 10 different organizations needing 10 different things. That is federating all these organizations. Your Windows Azure Access Control Services, it takes care of all those things. So both these so-called active directories, they more or less serve similar purposes, but the approach in which they do is completely different. Your Active Directory has more layered approach where every service is given a different layer or different way of handling it. But when you talk about your Microsoft Azure Active Directory, it simplifies things. Your first layer takes care of most of the things, and the remaining things are something that is taken care by a Windows Azure Access Control Service. Also, when you talk about Active Directory, it uses something called as LDAP for various other communications. But when you talk about your Azure Active Directory, here you use something called as your REST APIs. Again, the approach is completely different. So what are the audiences that are catered by this directory? Well, first and foremost, we have IT admins. Now, when I talk about IT admins, what Microsoft Azure Active Directory does is it provides in single sign-on for various applications. Now, there are quite a few SaaS applications, that is software as a service applications, and various on-premise applications to which you have a single sign-on. You do not have to log in every now and then. Now, I've worked on quite a few applications, and places where you have to log in every now and then, you have a lot of trouble because you have to remember so many passwords and so many logins, and these different credentials can be a problem. Now, this is something your Microsoft Azure takes care of. Single sign-on is very convenient. Apart from that, it ensures strong identification, and there are quite a few processes that ensure this. Now, I won't be discussing those points in detail, but yes, when you talk about identification, Microsoft Azure ensures that it happens in a very good manner. Plus, it automates quite a few processes, again easing up this process. Apart from that, it also caters quite a few developers as well. Now, I'm talking about quite a few organizations, and since sign-on becomes easier here, your application developers can focus on building applications. And since they have access to so many organizations and so many resources, application development definitely becomes easier. Online customers. Now, people who have been working for quite a while, they might know that we have things like Office 365, or you have your CRM services as well. Now, you had an access to all these things by using your Windows Active Directory, but your Microsoft Azure Active Directory also gives you access to all these services. That means if you're using or have account on any one of these things, you can have access to all these services. or have access to all the Active Directory services that Azure has to provide to you. So what this does is it caters the needs of various online customers as well. So let us try to understand the next point, that is Azure Active Directory editions. For that, what I'm going to do is I'm going to go ahead and switch into the Microsoft's web page basically, or I'm going to switch into my browser and move to their website and talk about all these points. So instead, what I would do is I would first discuss the last point, and before we do go ahead and take a look at the demo, then we would just go ahead and talk about these points as well so that we can directly switch into the demo part. So let's move further and try to understand the next point and then come back to this point. So what are tenants basically? Now, when you talk about a tenant, it is nothing but an organization. I just mentioned that we have tens of organizations that a particular application might cater. Now, all these organizations are treated as tenants. All these tenants can have access to a particular Active Directory or more than one Active Directory. As we move into the demo part, I would be talking about how to create multiple directories as well. Yes, we can have more than one Active Directory. We'll discuss that as we move into the demo part. But before that, you just understand these points as in what I'm trying to say exactly. Yes, what happens here exactly is when you talk about a tenant, first and foremost, it is nothing but an organization, and it is a dedicated instance of your Azure Active Directory service. Plus, these are isolated instances. That means, as I've mentioned, we have 10 organizations or 5 organizations. You'd be having isolated instances for each of these organizations, ensuring that they stay aloof and their services and their protocols are maintained differently. This is where your Azure Active Directory steps in. It takes care of all these things. It ensures that nothing is ambiguous or nothing is intermixed. Everything stays separate. Plus, each and every platform or organization gets serviced equally well. As we move further, we would be creating users, and then I would give you the differences as in what a tenant is, how do you go ahead and create all the domains and all those things. So again, into the demo part, you'd be understanding these topics with little more clarity or more understanding rather. This is the demo part, but before that, as I've already mentioned, let me quickly switch to the website of Microsoft Azure, and I would be discussing the editions that you can choose from, and then we can directly jump into the demo part. Okay guys, so this is a Microsoft doc basically which talks about choosing an edition. So these are the options you have. We would be finishing this quickly and then we would be switching into the demo part. So let's understand this. Now, what Microsoft Azure does is it gives you various options. First and foremost, you have 3 options to pick from. And out of these 3 options, the first one is your basic option, that is your Active Directory basic. Then you have your premium, which is P1. And then you have one more premium, which is P2. All these things provide you with different options that you have. First and foremost, your main job is to have your access, that is your identity management, your security, and your single sign-on and all those things. Now, these are some of the services that come with your basic account as well, and also with your free account. What Microsoft Azure does is, for people who are completely new to this session and Microsoft Azure, let me tell you that you have a free sign into Microsoft account. That means you can go ahead and create your account there and avail these services for a certain duration, which are available to you for free. So yes, you do not have to pay anything. There you have a free account. In that, you'll be having access to some of these services. But if you need advanced services, then you have to pay for it. And for those things, you have 3 options. That is your basic, premium P1 and premium P2. Let's try to understand these one by one, as in what are these and what do they have to offer to you. Now, if you scroll down and if you take a look at this thing, you have your Azure Active Directory Basic now. This basic is nothing but it is designed for people who are task workers or who are focused on a particular application on cloud. Now, it takes care of everything, your single sign-ons, your SLAs, and it ensures that the security is 99.9%. And it provides you with all these features which you can see here, that is your self-service password resets and all those things. You also have access to quite a few things like your proxies and all those things. I won't be getting into the details of what proxies are and all those things. But yeah, for people who are admins and who have worked on these topics or in these domains, they would understand what do these things mean. So yep, you have access to all these things which fall under your basic option. Apart from that, you have something called as your premium P1. Now, this is for people who want to scale up. So when you try to scale up, you'd be dealing with quite a few things, and terms like your IAM and all those things would come into picture. Now, IAM is nothing but your identity and access management basically, which is a very important point when you talk about Active Directories. So yes, it provides you with these things as well, or these facilities as well, like identity protection, your security in the cloud, and all those things. Everything is taken care of for this particular model. Now, when you talk about premium P2, if I scroll down, this is what you have. It is designed for more advanced protection. That means you'd be getting all the services that were provided in basic and P1. Apart from that, you'd be having some additional services which ensure more security. That means it focuses more on privileged identity management. Now, again, this is something that you can read and understand. It is very easy, but to give you a basic difference, your first thing provides you with your basic services. That is, your basic access gives you basic Active Directory service access. Then you have your premium version, which is focused for scaling up. And when you talk about P2, it focuses more on advanced security. So these are the three different editions that you can choose from. Now, if you're somebody who is belonging to a particular organization and wants to go ahead and use these services, he can actually go ahead and read all these things and then go ahead and take a decision accordingly. Now, what I'm going to do is I'm quickly going to go ahead and switch into the demo part. For that, I need to go ahead and open my Microsoft Azure account. So let's do that. Well, my internet is kind of slow today, so it might take a little longer while than normal. I can click here on portal and there you go. It would ask me to sign in. I would be using a dummy account today for this so-called demo. I wanted to give you an access to or view to quite a few directories and all those things. So that is why I did go ahead and create an account and or certain Active Directories created or basically certain accounts created. Now, this is how the Azure portal looks like for people who are completely new. Again, you have your dashboard here. Apart from that, you can actually go ahead and create quite a few things. That is your virtual machines, your data factories, and all those things. For people who want to know all those things, they can actually go ahead and refer the other videos that are there in this series, and you'd know quite a few other things as well. But as far as this session goes, we are here to talk about Active Directory. So let's head into it and try to understand how do you go ahead and create Active Directories and all those things. Now, how do you navigate to a particular Active Directory? Now, if you scroll down here, you'd be seeing an Active Directory here. For people who have an account on Microsoft Azure and have access to all these things, they would have an Active Directory by default. So you just have to come here and click on it, and a particular dashboard would open up for you people as well. Now, this is how it looks like. You have all these things, an overview, getting started. You have users, groups, which you can manage and monitor. You have devices you can connect to, your various app registrations. As I've told you, you can manage multiple applications as well. Now, in that case, what happens is, as I've mentioned, you might be dealing with multiple applications. So a particular user, what applications should he have access to? What domains does he have access to? What are the devices that are configured? All these things can be controlled or managed from here basically. So this is what your so-called Active Directory does. Now let's move further and try to create some users. Now, how do we do that? Well, I can click on this icon here and it would give you the list of users that are already there. As you can see, there are quite a few users here. This was a demo account, so we did go ahead and create so-called users so that you can have a look at them. This is something that I created yesterday. That is Chris Pratt. Now, how do you go ahead and create an account? I would be talking about all these things. To give you a start, you have to click on this thing, new users, and this window opens up. Now again, I'll have to go back and show you something else. How do we deal with all these things? Well, first and foremost, you need to give in a pseudonym or a name of the person for which you want to create a user. Apart from that, you need a particular domain name or yes, a domain name for a particular domain service. Now, how do we get that? Now, these domain services have to be registered with your so-called Azure Active Directory. So I have these accounts here, right? So I can use one of these accounts to just go ahead and create a particular user. Suppose I want that user to be assigned or maybe associated with this ID. So I can select this domain service extension basically. Again, click on new user. So what name should I give to this particular user? Now, I am a huge cricket fan and recently I watched England's match. So let's pick name of one of the players that belongs to England team. Say Sam Billings, and again, this is where I would be creating the user. Say I say Sam Bill as a pseudonym, and I give in this domain details that is at edureka.tk. Now this is something that is configured already. That is why I can use it and I can have an account. If I used an ID that was not registered with this Azure account, I wouldn't have been able to create this user because it would have given me a particular error. As we move further, we would be taking a look at that as well. But for now, let's go ahead and create a legitimate user, that is this one. Now it verifies whether the name is proper or not. Name is something you can use in any which way you want to, but your username has to be legit and valid. So I have these details which I've entered. Configuration not required, properties can be default, and if I have to assign him a role, I can click here. You can see the name is verified here as well. let's make him a global admin maybe. And again, you'd be given a password here. If you say show, it would show you the password, and I would suggest that you note it down because you would be required to go ahead and log in. And in that case, you might be needing this password. So a suggestion that you note it down. I say okay here and I create the user. Now it might take a while because at times there are certain things that take a while, but in this case, it has happened pretty quickly. So as you can see, we've gone ahead and created a user. His name was Sam Billing, if I'm not wrong. So yes, there you have this account, which is Sam Bill. And if you click on it and open it, you can have access to that account where you can enter in other details, what applications that are there under this user, and what applications do you want to assign, which devices do you want to configure, and all those things. If you scroll down, you have some other options as well, sign-ins and audit logs. Now I won't get into the details of these things, but you can assign all these things to this particular user as well. So yeah, this is what the user looks like, and you can actually go ahead and log into this Azure account through this user profile as well. We can do that. What I'm going to do is I'm going to go ahead and create or open an incognito window where I'm going to go ahead and log in as this user. Let's just say incognito. And now if I try to log in, I would have to enter in the details. I've actually gone ahead and tried logging in, but I've forgotten the credential details. So let me just quickly switch to this window, copy this email ID, and again switch here. So this is the email ID which we have, Sam Bill, next. And my password was, I hope it is right. Yes, so when you log in for the first time, it would ask you to enter the current password. And then you can enter the new password, let's say. And then you re-enter the password. There you go, and you sign in. So what happens is you enter into this portal as a fresh user. See, I'm a completely new user and it says, do you want to start at Tor? But I don't want to do that, so I would just say maybe later. There you go. You have your fresh dashboard. There is nothing pinned here and everything is completely new. So yep, you've entered in as a completely new user. And this is the Active Directory where I'm assigned to. That is my previous Active Directory. As you can see, this is what we have here to offer. So yes, as a user, I have certain privileges and I can have access to this so-called portal. So this is something I wanted you all to see. There are quite a few other things which we are going to go ahead and take a look at it. But for now, let me just log out and close this tab. I'm back here. The other things I want you to understand, and those things are, if I come here, what you can say is we have certain users here, right? There you go. Now, if you take a look at certain email IDs, you can see these email IDs. Now, these are quite huge email IDs, right? What happens is when you do go ahead and register your domain service, you register that domain service with Microsoft Azure account. And when you do go ahead and create users, you would not want to have such use names. That is, say, for example, Vishal at Microsoft something, 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 something. That can be long, right? And that is complicated to handle or manage. So instead, what you can do is you can provide them with pseudo identities or pseudo IDs as well, so that the process becomes easier or simpler to handle. Let's try to do that and see how can we do that. Can we just go ahead and assign a particular domain name or a domain service when we just go ahead and create a new user or all those things? So in order to add a particular domain, what you have to do is you have to go ahead and again, where is my Active Directory? Here it is. And I just kind of scroll down. You can see custom domain names, where you can actually go ahead and add domain names, but there are certain catches to it. Let's try to understand those. Now it would ask me to enter a custom domain name, and I say demo domain maybe. Yeah. And let me give it some extension. Now, again, let me tell you that this is a demo practice and it won't take in this particular domain name. I'll tell you why. But first, let's just try to add this domain. Yeah, the domain name is added. But as you can see, to use demo domain.add with Azure AD, create a new text record with your domain name registrar using the info below. So if I say text, I need to copy this part and I have to actually go ahead and add this to my particular domain name. Now, I won't be going ahead and doing that because that is something that we are not discussing here, because for that, we would be needing some other domain name, which I do not have right now with me. So if you do go ahead and try to add a particular domain name, you need to have that particular domain. That is, suppose I'm using a particular website or I have a particular organization which has a particular website or a domain name that is xyz at xyz.com or something like that. So I need to make sure that I go ahead and register or have access to that particular domain. And then I need to go ahead and attach this particular text to it or authorize this text with it so that I can actually go ahead and confirm with Microsoft Azure that yes, I have an access to that particular domain. And only then can I go ahead and use this particular domain with my Microsoft Azure. Now, if I click here on verify, it would give me an error that I'm very sure of. See, could not find the DNS record for this domain. DNS changes may take up to 72 hours to propagate. That means I have 72 hours to go ahead and add this particular text message to that domain, and so that I can verify that yes, this domain is legal. But in this case, it isn't. I just took something for the demo purpose or for the reference sake, and this is the domain that I might have or which I can actually go ahead and use. So yeah, this is how you actually go ahead and add a particular domain, and you can actually go ahead and create a user as well. What you have to do is when you do go ahead and register this particular domain, you can just go ahead and follow the processes like creating a user, which we did in the previous case, because that was the registered domain. When I used that so-called edureka.tk, it was registered with my so-called Azure account, and I could actually go ahead and register that particular user. But in this case, I cannot. But yes, if you do go ahead and create a particular domain, or you want to go ahead and create a particular domain or register a particular domain, make sure that it is valid and it is under use. And you can actually go ahead and register that particular domain by using this particular process. So yeah, this is how you actually go ahead and do all these things. Now, when you have this particular domain, which is not registered, and if you do go ahead and create a particular user on it, what happens is your Microsoft Azure would let you create that user, but the credentials or the access that user has is as a guest user, because your Microsoft isn't sure that this domain which you just created is actually registered or something that you can actually go ahead and use. So that is one point which you need to consider. Now let me just quickly go back to my Active Directory and see if there are anything or any points that I need to discuss with you or something that we have missed upon. So what I'm going to do is I'm going to talk about something else called as creating an Active Directory. Or can we create multiple Active Directories? That is a question. If you ask me, I would say yes, definitely you can create multiple directories. Now, as you see here, if I go to a particular directory, I would be having an option called as switch directories. Now, if I click here, I have certain options from which I can pick a default directory. Now, in my case, I have quite a few directories which I can actually go ahead and choose from. But I want to give you all a demo as in how do you go ahead and create one, because these are something that we have created for the practice purpose or certain usage purpose. So let's go ahead and create a fresh one. So how do we do that? Can we just go ahead and create one? Well, yes, definitely we can create one. If you just scroll down, you have certain options here. We had an option of creating a new directory. Let me just go ahead and see where that option is. See, here's this option, create a directory. So let's start by giving it certain names, say Edureka 1, 2, 3, 4. Not 1, 2, 3, 4. Let's call it say Edureka, maybe. Is it there? Yep. And what should be the domain name? Edureka 121. Edureka 121. State, well, since I'm from India, let's stick to India. And I say create. Now it might take a couple of minutes when you just go ahead and create this so-called directory. So yep, meanwhile you bear with me. And there you go, you have your directory here. You can just click on this thing to manage your directories. As you can see, it's a completely new directory, which is fresh and new to use. That means, as you can see, it's Edureka. And if you click on any one of these things, you won't be having anything else. Now, in my previous Active Directory, I had so many users. Now, if you come here, you'd see there's just one user, main admin. I do not have anything else or no other user whatsoever. That means this is a fresh directory. Like as you can see, if you just go back to the Edureka option, you'd be having an option of resetting your so-called directory, and you can do that as well. But I do not want to do that for now. I can just click on this and I go back. See, here's the option. You can click on it and you can switch the user. So yeah, you can use multiple directories and you can have multiple users for these directories as well. Now I can just go ahead and create users for this directory as well, but I won't be doing that. Now, since I do not need this directory, I'm just going to go ahead and delete it. So I click on this icon. I do not have permissions probably, so I click on it and I ensure that permission is granted. I say yes and I save changes. It might take half a minute to update these properties, or if the internet is slow, it might take longer as well. There you see, the changes have been updated. Now, if I refresh this thing, the access is given to me. I can just I don't want to delete the dashboard. I just want to go ahead and delete my so-called Active Directory. Okay, so I do not have an access to my domain services, because of which I'm not able to delete this account. But yeah, you normally have an option where you can actually go ahead and delete this directory. So yep, you can go ahead and do that as well. So yeah, this was the demo about Active Directory, as in how do you go ahead and create a user, how do you create a particular domain space or domain service basically, how do you go ahead and create multiple Active Directories.
So our first topic is, what are ARM templates? So as you can see in the definition, ARM template is a block of code that defines the infrastructure and the configuration of your project. So here it means that it is a way of deploying infrastructure as a code to the Azure environment. So here you create a project in that you define the objects you want, and you also specify their properties, names, and their types, and you convert it into a JSON file. And once you upload this file into the Azure, what does ARM API do? It understands the whole code, which is in the JSON file. So here, the JSON file is then checked into the source control and managed like any other code file. So here, what ARM templates are like, they give you the ability to roll out within the Azure environment. So it can contain the contents of the entire resource group, like they can manage the whole resource group, or it can also contain one or more resources which is assigned under that particular resource group. So when a template is deployed, you have the option of either using complete or the incremental code, like part by part codes. So if you go with the complete mode, it deletes any object that are not visible or that does not appear within the template. Okay. So if you have a template and in that, if you are not able to see any objects, so you can delete from those resource group which you're deploying. So in this scenario, whatever you're deploying into the resource group, like you will see that many amount of objects into that particular resource group. In the incremental deployment, it uses basically the template to the additional resources to an existing resource group. So the benefit of this is that you don't lose any infrastructure that is missing from the template, but the downside is that you will have to clear up old resources from the other way. So it's like whatever new resources you are adding into the existing resource group, that won't delete, you are able to see those. But once you are adding new, then you need to filter out the previous resources as well. In this case, the ideal deployment is complete, but it does mean that you need to have a good automated deployment pipeline with at least one test environment where you can validate that template and it doesn't rip the heart of your production. Like it should not ruin your management. Now that we've come to know what are ARM templates, now let us see why choose ARM templates. So how are they useful to us? What makes it so special? So there are a few advantages which validates that how ARM templates are useful to use in Azure environment. So we'll look onto them one by one. So our first is declarative syntax. So what does it means is that the RM template allows you to create and deploy the entire Azure infrastructure declaratively. So it means here that if you're using the RM template, you can create it while declaring all the codes in the JSON file. You declare your needs, your properties, and everything. It is very declarative. You declare, then it allows you to deploy it in that way itself. Okay. For example, you can not only deploy virtual machines, but also network infrastructure, storage systems, and any other resources that you need within that Azure environment. You don't have to go one by one, like first you create virtual machine and then you can go to storage account. You can create it at once. Next is repeatable results. So here you can repeatedly deploy your infrastructure throughout the development lifecycle and you have the confidence that your resources are deployed in a consistent manner. It is not key you can only deploy once, you can deploy it more than one time. So and you get the consistent results out of it. Like whenever you deploy, you will get that much appropriate results consistently. So here The templates are idempotent, which means that you can deploy the same template many times and the same resource types in the same state. So if you have created a template, you can deploy it more than one time. So whenever you deploy, the resources under it will give you the same results. You can develop one template that represents the desired state rather than developing lots of separate templates to represent updates. Next is orchestration. So, what do you mean here is that you don't have to worry about the complexities of ordering operations. So, the resource manager orchestrates the development of interdependent resources so they are created in the correct order. So, here you don't have to worry that in which order, like you don't have to think that which one should be deployed first, which one should be deployed second. So, ARM template manages, it reads the code and it manages itself and it makes it in order which has to be deployed first, which has to be deployed last. So it is done by the ARM itself. You don't have to do it manually. When possible, resource manager deploys resource in parallel so your deployment finish faster than serial deployment. It can also manage your time by just deploying the resources parallelly. So it can do the multitasking work, like it can deploy two resources at once so that you get the faster results. And you don't need so many commands to it. You can just deploy the template through one command rather than through multiple imperative commands. So here you just need to like hit a command to run this particular template and it all your other tasks are done simultaneously. Next is modular files. So here you can break your templates into smaller reusable components and link them together at the deployment time. You can also nest the one template inside the another template. So you can break down these templates into one or more parts and then you can link them. You can also just create a nested loop out of like you can create a proper chain how your deployment should process. Next is you can create any Azure resources. So as we said, you can immediately use new Azure resources and features into the templates. As soon as a resource provider introduces new resource, you can deploy those resources through these templates. So you don't have to like wait for the tools or modules to be updated before using the new services. If you want that particular service to be included in your template, it automatically grasps that particular service and it makes it ready to deploy. Next is testing. So when we talk here about testing, you can make sure that your template follows recommended guidelines by testing it with the ARM template toolkit. So what does it do? It helps you like to test whether your whole process or your whole project is running smoothly and based on the requirements or not. So the test kit is a PowerShell script that you can just download from GitHub or any portal. So the main benefit of this toolkit is that it makes it easier for you to develop expertise using the template language itself. Everything is within the ARM itself. You don't have to have a separate testing toolkit for it. All right. Okay, so one of our folks named Rohan has asked, is there any other toolkit available? So as I said, Rohan, the testing process is within the ARM manager. So ARM itself has its own toolkit. So when you're deploying a particular template into that ARM API, so once it is in the process of deployment, it checks once it is deployed, it will automatically go under the testing process and it will test the whole template over there. So you don't need an extra toolkit for it because ARM is one whole soul thing. It is managing your services, it is managing your resources, whatever you're deploying into the Azure. Lastly, once it is deployed, it is also testing it whether that particular resource is working smoothly or not. I hope you got clear with this. Moving ahead, we have deployment blueprints. So before we see what is the advantage of these blueprints, let us understand what are basically blueprints. So just as blueprints allow a particular engineer or an architecture to sketch a project's design or the parameters. So Azure Blueprints is also one kind of them that enables the cloud architects or the central information technology groups to define a repeatable set of Azure resources that implements and adheres to an organization's standard patterns and requirements. So basically, the blueprint makes it possible for the development team to rapidly build and start new environments with same trust that they are building within the organizational compliances with a set of built-in components such as networking, speeding up of development and the delivery. So basically it is a declarative way to orchestrate the deployment of various resource templates and other artifacts such as role assignments, policy assignment, ARM templates itself, resource groups. So, what is the advantage of deploying blueprints is like you can meet the regularity and the compliance standard. So, these blueprints include pre-built templates for various architectures, which will help you organize your work as well as fasten your deployment rate. Next is track deployments. So in Azure portal, you can review the deployment history and get information about the template deployment. And you can also see the template that was deployed, the parameters value passed in, and any output values. Other infrastructure as a code service aren't tracked through the portal. So here, whatever your deployment history, you can track down the deployment history. You can also get to know which template has been deployed and what were the parameters under that particular template and what output did you get out of those templates. So you can keep a track of each and every deployments. Next is exportable code. So here you can get a template for an existing resource group by either exporting the current state of the resource group or viewing the template used for that particular deployment. So viewing these exported template is a helpful way to learn about the template syntax. Lastly, policy as a code. So Azure policy, as we know, Azure policy is a policy as a code framework to automate the governance. So if you're using the Azure policies, policy remediation is done on the non-compliant resources when deployed to the template. So these are some of the key benefits of the advantages of ARM templates, which makes it more useful within the Azure environment. Now let us understand what are templates. So basically, the template is a JavaScript object notation or a JSON file that defines the infrastructure and configuration of your project. As we had discussed before, to create a particular object or if you want to run a particular resource, you need to specify what services you want to use and what are the parameters, its properties and its name and all the information into a JSON file and then you upload it. So it becomes a template. The JSON file is nothing but a template that is run inside the ARM, that is nothing but Azure Resource Manager. So the template uses a declarative syntax which lets you state what you intend to deploy without having to write the sequence of programming commands to create it. So in the template, you specify the resources to deploy and the properties for those resources. That is nothing but in the JSON file, you specify each and everything. What are the properties, whatever resources you want to deploy. And it becomes a template form and it gets deployed in the ARM. Now that we have understood what are templates, now let us understand the template design. So defining the templates and the resource group is entirely up to you and how you want to manage your solution. For example, you can deploy your 3-tier application through a single template. So as you can see in this diagram, so this is a 3-tier template. All right. So in this template, you can run 3 types of application, that is virtual machine, app services and SQL database. And it can be done within the one resource group itself. So here you don't have to define your entire infrastructure in a single template. Often it makes sense to divide your deployment requirements into a set of targeted purpose specific templates. But you can easily reuse these templates for a different solutions. So now if you see in this another diagram, you can also deploy a 3-tier solution through a parent class or in the nested form. So as you can see here, this is a parent template. Under this, we have created sub templates. That is, one template is for virtual machine, the second template is for app services,
and the third one is for the SQL database. So here you can create it in the nested form as well. So it depends upon you how you need to design your own templates. And you can create different resource groups also, or you can add them into a single resource group. Now let us understand how do ARM templates work. So as you can see in this diagram, the ARM templates actually work on the hierarchical scope level. So as we know, there are different ways to create our resources like Azure Portal, Azure PowerShell, and Azure CLI. And apart from the Azure environment, we also have the third party clients, those are REST clients. So these are the different ways through which you can create your own resources and your resource groups as well. Once you start creating the resources in the Azure environment, so whenever you're creating a resource group or you're opting for a new service, so what happens that in the backend there creates a JSON file that is nothing but an ARM template. So as we discussed that ARM template is all about the JSON format. It has the JSON syntax. So whatever resources we would be creating or whatever services we would be opting within the Azure environment, that would be converted in the backend as the JSON file. And that JSON file then goes to our API, that is nothing but Azure Resource Manager API. So what does the Azure Resource Manager API do is that extract that file and then understands what are the requirements in that particular template. And for that, like now, if you're opting for a resource for any services from Azure, you always need a subscription. So it will check whether you are subscribed to Azure portal or not. Then based on your subscriptions, it allows the particular resources to get deployed. So once your subscription is authenticated, then you have a resource provider. So in the ARM template, we specify what are the different services we want to opt for or what and all resources we require within the Azure environment. So it goes automatically into a resource provider. And within that, we can run multiple objects that are nothing but our services. For example, virtual machines, app services, storage account, and SQL. So this is how ARM templates or the whole Azure Resource Manager work. So in a just if I call it as is like whatever resource you are trying to create in the Azure portal or through PowerShell or through CLI or from any third party application. So it does have a template and in the backend, which is then extracted by the RM, that is a Azure Resource Manager API. Then it processes the particular template for the deployment based on your subscriptions. Now we know that how templates usually work. It uses the JavaScript object notation syntax that also includes the advanced capabilities. So in this particular syntax, we have the different components. So the first component is the parameters. So what are actually parameters? So here the parameters allow you to pass the different values to the ARM template for use during the deployment. Some common examples like you can include the names of the resources or which Azure region to host them. So what do they do is it enables your templates to be more dynamic and used across the different environments. So parameters require a name and a type. So here you can include strings, array, objects, integers, boolean, or any secure string like password. Optionally, parameters also contain the description of how to use these particular parameters. So you can include default values to your parameters so that you do not need to provide one at runtime and you can configure it with a set number of values. So this configuration is helpful when you want to limit what SKUs or location a person can deploy the resources. The next component is functions. So in ARM template, functions allow you to create complicated expressions that you don't want to repeat throughout the template. So here what functions actually do is there are a lot of functions in other programming language. Like when we code, you add on different kinds of functions, like more than one function you can add. So you have a list of functions into it. But Here you can tell them when you need to run them, and you can pass informations to them and expect the return value from there. For example, say you need to create a unique name of a resource. So instead of copying and pasting the same code to generate the unique name, you can create a function that makes the unique name. For example, if a function called as unique name with a parameter named prefix returns a unique name using the resource group ID. So here, note this namespace value. So this value can be anything you want. So here the functions require a different namespace value to avoid a naming conflict with the regular template function. Next is variables. So variables are not much different in ARM templates that you find it in other programming languages too. Here, the variables contains the values that are used repeatedly throughout the template. Like functions, you can use variables to create complicated expression. Like functions, you can also use variables to create complicated expression so that you don't have to repeat them into the same template. And like parameters, variables have the same data types such as strings, objects, and integers. So you can define variables using colon as a signed operator. For example, instead of passing the Azure region as a parameter, you can define it as a variable. So you can just type down location, and whichever required location you need, you can specify there. Next are resources. So what are resources basically? So the resources defines the Azure resources to deploy within the particular template. So the resources can be anything as small as a network security group, all the way to, like it can be virtual machine, storage account, or functions, or any other services which are within the Azure environment. So when you specify a resource, so you have to give a couple of explanation in each part. Like you need to specify the name of the resource, and then you also need to give the type of the resource you need to deploy. Whether you need to like refer to the high level family of the resource to deploy. For example, like Microsoft.compute, Microsoft.storage, or .network. So this will help you out to map out these resources to deploy more precisely. Next, you need to also specify the API version, that is like to check the configuration of that particular resource. So you also specify the dependencies. So here dependencies determine the order of Azure, how Azure should deploy these particular resources. So for example, if an ARM template is deploying a virtual machine and then a virtual network, so the virtual machine will exist first before creating a virtual network. And then you start giving up the properties. So here the properties contain the configuration information for the deployment. And last is the output. So the output section will define the values and information returned from the deployment. It is helpful for the data that Azure dynamically generates through the public IP address. So these are the key components that are used in ARM templates and which will help you to work with these Azure Resource Manager. Now that we have an overview on the ARM templates, and all the key concepts related to ARM templates, now let's have a quick demo and let's see how do they actually work. So for that, let's quickly move on to our Azure portal. So we need to first log into our Azure. So let's quickly sign in. So this is our Azure portal. Now, as we had discussed that there are different ways, like you can use the portal itself to create your services. As you can see here, there are different services you can opt for, like create a resource group or service bus, virtual machines, application gateways, etc. And you also have your CLI, that is your cloud shell. So you can even run your commands, and you can create your resource group. So let's see how are these templates created while we create a resource group or any resource through Azure portal. So let's quickly create a resource group first. So as you can see, we don't have any resource group yet. So let's quickly create a resource group. So we'll give any random name to it. So as it is ARM, let's give it a name as ARM demo 123. And You can choose any of your region as it's up to you, like of your choice based on your requirements. So I'll take West US because that region is more free. So let's review and create. And your validation is passed. Let's create. So when you see over here, your resource group has been created now. And now you can also see your ARM demo has been automatically created. I will just go inside. So now that we have created a resource group, now if I just go into their properties, like we just click onto this resource group and we'll just go to their export template. So here you can see the template has been created. So this is a snippet code where it shows whatever object you have created. So under that, what are the parameters and what are the variables you need to add. This happens in the backend once you create any resource or any resource group. So one of our folks have a doubt. Tejaswini has a doubt that how does these template create? So Tejaswini, as we had discussed before, that whenever you create anything in the Azure, no matter if it is a resource group or if you're using any services, so whatever resource you're creating, either it is through Azure portal or PowerShell or CLIs. So in the backhand, it automatically creates a JSON file. In the backend, it automatically creates a JSON file, which then becomes a template. It is formed in the backend process so that it goes to the ARM, that is our ARM API, Azure Resource Manager API, then it can process the rest of the resources accordingly. All right. So it is formed automatically. So whenever you create any resources or any services you're applying to or you're utilizing any resources and you create any resource, so it will create a template and that template will then go to the our ARM and from there the whole process of the deployment starts. I hope you got an answer to your question. So as we have seen that we created a resource group and as we go under their overview, you just come into these export template and here you find out your template, that is the JSON file, and you can even download it or you can send it to deploy as well. So now what we'll do, we'll create a resource within this resource group. So you can take any resources. So I'll just take up the storage account. Let's create a storage account at first. And our resource group is ARM demo 123. And now let's name our storage account as well. And we'll change our location. All right. And our performance would be standard because as our subscription is free and it is only for the demo purpose, so we'll be keeping everything as it is and we'll just review and create. All right. So here, as you see, they are initializing the template deployment to the resource group. So as I said, whatever resource you're creating, it automatically creates a template of that particular resource within that particular resource group. So now once it gets deployed, we'll see. So here you see the overview, the input and outputs and your template. So we'll just get into this and you see, this is the ARM template of our storage account. This is how your ARM templates are created.
Let us understand what is Azure DevOps. Now, Azure DevOps provides developer services for support teams to plan work, collaborate on code development, and build and deploy applications. Azure DevOps supports a culture and set of processes that bring developers and project managers and contributors together to complete software development. It allows organizations to create and improve products at a very fast pace than they can with traditional software development approaches like the waterfall approach. You can now work in the cloud using Azure DevOps services or on premises using Azure DevOps Server. So you have two options. Now, Azure DevOps provides integrated features that you can access through your web browser or IDE client. Now, you can use one or more of the following standalone services based on your business needs. The first one that we'll be talking about is Azure Repos, which provides Git repositories or team foundation version control for source control of your code. Azure Pipelines, on the other hand, provides build and release services to support continuous integration and delivery of your applications. Azure Boards delivers a suite of agile tools to support planning and tracking work, code defects, and issues using Kanban and Scrum methods. Azure Test Plans, on the other hand, provides several tools to test your applications, including manual or exploratory testing and continuous testing. The last component is Azure Artifacts, which allows teams to share packages such as Maven, NPM, NuGet, and more from public and private sources and integrate package sharing into your pipelines. Now that we know what is DevOps and Azure DevOps, let's understand how to implement continuous integration. Before that, we have to understand what is Azure Pipelines. This is really important. Now, Azure Pipelines automatically builds and tests code projects to make them available to others. That's all it does. So it works with just about any language. It could be Java, Python, or project type. And these pipelines combines continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target eventually. Now, you must be wondering, what is continuous integration? Continuous integration is the practice used by development teams to automate the merging and testing of code. Implementing continuous integration helps to catch bugs way early in the development cycle, which makes them less expensive to fix. Automated tests execute as part of the continuous integration process to ensure quality. Artifacts are produced from continuous integration systems and fed to release processes to drive frequent deployments. The build service in TFS helps you set up and manage continuous integration for your applications. Now, continuous delivery, on the other hand, is a process by which code is built, tested, and deployed to one or more test and production environments. Deploying and testing in multiple environments drives quality. So, continuous integration systems produce the deployable artifacts, including infrastructure and applications. Automated release processes consume these artifacts to release new versions and fixes to existing systems. Monitoring and alerting systems run continually to drive visibility into the entire continuous delivery process. The release service in TFS helps you set up and manage continuous delivery for your applications. Azure also has continuous testing on premises or in the cloud, which is the use of automated build, deploy, test workflows, and with a choice of technologies and frameworks that test your changes continuously in a fast, scalable, and efficient manner. Implementing CI/CD pipelines helps to ensure consistent and quality code that's readily available to users. And Azure Pipelines provides a quick, easy, and safe way to automate building your projects and making them available to users. The next question that arises is, why should one use Azure Pipelines, right? So the first and the most important benefit of using Azure Pipelines is it works with any language, any platform. That's one of the biggest advantage. And the next advantage is that it deploys to different types of targets at the same time. It also integrates with Azure deployments. It builds on Windows, Linux, or Mac machines. That is, it works on any OS. And it also integrates with the biggest and the most popular code hosting website, that is GitHub. It also works with open source projects. So this is definitely why one should opt for Azure to create their pipelines. Now let's move on and learn the differences between continuous integration and continuous delivery. Azure Pipeline supports continuous integration and continuous delivery to constantly and consistently test and build your code and ship it to any target. Now you accomplish this by defining a pipeline. You define pipelines using the YAML syntax or through the user interface, that is the classic way. Continuous integration. So in continuous integration, the tests are automated and builds for your project. Continuous integration also helps to catch bugs or issues early in the development cycle when they're easier and faster to fix. Items known as artifacts are produced from continuous integration systems. They're used by continuous delivery release pipelines to drive automatic deployments. Continuous delivery, on the other hand, automatically deploys and tests code in multiple stages to help drive quality. Continuous integration systems produce deployable artifacts, which include infrastructure and applications. Automated release pipelines consume these artifacts to release new versions and fixes to the target of your choice. Now that we know the difference between continuous integration and continuous delivery, let's move ahead and learn how to create Azure pipelines. So the first way to create Azure pipelines is to define pipelines using YAML syntax. You define your pipeline in a YAML file called Azure pipelines.yml with the rest of your application. The pipeline is versionized with your code and it follows the same branching structure. So you can get a validation of your changes through code reviews in pull requests and branch build policies. Every branch you use can modify the build policy by modifying the Azure pipelines.yml file. A change to the build process might cause a break or result in an unexpected outcome, so be careful. And this occurs because the change is in version control with the rest of your code base and you can easily identify the issue. So the first step is to configure Azure pipelines to use your Git repository where you're going to edit your code, where you're going to really write, where you're going to really store your entire project. And then you're going to edit your Azure pipelines.yml file to define your build. In the third step, you're going to push your code to your version control repository. And this action finally kicks off the default trigger to build and deploy, and then eventually monitor your results. So once the pipeline has been created, your code has been now updated, built, tested, and packaged. It can then be deployed to any target that you'd like. There's also another way to create your Azure pipelines, that is to define pipelines using the classic interface. Now here you create and configure pipelines in the Azure DevOps web portal with the classic user interface editor. So what you do is you define a build pipeline to build and test your code and then to publish artifacts. You also define a release pipeline to consume and deploy those artifacts to deployment targets. So here the first step is to configure Azure pipelines to use your Git repository. Then you use the Azure Pipelines Classic Editor to create and configure your build and release pipelines. Then you finally push your code to your version control repository. This action triggers your pipeline and runs tasks such as building or testing codes. The build creates an artifact that's used by the rest of your pipeline to run tasks such as deploying, to staging, or even production. So the tasks that are released is termed as continuous delivery, and the part where you're building tasks and testing them is termed as continuous integration. Now that we know how to create your own Azure pipelines, let's go ahead and learn to set up release management workflow. So the first thing that we're going to learn is how to design a release strategy. So we have to understand what is release pipelines. Okay, so release pipelines enable teams to continuously deploy their application across different stages with lower risk and with faster pace. Deployments to each stage can be fully automated by using jobs and tasks. Teams can also take advantage of the approvals and gates feature to control the workflow of the deployment pipeline. Here, each stage in a release pipeline can be configured with pre-deployment and post-deployment conditions that can include waiting for users to manually approve or reject deployments and checking with other automated systems that specific conditions are met. In addition, teams can configure manual validations to pause the deployment pipeline and prompt users to carry out manual tasks, then resume or reject the deployment. By using gates, approvals, and manual intervention, you can take full control of your releases to meet a wide range of deployment requirements. You can also release deployment control using gates. Gates allow automatic collection of health signals from external services and then promote the release when all the signals are successful at the same time or stop the deployment on timeout. Typically, gates are used in connection with incident management, problem management, change management, monitoring, and external approval systems. Some scenarios and use cases for gates are incident and issue management. Here, you ensure the required status for work items, incidents, and issues occur regularly. For example, now you have to ensure deployment occurs only if no priority zero bugs exist and validation that there are no active incidents take place after deployment. Also, another scenario would be to seek approvals outside Azure pipelines. Here, notify non-Azure pipeline users such as legal approval departments, auditors, or IT managers about a deployment by integrating with approval collaboration systems such as Microsoft Teams or Slack and waiting for the approval to complete. In another scenario, there could be quality validation. Query metrics from tests on the build artifacts such as pass rate or code coverage and deploy only if they are within a required threshold. There are many other use cases like security scan on artifacts, user experience relative to baseline, change management, infrastructure health. There are many scenarios that you can use gates for. So this is a really important topic. Moving on, let us learn how to implement compliance and security. Firstly, we will have to design a dependent management strategy. Before we learn how to design one, we will have to understand what is dependency management. Now, with modern software architectures and development methods, software dependencies can come intertwined quickly. With more online repositories like GitHub, Docker Hub, pre-built libraries and services can be easily published and leveraged. Now, these projects can be managed by all sorts of individuals or groups and have a very wide range of work ethics, from well-maintained solutions with good community and multiple contributors and release schedules. That is all the way to the other end of the spectrum. Code is also developed internally and is often reused. Wherever the source comes from, the problem is the same. Once implemented, one project now has a dependency on other. Now, for example, when a team comes together to build a solution, they may decide for various reasons to leverage code that already exists. Now, depending on the type and language used for that particular project, there are different sources that can be leveraged to accelerate development. For example, let's say you're running a .NET application that's going to be processing JSON that you retrieve from Azure to describe Azure resources. Now, rather than having to write all the logic to handle the JSON file, your team decides to leverage a popular package called newtonsoft.json, which is a publicly available package. You could leverage the NuGet package that's already been built and published for consumption. By leveraging this package in your code, you have created a dependency on the package for your solution. Now, you must be wondering, what is a package? A package is simply a standardized way of distributing codes that can be consumed by another application or solution. Metadata is used to help store and version and identify these packages. So there are different types of packages, right? So these artifacts can be NuGet, NPM, they can also be Maven, and all of these are a part of the packages. Okay, so we'll be talking about NuGet. So NuGet is a free open source package manager designed for the Microsoft development platform used in .NET since its introduction in 2010. NuGet has evolved into a larger ecosystem of tools and services, so it is distributed as a Visual Studio extension. The NuGet packet has a NUPKG suffix and as a zip file with a specific folder structure. Maven packages, on the other hand, are often used for Java projects. Maven can also be used to build and manage projects written in C#, Ruby, Scala, and other languages. Now, a project object model file describing the metadata of the project is also stored within this package. NPM, on the other hand, is a package manager for JavaScript programming language, and it's primarily used for runtime environments with Node.js. An NPM package contains a package.json file describing the metadata of that package. The Python package index is a repository of software for the Python programming language. Python's packaging is built for distributing reusable code called libraries between developers. Now, these packages are libraries used as building blocks to create applications and have a tar.gz extension. Azure DevOps also has the ability to store universal packages. A universal package installed one or more files together in a single package that have a name and version, which is useful for many ad hoc situations where you want diversion and track files. Containerized workloads are becoming more popular as platforms like Kubernetes are becoming mainstream. We'll be talking about Kubernetes later on in the session. Docker images, on the other hand, are generally complete self-contained system. Azure artifacts are available in Azure DevOps, DevOps servers, as well as in Team Foundation Server 2017 and 2018. The sources allow you to integrate packages seamlessly into your CI/CD pipeline. Now, there are three concepts you need to understand when managing these Azure artifacts that we just talked about. That is feeds, views, and upstream sources. Feeds are the primary method for delivering packages. Microsoft really recommends one feed per project. And to achieve this, we can utilize the feature of upstream sources, which allows you to combine multiple sources into a single feed. Now, using this method allows you to control sources in your project in the various levels of access. Here we see two options we have when adding upstream sources: a public source and from an existing Azure artifacts feed from within your Azure DevOps organization. When adding a public source, the only supported package type is an NPM source, which we've already talked about. Now, when you're adding a source from within your Azure DevOps organization, you can target an Azure artifacts feed. This allows you to use different package types, that is NuGet, Python, and Maven. You can scope the visibility of your package feed to your organization, which is multiple projects. And this is by default. Now, a benefit of bringing all these packages together in one feed is the copies are made of the sources. Now, if you're using sources and those sources goes offline, you'll be able to maintain your own version of this packet. Upstream sources, on the other hand, enable you to manage your product's dependencies in a single place. Using upstream sources makes it easy to use common packages in your solution. It has the added benefit and gives you protection against outages and corrupted or compromised packages from upstream sources, and also as a copy of the packages stored locally. Now let's move on and understand how to manage security and compliance. White Source Bolt is a lightweight open source security and management solution integrated within Microsoft's Azure DevOps Services and Azure DevOps Server, formerly that is DFS products. It enables you to do many things like detect and remedy vulnerable open source components. Also, you can generate comprehensive open source inventory reports per project or build. You can also enforce open source license compliance, including dependencies licenses. And also you can identify outdated open source libraries with recommendations to update. This is just one solution to manage security and compliance. Let's move on and understand how to implement continuous feedback. So you can design system feedback mechanisms. The first one is to use application insights metric dashboards. Now, Application Insights has always provided a summary overview pane to allow quick, at-a-glance assessment of your application's health and performance. The new overview dashboard provides a faster, more flexible experience. Dashboards are basically customizable, interactive signboards that provide real-time information. Dashboards are associated with a team or a project and display configurable charts and widgets. Charts, on the other hand, are query-based status or trend charts derived from a work item, query, or test results. Widgets, on the other hand, display configurable information and charts on dashboards. The widget catalog provides brief descriptions of those widgets available to you. Now, in addition, you can add widgets provided through the Azure DevOps Marketplace. In context, reports are system-generated charts that support specific services. Examples are team velocity, sprint burndown, and the cumulative flow diagram. These reports are displayed on the Analytics tab for a specific service and derive data from analytics. Power BI reports allow users to create rich, customized Power BI reports or other reports using OData queries of analytics data and the return JSON data. If you see the fourth point, you can also configure a burn down or burn up widget. The burn down and burn up widgets provide the flexibility to create charts for any type of scope, any number of teams, and within specified time periods. Burn down charts focus on remaining work within a specified time period, while burn up charts focus on completed work. In the last point, both lead time and cycle time widgets are extremely useful to teams as they indicate how long it takes for work to flow through their development pipeline. Lead time measures the total time elapsed from the creation of work items to their completion. Cycle time, on the other hand, measures the time it takes for your team to complete work items once they begin actively working on them. Moving on, let us understand how to optimize feedback mechanisms. So the application lifecycle doesn't finish with application deployment. Feedback is a very important element of refining an application, whether that's exception detection and diagnosis or improving the user experience. You can do this in various ways. You can analyze alerts to establish a baseline. You can analyze telemetry to establish a baseline. You can also perform live site reviews, and you can also perform ongoing tuning to reduce non-actionable alerts. Moving on to the next part of the session, we'll be talking about some of the Azure tools. The first one that we're going to talk about is Azure Kubernetes Service, which simplifies deploying a managed Kubernetes cluster in Azure by offloading much of the complexity and operational overhead to Azure. Now, as a hosted Kubernetes service, Azure handles critical tasks for you like health monitoring and maintenance. Since the Kubernetes masters are managed by Azure, you only manage and maintain the agent nodes. Thus, a managed Kubernetes service, AKS, is free. You only pay for the agent nodes within your clusters and not for the masters. You can create an AKS cluster using the Azure portal, the Azure CLI, Azure PowerShell, or even using template-driven deployment options such as Resource Manager templates and Terraform. Now, when you deploy an AKS cluster, the Kubernetes master and all nodes are deployed and configured for you. Additional features such as advanced networking, Azure Active Directory integration, and monitoring can also be configured during the deployment process. Windows Server containers are also supported in AKS. Now, there's some technologies used for configuration management like ARM templates, Terraform, Chef, Puppet, Ansible. ARM templates are a way to declare the objects you want, the types, names, and properties in a JSON file, which can be checked into source control and managed like any other code file. ARM templates are what really gives us the ability to roll out Azure infrastructure as code. Also, there is Terraform, which is an open source tool for provisioning and managing cloud infrastructure. It codifies infrastructure in configuration files that describe the topology of cloud resources. Now, these resources include virtual machines, storage accounts, and networking interfaces. The Terraform CLI provides a simple mechanism to deploy and version the configuration files to Azure. Supported by Chef, the Chef Automate Azure Marketplace solution enables you to build, deploy, and manage your infrastructure and applications collaboratively. Moving on to the last part of the session, we have a case study for you. So we'll be talking about how ServiceNow want to make work easier and more efficient for their customers through its software as a service workflow platform. Now, to maximize the value it can deliver, ServiceNow moved its business critical SAP estate, including 50 essential applications, more than 10 SAP landscapes, 50 database instances, and over 50 terabytes of storage and other IT assets to Microsoft Azure. ServiceNow relies on the high level of security that Azure provides, along with the scalability and agility that a rapidly growing company needs to expand. Benefits of the migration include an 80% reduction in deployment cycle time, an improved service level agreement, better disaster protection, improved SAP application performance, and a 40% reduction in TCO. ServiceNow helps some of the world's largest and most influential companies work better. It also helps customers in numerous industries reduce costs, increase productivity, streamline processes, and accelerate digital transformation. It does this by delivering a comprehensive software as a service digital workflow platform with native AI capabilities and intuitive user experience. To support its customers, ServiceNow must ensure that its own internal systems and processes are powerful, dependable, and scalable. The company has long relied on Azure to keep its operations running.
So these are the components of Azure DevOps. I mean, you have Azure Boards, you have Azure Artifacts, Azure Pipelines, Azure Repos, Azure Test Plans. Now, basically, these are different services that kind of let you carry out certain practices that concern DevOps. If you're interested or if you wish to create pipelines in which your products would be built, tested, and deployed, you need Azure Pipelines. Azure Artifacts let you keep track of all the artifacts that you're actually going to go ahead and use in your DevOps approach. Azure Repos is similar to GitHub, where you can actually go ahead and have your in-house repository or in-house orchestration, where you can actually go ahead and put in your repositories, commit them, pull them, basically branch them and do a number of things with them. Test plans, as the name suggests, it gives you plans using which you can actually go ahead and carry out the testing process when you talk about Azure DevOps in particular. Azure Boards, this is something that we are going to discuss in little more detail today. So Azure Boards, think of it as a one place that basically unifies all these services or brings in all these services together. It is more of a dashboard that basically lets you keep track of all the activities that you do in this process. So whether it's about building your applications, deploying them, testing them, kind of importing your repositories, all these things can be managed on a single platform or on a single page, so that it creates simplicity. I mean, if you have a team of maybe 25 people, if all of them can interact with all these services on one single page, on one single dashboard, that would be really good. And that is what Azure DevOps exactly does. It is not just a medium which brings in all these things together. It does a lot more. So as we move further, we would be discussing that as well. But for now, that is what the definition says, or that is what I would define it as, by saying that it is a place where you bring in all these services together. So let us move further and try to understand something else. So what are the components of Azure Boards in particular? So guys, these are the terms that we would be more concerned about as we move further into the demo part. So let us try to understand these one by one. Calling them components, I'm not sure how right an approach that is, but yeah, these are more of the terminologies that concern Azure Boards. Now, I've already mentioned that it is a page that brings in all the services together. So basically what it does is it lets you keep track of all the activities that are happening. So whether there are certain work items that you're dealing with, whether you're dealing with certain issues, certain tasks, whether you're talking about different views in which you wish to view all the data that is there, whether you're keeping track of all the repositories that are there, whether you're keeping track of all the sprints, if you wish to take a note of what happens in a particular sprint, or if you have certain queries that you wish to throw into so that you can understand your process or you're working much better. In that case, you have your Azure Boards basically, which lets you take care of all these activities. So what are these terms and what do they do exactly? Let's try to understand those. Now, as I've already mentioned, each artifact that would go on your Azure board, I mean, whether it's an issue, whether it's a task, whatever it is, it comes under a particular classification. I mean, I want to make note of that particular artifact in the form of some entity. So that entity is my work item, as in what your work is being done, what your action is being done on this particular item. That can be taken note of by using this particular thing. Work item is nothing but basically creating a simple tab in which you keep track of everything. Okay, if I have a particular issue, say for example, I have some issue with committing a change to a particular repository. In that case, I can create a work item or an issue saying that, okay, this is the stuff that I'm working on, or this is the stuff that I need to keep note of. So this basically is a work item. Boards, now again, if you have a particular project that you're working on, now that project would have its self-defined board. In this case, you can think of it as a Kanban board basically, which is very popular, and it comes self-integrated with every project that you work on Azure Boards specifically. Backlogs, yes, the fact that you are working on sprints, I mean, let me simplify this a little more for you. Basically, Azure Boards also lets you keep track or lets you perform sprint management and agile development and management as well. That means you would be working on software development in different phases. So you would be working in different sprints, right? So there might be a possibility that you are working on a particular software or developing a particular software. In that case, you would be having certain backlogs, certain issues that need resolving. So in order to keep a track of it, in order to keep an order in the flow of your software development, you can always have backlogs which let you backtrack and keep track of what has happened and what has not. So for that you have backlogs. Queries, we've already discussed that. I mean, you can always throw in queries to understand what is happening on your dashboard or on your board. Sprints, I believe we have a fair bit of idea about that as well. When you talk about dashboards, yes, as I've already mentioned, you have a separate board. Azure ensures that you get that simplicity. I mean, you get everything on one simple page. So as we move into the demo part, probably we would be understanding these topics in a little more detail. So let us quickly just do one thing, that let us quickly switch into the Azure boards and let us get started with the demo part so that probably these terms make a lot more sense to you people. So guys, what I've done is I've gone ahead and I've switched into my Azure portal. Technically, I haven't switched into my Azure portal. Azure portal is a one-time place or a single place where you can actually go ahead and implement or carry out all the Azure practices. So that happens with most of the cloud platforms that are there in the market. So in case if you wish to practice Azure, all you have to do is go and search for Azure portal or free tier for Azure, and you would be directed to a page where you can create a free tier account on Microsoft Azure. You'd be expected to enter your credit card or debit card details. This is because these services have an upper limit or a cap on top of that, so that you cannot exceed those limits. Because if you do exceed those limits, then Microsoft Azure would charge you, and that is why they need your credit card or debit card details. But if you are a beginner and you wish to practice, do not worry, these resources are more than enough for you to practice. So I would suggest that you actually go ahead and create a free tier account. Okay, one more important point. Once you create that free tier account, you have certain credits which are somewhere around $200 if I'm not wrong, 200 US dollars. And if you are from India, the fact that I am conducting this session in India, I have a credit. If I create a free tier account, I have a credit of somewhere around 12 to 13,000 Indian rupees, which is more than enough if I'm not wrong for the practice sake. And you have a validity of 1 month to practice these services for free. Once you exceed the 1 month part, your account would be deactivated. or you won't be given access to the services. If you wish to have an access to these services, you would have to probably sign up to some plan that they have. But meanwhile, you can use these resources for free for a month actually. So with AWS, it is for 1 year. With Azure, it is for 1 month, if I'm not wrong. So once you do have that free tier limit with you, you can visit this particular link. As you can see on the screen, you can actually go ahead and search for this particular screen. And once you do that, guys, probably you can actually go ahead and come to this page where you can start free with the boards. So let us see how can we get started with this particular service. So click on Start Boards. It would ask you as in, do you wish to continue? Just say yes. It is an Azure DevOps service basically. So it would ask you for the name of the organization. I mean, you have a structured approach here where you would be having an organization under which you'd be having projects. So let us call it, say, Azure Boards. Guys, I'm giving a random name because most of the names are taken. Azure Boards 1, 2, 3, 4, 5. Continue. Okay, I just backtracked accidentally. Let's say Azure Boards sample 1, 2, 3, 4, 5, and I say continue. So it creates an organization and it redirects you there, and then it says that actually go ahead and create a project. So I'm gonna say demo project for this session, and I'm gonna keep it public because I wish to add certain users. So let's just keep it public for now, because if I create a private account, I would have to look into access rights for the users that I'm creating. And there you go, your project is created. So you can go through this welcome guide if you want. I'm gonna skip it for now. So guys, this is how the interface looks like, and as you can see, I've mentioned that you can take a look at the backlogs if you've created, which I haven't in this case. You can create issues if you want. You can do that as well. You have an option of epics, issues, which lets you basically keep track of all the stuff that you're doing. You have certain work items that you can add if you want to here. Boards, what boards are you using? Backlogs, you can keep track of all the backlogs that you do. Sprints and queries. So if you just come to boards and then you say add a new item, let's say sample item, there you go. So guys, you can see that it comes with these two options. You have a particular state here. So for now it says to do. What do you wish to do? It is that phase. Okay, so you can actually go ahead and change the state as well, saying once you do change the state, it moves to the next part, as you can see here. So if you are working on a particular action and you've actually moving from one state to the other, you can always make changes to that, and probably you'd know that, okay, what state is the work item into, what state is the issue into. So if I click on this thing, it would probably go back again. As you can see, you can add tasks here saying that, okay, this is a particular subtask or a task that needs to be done. Say for example, clear cache, and there you go, cache has been added. If I am done with this particular task, say for example, I move into doing phase and I clear this task and I say I am done with it. There you go. As you can see, the color here has changed, indicating that the flow is correct and my task has been completed. So you can keep track of all the resources that you're using here. You can actually go ahead and add users. You can do a lot of stuff that is there with these projects. So come here and take a look at the overview. You can, suppose if you name it, say sample for today maybe. Guys, I'm gonna go very random with this session. I mean, whatever I feel is worth telling, I'm gonna go ahead and share that with you. I hope that flow is fine with you people. So there you go. Let's see if we can add a user from here. If not, we'll create a user from somewhere. Okay, so a user was added here. One user is added and assigned an access level to user one. You can view the status here as well. It says for now it has failed because probably I do not have the license to actually go ahead and assign users, but you can actually go ahead and assign users as well. So that depends upon the access rights that you have. Once you do that, you can actually go ahead and do a lot of stuff. You can just come here. Probably you can visit your dashboards and the demo projects that you are creating. Maybe go to boards. Once you do that, you can come here and add backlogs as well. Suppose I have an item here, which is this. Now so let's add a new item. Take a look at this issue. Say add to top. There you go. I can come and assign it to a particular user. Let's say I assign it to this particular individual, and there you go. The person can actually go ahead and make change to the issue. You can see the update is here, and if it is done, it's gonna go to green again. And if I come back to my board, you can see that it is here. Work items, again, if I actually go ahead and move it to the other state, that won't be a problem. It would again go to the green part. So this is how it works. You can actually go to the project settings as well. You can come here, you can do a lot of stuff here. Say for example, you can manage your teams, take a look at the security principles that are there. You can test. Let's not get into the test part for now, but let's say if you wish to have GitHub connections, you can connect to your GitHub account as well. Just come here and probably, okay, so you can just go ahead. My GitHub account is already added, I believe here, so it shows that thing to me. Else you'd require to sign up as well, so you can just say save and the repository gets added here. So you can actually go ahead and move to the repos part as well and take a look at the stuff that has happened here. Say for example, let me switch to some other account that I have. This is the one, or maybe Edureka Boards. So if I go to samples, there was something I was wanting to tell you. Yeah, this is the part. So you can enable your repos as well if you want. Okay, you can enable your pipelines, even artifacts. You can see that all these things are available here as well now, because I've actually gone ahead and enabled those things. If you just enable these things, you can have access to these resources here and here. So if you have any files or stuff, you can actually go ahead and check if there is anything that is there in your repos or in your other services, and you can clone those. You can make changes to those services that you've used. You can commit certain changes to the code that is there. Say for example, you have some index files or some basic codes that are there. You can actually go ahead and edit those changes. Once you've actually edited those changes, you can go ahead and commit those. You can create branches as well. So you have your master branch, you have your sub branch, and you can make changes and commit those changes to the master as well. So when you talk about DevOps operations and various activities that concern a particular board, everything can be taken care of when you talk about Azure boards in particular. So this is it, guys. There is not a lot to explore when you talk about these services. These are very important to use though, because they help you keep track of a lot of things. I would suggest that you visit Microsoft Azure's documentation as well, because there are quite a few other activities that you can do with this particular service. Some basic activities which are simple, but something that are important and can be done as well. So as far as you are concerned, you can actually go ahead and explore as many services as you want, and you can understand what all can you do with Azure boards in particular. As far as this session goes, guys, I just wanted you to get introduced to this particular topic, and I believe I've done justice to that, and I hope that you've understood this particular topic to some extent where you can take it further and probably enhance your knowledge in this particular domain. Let us try to understand what is Azure Pipelines now. Now, basically, this particular service helps you carry out following things, or this is what the definition has to say. Well, it is a service that caters the need for creating pipelines on Azure cloud platform, which is pretty much evident. And what it does is it lets you build, test, and deploy applications to Azure cloud and other supported platforms. Let me simplify this definition for you a little more. Now, basically what it does is it lets you create a pipeline. Now, when I say a pipeline, when you develop a software, it needs to be built. So there are steps involved in it. You would be picking up a piece of code, or you'd be creating a new code. Once that code is there, you would build that code. You would probably run some tests on top of it. If any changes are required, you would again build that code, again test it. And once it is ready, you would deploy and deliver it to the end customer, right? So instead of doing these things individually or doing these separately, what if there was a channel in which you could do all these things and keep a track of all these at one single location? Wouldn't that be nice? Well, when you talk about Azure Pipeline, that is what it does. It basically lets you bring in all these actions under one umbrella. And these are some of the features that Azure Pipeline has to offer to you. Let us take a look at those one by one. Well, Azure pipelines are basically platform and language independent. What do I mean by this? Well, if you have your application and you wish to run it on a particular platform, well, Azure gives you option for that as well. You can run it on maybe your Windows operating system. You can run it on your Linux operating systems. You can run it on your Mac operating systems as well. Plus, it is language independent. That means whether you are building a Node.js application, you are building it in some other programming language like Python or stuff like that, you can definitely run this piece of code or build your applications using different programming languages, and you can run those on different platforms as well. Freedom to work with containers. Definitely true. What do I mean by this? Well, containers are something that let you simplify the process of virtualization, or in simple words, they let you separate your piece of code and binaries from the platform on top of which you wish to run those. So in simple words, your code is locked into a container which can run anywhere. There are containers like Kubernetes, Docker. So basically what it does is it lets you push your applications on top of these containers. You have Azure Container Registry as well, if I'm not wrong. That is an Azure service for containerization basically. So you have the freedom to move your applications on top of these containers or inside these containers as well. Deployment to the other cloud vendors, definitely yes. Now, the fact being that this is an Azure service and it lets you create pipelines does not mean that it restricts your applications to Microsoft Azure only. If you have been using other cloud vendors or your customers or whatever it is, I mean, your end goal is to move it to some other cloud platform, you can do that. If you're talking about cloud platforms like AWS, which is popular, GCP, which is a very good competitor, if you wish to move your codes or your applications to these vendors, well, definitely deployment to these vendors is also supported. Support for open source, yes, Microsoft Azure has put in a lot of effort in recent times to ensure that Azure is open to open source projects, applications, and tools as well. This being said, it is very easy to integrate open source services with Azure these days, and that is why if you wish to keep your project open source or you want it to be accessible to others, you can take care of that as well. So these are some of the features that make Azure Pipelines a must-have tool or a must-have service. So let us just quickly move further now and quickly switch into the demo part because I do not want to stall any of your precious time. So let us just quickly take a look at what Azure Pipelines can do for you. So guys, what I've done is I've actually gone ahead and I've switched into the console. Now, if you talk about Microsoft Azure, they give you some free credits to use Azure services for free for 1 month. The credits are somewhere around 12 to 13,000 Indian rupees and somewhere around 200 US dollars if I'm not wrong. So you can utilize these credits to use these services because these services are chargeable. But the fact that you have free credits, you can utilize these services for free for 1 complete month so that you can test and practice what these services have to offer to you. So if you do not have a free tier account, just go ahead and sign in for Azure portal. And once you do that, guys, you would be having this free tier account which you can use. Once you do that, probably you would want to search for Azure DevOps, something that we are going to use. Just type Azure DevOps in your browser and you would be redirected to this page. And from here on, I would be taking you further. So let us take a look at what you can do with Azure Pipelines, guys. So I'm going to start with start free. No sooner I click on this icon, guys, it would probably, if you are starting as a fresher or somebody who hasn't worked on any project, it would ask you to create an organization and a project to start with. The fact that I already have an organization or a project, it has actually redirected me to this particular page. So let me just quickly see if I can just go ahead and delete this particular project or organization and see if we can start fresh. How do you do that? Just come here and say delete. And this was the name. Just gonna copy it. Control C, Control V, and delete. So guys, when you click on start fresh, this is how it should start if you've started fresh. If not, you can continue from the interface where I just left from. So it says, do you want to get started with DevOps? I would say yes. Give it a name, your organization. I'm just gonna say sample for today. Okay, South India. I'm kind of based in Bangalore right now, so that is why it says South India. And it will say create a project. So the name should be demo project for me. You can name it whatever you want to. If the name is available, you can use it. Do I want it private? Do I want it public? I would say public for now because I wish to import certain repositories as well, and keeping it public would make it easier for me to get access to those repositories. No other reason. So I'm just going to go ahead and say create. So guys, we've gone ahead and we have an organization for our usage, and under that we have a project as well. So if I just scroll down, I would see following options. I can switch to these 5 services that we've discussed, and I can also have them on one tab as well, which you can see it here. I've already added those as extensions to my dashboard, so we can use it from here as well. Let's just say create pipelines for now. There are no pipelines here because I've deleted my previous project as well. So I'm just going to go ahead and say create a new pipeline. So where is my code is what it is asking me. Is it in Bitbucket? Is it in Azure repositories? Is it in GitHub? I have some pieces of code in GitHub. So let's just go ahead and use a random piece of code that is there in my repository. Once you click here, guys, if you're not authorized to use your repositories or use your GitHub, you would be required to sign in here. It would throw in a page where you can actually log in with your credentials to GitHub. and pick up your repositories if you wish to use those. I have this one here. It is available actually. You can look for pipelines, Python, Django for Azure, and probably you would get these anywhere. You can just fork it by clicking here. If you do not have it, do not worry. I would be sharing the link for this as well. For now, let us just go ahead and continue with the demo part. So I'm going to select this. So guys, this is basically a piece of code for Django framework supported by Python. What it does, it tests a Django project on multiple versions of Python. It adds steps that help you analyze the piece of code, save, build artifacts, deploy, and more. So basically, you can visit this particular link as well to know more about this piece of code. So this is what it does. You can see step by step the information is here. What VM it is going to use, again, what are the versions that it is going to use, what is the script that is here to export a particular path, source, plus if you go ahead, these are some of the commands that you would be wanting to take a look at. These are nothing major. It just basically goes ahead and builds a particular project for you and deploys it. So let us just go ahead and do that as well. Let's just say run. So it would configure your piece of code, and once it starts doing that, you would get all the information as in what is happening here step by step. So bear with me, let it just configure the stuff and give you the information. Probably might take half a minute to get started. And there you go guys, it has already started. The agent is ready for the job is what it says, and it would start the connection. Once it does that, there would be a log made available to you people. So guys, this is what has happened, and this is what is happening. You can see it is getting logged step by step, whatever is happening, and you can see the commands and piece of code running in the background. And once it has succeeded, it would give you the status succeeded. So it initialized an agent, prepared a job, initialized the job, checked out, then it used a Python version. It did actually go ahead and export a particular project, installed the prerequisite. It ran test on top of it. It published the piece of application or the result basically, and it actually did go ahead and check out and finalize the job. So these are the things it has actually gone ahead and performed. You can take a look at the summary part, and this is what has happened step by step. Tests, these were the tests that were run and those were successful. So you have for those as well. You can click on release, but there is nothing to release for now. So yeah, so you can choose where you wish to actually deploy your application. You can carry out these steps as well. So these are the options, and you can just go back. Let me just leave it. Yep. And if I overview, it said pipelines, it is 100% fully built. Member is the account that I'm using. Pipelines, if I go here, it would give me information about that as well. This is the master branch that I'm using. I can actually go ahead and update my piece of code as well if I wish to. So guys, there are a lot of things that you can do. You can actually go ahead and commit of codes here as well. You can go to repos. You can decide what piece of code you want. The existing master branch that you're using in the pipeline, you can actually go ahead and fork that particular piece of code. When I say fork, you make a copy of it for your own sake. You make changes in it and then you push it to the master, and if the master finds the latest version doable with the proper access admin rights, you can actually go ahead and merge that piece of code, something called as commit. You can commit your code to that particular pipeline. So guys, this is how your pipeline works. This is how your piece of code works, or this is how basically you actually go ahead and use your Azure pipelines. There are a lot of other things that you can do. You can actually go ahead and install certain extensions to your Azure pipelines so that you get quick sites, or basically you get analysis as in what was the process that was implemented and what steps it took. If you wish to know more about it, do visit our YouTube channel and visit Azure DevOps video where we've talked about that. The video also talks about how you can actually go ahead and add batch to your particular piece of code or your application, suggesting that whether all the builds were succeeded or were successful or not. As far as this session goes, guys, I believe I've talked enough about what Azure pipelines are. I've shown you a sample as in how you can actually go ahead and create a sample piece of code using Azure pipelines, or not a piece of code, or how you can actually deploy a sample piece of code using Azure pipelines. I believe most of the parts here are covered, but let us quickly take a look at some of the other pointers and then probably we can rest this session. So here you'd be having summary of what is happening. Dashboards, I don't think it would show any dashboard. You can just go ahead and add widgets if you want. So you can click it or click on this particular icon, select a widget. You can add it here and you can say add. So now if you go to your dashboard, you can select a pipeline here. Let's say this is the pipeline and I say save. So it gives me the history as in what has happened 4 minutes ago, and whatever changes happen, those can be studied and understood here.
What is Azure DevOps Test Plans? Azure DevOps Test Plan is a service launched by Azure DevOps that provides a browser-based test management solution for the exploratory, planned, manual, and user acceptance testing. It provides rich and powerful tools so that everyone in the team can use to drive quality and collaboration throughout the development process. It is easy to use and it is browser based test management solution which provides all the capabilities required for a planned manual testing and user acceptance testing or exploratory testing and for gathering feedbacks from the stakeholders as well. So now that we have come to know what is Azure DevOps Test Plans, now let's deep dive into the concept and understand what are these test plans basically. So first let us understand what do you mean by a test plan. So a test plan is nothing but a container for storing test suites that are nothing but a collections of test cases. So these test plan function by allowing you to establish a container in which you can group your all test suites. So as you can see in this diagram, this is a container which comprises of number of test suites which are grouped and then stored into these test plans. So test suites are nothing but the collections of test cases which then form a group and then they are stored inside these test plans. So there are three types of test suites, that is static based, requirement based and query based. So static based test suites are type of test suites that are used either as a container to group other test suites or to group a specific set of test cases. So in Azure DevOps Test Plan, you can have nested test suites. That means a static test suite itself become a form of a container where we can add different test suites and then we can place or as a place to create a test case ad hoc. So as I said, it will be in a nested loop form. So most of the time you will be using a static test suites as you mean by grouping test suites together. Next is requirement based test suites. So requirement based test suites are the simplest and the most traceable test suites. It is basically they pull all the test cases for a given requirement. This means when you go to build a test suite, you will not be choosing test cases. Instead, you will simply choose the requirements. So what happens next is that any test cases that have already been built or connected to that particular requirement will get pulled in and populate your test suites. So you can then run all of the tests for that particular given requirement. So if you use a requirement based test suites, your team can create a traceability matrices so that you not only see how your test cases align with your requirements, but also you can see whether a particular test case has passed or failed for that particular given requirement. And next comes the query based. So query based test suites are the type of test suites which pull in a group of tests from your project irrespective of what requirement the test cases are linked to. So it affords teams that have the ability to create a test suite using any criteria available. What does this mean actually is that when you are creating this type of test suites, it asks you how you want to pull these test cases and allows you to construct an ad hoc query to do so. So here you are not concerned with how test cases are connected to specific requirements, and instead it allows you to pull in the test cases that match a specific criteria. So when do you use these query based test cases is like when the team will run these tests on all the test cases that are currently in a given iteration or run the test on everything with a given tag. So the idea behind the query based test suite is that you can easily include test cases from your project that you would like to test irrespective of the affiliation to that particular requirement. So as I said, a test suite is nothing but a collection of these test cases. So what are test cases? Test cases defines to test a system, software, or any application. It can be a singular set of action or the instruction for a tester for a test to perform that validates a specific aspect of a product or the application functionality. So here in this particular test suite, you can have n number of test cases which can be then grouped based on the different types of test suites, that is static based, requirement based, and query based. Now that we have come to know about the test plans, test suites, and the test cases, now let us look on to some of the key scenarios which will help us understand why do we use Azure DevOps test plan. So Azure DevOps test plan provides software development teams some of the key benefits, such as they can test on any platform. So this means that with test plans web portal, you can use any supported browser to access all manual testing capabilities. It enables you to create and run manual tests through an easy to use browser based interface that users can access from all major browsers on any platform. Next is it has a rich diagnostic data collection. So here using the web-based test runner and test runner client, you can collect rich diagnostic data during your manual test. This includes your screenshots, image action logs, screen recordings, code coverage, IntelliTrace traces, and test impact data for your apps under the test. And this data is automatically included in all the bugs you create during test, making it easy for the developers to reproduce this issue. Next is end-to-end traceability. Your DevOps provide end-to-end traceability of your requirement, builds, test, and bugs. You can create your requirement qualities from cards on the Kanban board, and created while testing are automatically linked to the requirement and builds being tested, which helps you to quality of the requirements and the builds. This is integrated analytics. So in this, the analytics provides data that feeds into built-in reports, configurable dashboard widgets, and customizable reports using Power BI. Data tracks test plan progress and trends for both manual and automated tests. The test analytics then provides real time visibility into test data for builds and releases. So, teams can act on this data to improve the test collateral to help maintain healthy pipelines. Lastly, is the extensible platform. So, you can combine the tools and technologies you already know with the development tools that work best for you to integrate with and extend Azure DevOps. You can use the REST APIs and contribution model available for the test platform to create extensions that provide the experiences you need for your test management lifecycles. So these were some of the major key benefits that makes Azure DevOps useful for the development teams. Now let's quickly understand how does these test plans work. You can work on with the test plans with two ways, that is manual testing and automated testing. In manual testing, the Azure DevOps test plan uses test specific work item types to plan and author these tests. In addition, it provides two test tools to support running the test. Test plans, parameters, and configuration hubs provide the tools to efficiently create, manage the test items, their settings, and as well as their configuration. Now, in this, the test suites can be dynamic requirement based or query based suites to help you understand the quality of associated requirement under these development, or static to help you cover regression tests. Next is automated testing. So, automated testing is facilitated by running the tests within the Azure pipelines. So, here the test analytics provide you real time visibility into your test data for builds and releases. It helps you improve the pipeline efficiency by identifying repetitive, high impact quality issues. So, these are the two types in which the test plans actually work. Now that we've come to know what are test plans, test suites, how do they work, so now let's have a quick demo on these test plans. Now let's quickly work on some of the demos where we'll create test plans, test suites, and see how it works. So for that, first we need to log into our Azure portal. So let's quickly log in. So for that, what do we need to do? First we need to login, stay signed in. Alright, now that we have come to our dashboards, here as you can see, this is the whole dashboard of the Azure portal where you find all the different kinds of services and resource group and all other subscriptions and stuff. So we'll be directly moving ahead to our Azure DevOps organization. Now let's go to my DevOps organization. So once we come here, so this is the dashboard of Azure DevOps where we can see projects and we can also create new organization. So it is basically you need to create a new owner where under which you have a different you can create different projects. So I already have one of the test plans, but we'll create a new project. So let's create a new project first and let's name it as Azure Test Plans Demo. Now we can give a descriptions to our project or else you can leave it as it is and it's just a demo for us. So I'll be taking the private option and now we can just create. So now our Azure test plan has been created. So this is our project overview. So in this, we can add boards, repos, pipelines, test plans, and artifacts. So let's quickly go to our test plans. Now, once we come here, now we need to first create a test plan. So as we said, a test plan is a container where we have group of test suites. So for that, we need a container. So let's quickly create one new test plan. So let's name it as Azure Test Plan 1. Okay, that would be cool. And here you can choose the area path. So as our project name is Azure DevOps Test Plan, so we'll be keeping it under that. And the iterations, so here the iterations are nothing but our sprint. So we can take, or we can keep it as it is. Later we can just change whenever to sprint 1. So let's quickly create. So now that we have created our test plan, now under this, we will be creating the test suite. So now here we need to see, here we can create a test suite over here. So this is our test plan. Under this, we'll be creating a new suite. So as we discussed before, we have 3 types of test suites, that is static, requirement based and query based. So we'll be taking here static suite. And now let's name it test suite 1. Alright. Now our test plans are created and our test suite is also created. So if you go to our more options, so you can create one more under that particular test suite. You can create another test suite based on your requirements. And you can also assign testers to run the tests which are under these test suites. So now that we have created our test suites, so let's quickly go to our boards. Under that, we'll go to our sprints. So in this, we'll see whether our test plans are available or no. So as you can see here, Azure Test Plan Demo, that is our test plan. And under that, we have the test suite, which is under sprint 1. But currently, we don't have any test cases. For that, we need to create test cases as well. So as you have created these test suites, so in this you can either add new test suites under the test suite 1 or else you can assign the testers to the particular suite. But before that we need to create new test cases. So now what do we need to do is we'll first edit our test plan and we'll choose our iteration, that is our sprint 1. So we'll be choosing that and we'll just save and close. So once we do that, we'll just go to our boards. So as you can see, this is our test suite and this is our test plan. So, and it is currently active. So once you go to our sprints, so here you can see, as I said, in sprint 1 we have only one sprint, but we don't have any test cases. So now what do we need to do? Now we'll go back to our test plans and here As you can see, we can have add test cases. So let's quickly new test case. So here we'll enter the title for our test case. So let's keep it quite simple. So let's create a test case like change the title size from H2 to H3. Okay, so what do we need to do is like we are changing the title size from H2 to H3. So here we'll provide the test case stage that will be in the design stage. So here what do we need to do? Here we need to add the steps. How to change the title from H2 to H3. So let's quickly add some steps. Alright, so we'll just give couple of few steps, that is open home.html, then go to class is equals to hello, and then we will change from H2 to H3. So these are a couple of steps we can add, and based on that you can also give your expected results. Here we'll write size changes. That means the size gets changed. We need to check that. So we'll just save and close. Now let's create one more test case. Let's try one more. So we'll just create one more test case, that is new test case. So in this test case, we'll just write something different. Now we'll say change the title size from H2 to H1. And here, as we said, we need to give our steps. So we'll just follow the same steps. Open home.html, then go to class is equals to hello, and then change from H2 to H1. So we have also created the steps, and this will be size change as we are just changing the size. So our expected result should be same. Now here you can also add the status, means you can give it the priority to our test cases. So there are different types of priority based on which you can create. So let's keep it 2. Let's not change anything, and we'll just quickly save and close. So we have 2 test cases. Now in this define section, we are able to see the different test cases which are assigned. Now we'll go to our execute, and here you can see that your test cases are also visible. So you can select one or multiple test cases. So let's quickly select one and just run for web application. So once we run the web application, so here you can see the steps are specified here. So now what I will do is go to these web applications and I'll check whether the changes have been done or no. When I open the home.html, if it is running well, so I'll just tick mark, or else if it is not, then I will just fail the test step. And then I go to the class hello. So once I go there, so I tick mark that, and I change from H2 to H3, so I'll click that. So once that is done, whereas here you can add some more steps, like here you can see insert new step. You can just create new steps, or you can delete the steps if you are not requiring it. So here you can just add any one new. All right. So here you can also take screenshots, or you can just select the image action and also create a video. Now once you have done this, we'll just save and close. So as you can see here, our test case, that is change the title size from H2 to H3. So here it shows passed. Now we'll also do with the second one. So let's run it together. Let's see what happens. Okay, so Here you can change your test, like we have our first test and you can switch your test cases. So currently our one test has been done, so we'll do with our second test as well. So we'll just pass all the tests and we'll just save and close. All right, it shows active state. Let's see whether it has been done or no. All right. Okay, so what did we do? We did it for the first one as well. So we'll just quickly do for this as well. And just save and close. So as you can see, our both test cases have passed. So now that our test cases are run, now let's go to our chart section. So here you can create a new chart. So here you can either create a new test case chart or the result chart. So now let's create the test result chart. So you have different kind of charts. Select as just and group by as per your, if you have suits you can choose those. So as up the priority. So now here we'll just, you can change the bar, use it on your own. Is now case we have only one, that our chart looks like this. So now that we have just run both and we also see the charts as cases that had run successfully, now we'll just go to our boards and in that we'll just select any one of the test cases. Now as it has been run successfully, we'll just change the state. You can change the state by ready, closed, anything. So it will be just, we'll close this and we'll save it. All right. And now let's go back to the work items and let's do the same as well with the second test case, that is the change the title from H2 to H1. So let's do ready and let's save it. So what do we do is now we'll just go back to our test plans and create a new chart and see how our test case looks. So let's check based on our states. So here you can see one is in the ready state and one is in the closed state. So we had changed the state of one test case as closed, means the test has been done, and one as it is ready. As said, you can also change the colors based on your choice. You can give any colors to your charts and you can show to the people. So in this test suits, let's create a new test case chart. So in this, let's take a pie chart itself and let's group it by the states. So as we change the state of each of the test cases, based on that, we'll be seeing. So as you see, one test case was closed and I had changed one of the test case to be ready. So we can see the differentiation based on it. So it will be helpful for the team also to understand that how many test cases are closed under which states. So this is for you can create. So this was under the test suite one. Whereas you can also do it for your test plans as well. So as you can see here, it is like you can create new test cases over here and based on that you can create a chart. Now let's create one more suite and let's see how does that chart look. So let's create a test suite, that is test suite 2, and in this also we'll have a test case. Let's create a new test case like hello world and we'll give couple of steps. Open hello world dot html, go to class and then print is equal to hello world. All right, now we'll just save and close. So this is our test case. So now we'll not run this test case now. we'll just create a chart and see how does it look like. So we'll just go to our test plan itself. So under this test plan, we will create a new test case. Okay, so here you can see it automatically gets changed. You don't have to like create a new chart over there. It automatically gets changed, and you can see one is in the design stage, one is in the ready stage and close stage. Whereas you can also edit it while if you want to change their constraints based on like state or anything, so you can change it accordingly. So I'll just keep it as it is. So this is how you do the manual testing in DevOps test plan. Whereas I said you can also do the automated testing by building pipelines, and with those pipelines you need to connect it with your test suites, and through that you can just automate all your test plans.
What are artifacts? According to the definition, Azure Artifacts is a package management system integrated with Azure DevOps that allows you to develop and share packages like Maven, NPM, and Nugget, etc. via public and private feeds to any site. So basically, Azure Artifacts is kind of an extension that makes it easy to discover, install, and publish packages in Azure DevOps. It's deeply integrated with other hubs like Build so that package management can become a seamless part of your existing workflow. It enables developers to share their code efficiently and manage all their packages from one place. Using Azure DevOps artifacts, developers can publish packages to their feeds and share it within the same team, access organizations, and even publicly. So this was all about what are Azure artifacts. Let's quickly move on to the next, that is why Azure DevOps artifacts. So there are three main features in Azure DevOps Artifact which makes it more special and demanding. So let's quickly have a look. What are those three? So first is you can keep your artifacts organized. So what does it mean? That you can share code effortlessly by storing any packages irrespective of whatever programming language you are using, like Maven, NPM, Nugget, and Python, etc. You can just feed them all together in the artifacts and keep it organized. Second is protect your packages. So here it means that you can keep every public source package that you use, including packages from npm.js and nugget.org, safe in your feed where only you can delete it, and it is backed by the enterprise grade Azure SLAs. So that means that all your packages are safe and secure. Third is integrated package handling into your CI/CD pipeline. So what does it mean? That you can access all your artifacts in builds and releases, in which artifact integrates natively with the Azure pipeline or CI/CD tool. So these were the three benefits, or we can say features, that makes Azure DevOps artifacts more demanding and mostly helpful to users, basically like developers. So let's quickly move on ahead. So next is Azure Artifacts workflow. So let's see how Azure Artifact work. So it is a three-step process in which makes it easy to work. So like we can see the first step is to create a package. So basically what is it? A package feed is a location you use to host packages you want to deploy with a deployment manager. So when you set up a deployment manager, you need to choose a feed you want to use to host your package. So here what do you do? First you create a package feed or a team feed. So once you create a team feed, then we move on to the next step, that is build integration. So basically what do we do here is like we connect to the feed in the Azure DevOps and then we start building integration. The main purpose of build integration is to define the order in which the components and subsystem should be implemented, which builds to create when integrating the system and how they are to be assessed. After this, we move on to the third step, that is consume from feed. So here what do we do is that we pack and push packages to your feed, and then we consume feed by running build and restoring packages from team feed and setting up new solution locally to consume the feed. So these were the 3 easy steps, or we can say the whole workflow of Azure DevOps Artifact. So with no wait, let's quickly move on to our demo where we'll see how do we work with the artifacts. So first we need to open our terminal. Let's open our terminal. And now what we'll do is we'll create a folder where we'll be storing our both the projects. So let's quickly create the folder. So here you can see our DevOps folder has been created. Now let's just confirm whether it has been created or no. Document. All right. So here you can see this is our DevOps folder. So now here we'll be adding our both the projects, whatever we'll be building. So let's quickly build our projects. Let's move to our Visual Studio. Okay, so here we'll be creating our project. So as I said, I'll be using the Java project. So let's quickly make it. Control Shift P. And this is the option, Create Java Project. So we'll just click on this. And I'll be taking Maven. You can take any other tools like Gradle, Spring Boot, Quarkus, Microprofile, any of your choice. For me, I'll be choosing Maven and then Maven Arctag Quick Start. And our version would be 1.4. And now here we need to give a name to our group ID. So let's keep it Azure Artifacts. All right. And now they ask for the artifact ID. So we'll keep it very simple, project 1. And here we need to select the folder. So we'll be selecting the DevOps folder which we had created. So this would be our destination folder. So here you can see it is executing. All right. So here you can see your group ID, artifact ID, and the version. So our version would be 1.0 snapshot. So just copy this and paste it over here. Hit enter. And they ask for the confirmation of your properties. So our group ID is Azure Artifacts, artifact ID project 1, version 1.0 snapshot. Package, so here we must update the package name. It should be similar to the artifact ID. So let's just update it. Snapshot, our version is 1.0 snapshot. And package, will name it as our artifact ID. So project 1. Yes. And here you can see our project 1 has been created successfully. And here you get the message and we'll just open this. All right. So here, as you can see, this is project 1 and you do have your source files and pom.xml. So this is the where you find all your dependencies. So let's quickly build our project 2. We'll follow the same process. Control Shift P, Java project, Maven, type 1.4, and our group ID would be same. So Azure Artifacts, and this will name it as project 2. Now select the folder, destination folder. All right. So here we see our group ID, artifact ID, project 2. Let's keep the version same. So just copy this and we need to update our package. So let's update it. Project 2. Yes. All right. So our project 2 has also been successfully built. Here you get the message. We'll just open this as well. So here also you can see your source file and your pom.xml file has been created. So now both the projects are created. Now what do we need to do is to create the dependencies. So let's create the dependencies. For this, we'll just maximize this. In project 2, we'll come to this dependencies section and we'll copy this dependency code, copy, and just paste it below. And now what do we do here is, as we need to create the dependencies, so we'll change the group ID, artifact ID, and your versions. So what would be our group ID is Azure Artifacts, which we had created. So let's just copy and paste. And our artifact ID is project 1, as we are making project 1 dependent on project 2. So let's write it project 1. Alright, our version would be 1.0 snapshot. Cool. And our scope would be system. Now below this, we need to give the system path. So let's quickly give the system path. Okay. So our system path would be $base star live project 1-1. So here we get the option 1.0 snapshot.jar. So we'll quickly save this and we'll open our terminal. So let's open our terminal. So now to build this jar file, we need to go to project 1. So let's go to project 1, cd project 1. So here what do? We'll just hit the command maven compile. Alright, so here it shows it has been built successfully. After this, we'll just hit the command maven package. Alright, so your maven package command has also been run successfully. Let's quickly cross check it once. Let's go to project 1. Now here we see the target folder. So let's quickly check. So here you can see your project 1.0 snapshot.jar file has been created. Now what do we need to do is we need to copy this jar file and paste it in project 2. So for this, let's create a folder in project 2. Let's name it live and we'll copy this jar file and paste it in. Okay, now what do? We'll run the same commands, that is maven compile and maven package in project 2 as well. So let's quickly go to project 2. Maven compile. Alright, so here you can see it has been built successfully. Let's run another command, that is maven package. Alright, so here you can see maven package has also run successfully. So this is how you create the dependencies between the two projects. Now let's quickly move on to our Azure. So we'll go to our Azure DevOps. Okay, so here first we'll be creating a project. Let's create a new project and let's name it Azure DevOps Artifacts. And we'll make it private. Like you can choose any one of the you can choose the visibility of your own choice. So but I will prefer private and we'll create it. So this is our new project. Here you can see there are different options like boards, repos, pipelines, test plans, artifacts. So first we'll go to repos and here we'll be uploading our project, whatever we have created right now. For this, now what do we need to do? The first step is so let's go to our project. Now we have created the dependencies, like we have created our jar files and both the projects are dependent on each other. So it is basically typically for one developer environment. But let us assume if you have two different teams, and then what you need to do that you need to always come over here and open the jar file and just update the versions of the jar file every time. So what do you need is to have a central location where you have all these files, and then every time whenever you compile these projects, then it is going to go ahead and the latest file, and then it is basically that you don't need any more, you won't have to just come over here and keep on updating your versions. So it would be automatically done. So for that, what we'll do, we'll just delete this jar files from here so that only the code is transferred to our repos. So let's go to our files and go to project 1, and in target there is a jar file. So we'll just delete this jar file
Same would be done in project 2, project, and we'll just delete this folder. Alright, so now that is done. So let's move on to our terminal. Now we need to move to our destination folder where we have where we have built our both the projects. So I've come here to this DevOps folder. Now what we need to do is we need to send these two projects into our Git repository. For that, we'll git init and then git add all and then git commit and then first commit enter. So here you can see both the files have been gone into the repository. Now what do we need to do is we will go to our repository and we'll just copy this git remote add origin. So what do we need to do is we'll just copy this link, copy and git remote add origin, git remote add origin. And now we'll use the git push command. So let's use it, git push -u origin master. Alright, so our files are uploaded now. Just let's refresh this repository. Let's go to repos. Okay, so here you can see both the projects are uploaded over here. So it is quite clean. We just have our formx.xml and our source folder. We don't have our jar files or anything as such. Now after this, let's move on to our artifacts. So here first is we need to create a feed. So let's create a feed. Let's name it project Azure app. And here we can give the visibility. It's upon you, like whatever choice you need to give. So you can give the visibility like only accessible to the members of the organization or to the specific people. So I'll select the second option and upstreaming sources. So here we from the public sources, we include the packages, like no matter whatever languages you're using. And our scope would be project. It can be either project or organization. So for me, I'll be selecting the project and I'll just create it. So yes, as you can see here, our feed has been created. Now next, what do we need to do is connect to feed. So here you can see all different languages, the packages which you need to connect and you need to feed on to the artifacts. So here there are different languages like .NET, Nugget, Visual Studio, NPM, Gradle, Python, Pip. So you can choose any one of your choice. For me, I will be choosing Maven as we have worked on Maven. So let's, what do we need to do is here, let's copy this repository and we need to paste it onto our project files. So let's go to project 2 and let's search for our repository section. So do we have any repositories? So no, we don't have repository. We need to create a new repository. So let's create a repository just below our dependencies. So repository, please. So let's close it. Alright, now what do? We will just paste the code over here and just save it. Now we can also copy this whole code and paste it on project 1 as well. So this is a project 1. Let's go and do the same thing under repository.
under the dependencies, we'll paste this repository code and we'll save it. Alright, so now you can see this URL. So this URL needs some authentication as this is private. So how do we give the authentication? So let's move on to our Azure DevOps. Here we'll go to personal access key tokens, and here we'll be creating a new token. So let's create a new token over here. You can give any name to your token. Let's keep it project Azure app artifact. All right, and let's give the authentication. We'll give the packaging, read, write, and manage. Once that is done, let's create. So as you can see, your token is created over here, and this is your password. All right, so just copy this password. Now, where do we put this keyword so that we can authenticate? So there's a folder, Maven folder, that is m2.m2. So we'll go to that m2, and here you can see the repository folder, and there's a settings.xml. So we'll go to the settings.xml file, and here you can see this is the code where you can give the authentication to your Maven project. So here, this is the code server. Under this, you have your project ID, project azure.app, and your username is your organization's name. Now let's paste the password which we had copied. So let's paste it over here and let's save it. So now let's go to our Azure DevOps, and we'll go to the artifacts, connect to feed, Maven. And so here you can see the settings.xml file, your username is there, and your personal access token which we created previously have been initiated. Now what do we need to do is copy this repository as it has been updated. Let's copy this and paste it again to our both the projects. So we'll just copy this repository, paste it over here, and save it. Let's do this same with our project 1. So this is our project 1. Alright, so we'll save this as well. Now what do we need to do is we need to also have this distribution management code. So let's find out if we have this section. So we don't have it. Let's paste it again to just below the repositories. Just close this. Copy, paste, and close. Now what do we need to do is copy the same repository code and paste it just inside this distribution management and save it. Alright, now we'll just do the same thing with, this is for the project 1, we'll do it for project 2 as well. Let's copy project 2 and paste. Alright, so we'll save it. So now let's move on to the terminal of project 1 and npm deploy. Alright, so here you can see it has been successfully built. Now let's just check whether it has come or no. Let's go back and refresh this. So here you can see your project 1 artifact have been created. Just click on this, and here you see all your details, all your files are already existing. Now what do we need to do is just copy this dependency and we'll paste it in our project 2. So we'll just select this and paste it and save, and let's npm deploy. Even this has been built successfully. Let's check, refresh. So here you can see our both the projects have been uploaded, and this is how you push your packages into your artifacts.
I hope you all understood how actually the Azure DevOps artifact works. How do we push packages into our artifacts?
So first and foremost, let's try and understand what Azure Kubernetes service is. Now, I'm not going to get into the details of this service right away, but just to give you an introduction, Azure Kubernetes service is a fully managed container management service. It is provided by Microsoft Azure, obviously, which is a very popular cloud service provider. And recent stats also state that it is one of the leading public cloud service providers in the market. So when you talk about Azure Kubernetes, it is basically managed by Microsoft Azure. What it does is it offers serverless continuous integration and deployment experience. Now, what does that mean? What we can do with it? We'll discuss all those things as we get into the details of Azure Kubernetes service. For now, we need to understand quite a few other concepts before we get to that point. But to summarize a few of its benefits, what Azure Kubernetes service does is, what it offers is end-to-end deployment, scalability, and availability. Now, how do these things work? We'll discuss that. But before that, let's try and understand what evolution of software development and deployment is and how it has evolved with time, right? So we all know how applications were built and how they've progressed with time, right? So if you talk about the popular ways in which software development and deployment has evolved, we all think of waterfall model, agile model, and DevOps, which is the current way in which we basically go ahead and deploy applications, right? Or basically not only develop, but also maintain, monitor, and deploy applications, right? So let's try and understand all of these one by one. Let's see how they evolve with time. So when you talk about waterfall model, agile model, or DevOps, they all have these three things, which basically sets them apart, right? The application architecture, be it their deployment or packaging, and finally, the application infrastructure that we can think of. Now, when you talk about the application architecture, the first one, that is your waterfall model, is known for its monolithic architectures, right? Something that we came away from. If you talk about current generation, we are more into the microservices model that is handled by a DevOps, right? So when you talk about waterfall, we had monolithic applications. That means everything was inside a single application. Your servers, right? Your applications, be it your management tools and stuff like that, everything was inside a single application. And these kind of architectures were called as monolithic architectures. Now, with time, we had agile model where we had multi-tier applications where some of your applications or some of the functionalities of your applications were handed over to some other domain or to some other tier, right? And hence we had multiple tiers. Say, for example, you would have your application tier in one place and you'd have your basically your database tier in another place, right? Something like that. And when you talk about DevOps, they took this functionality to a further classified, I would say, architecture where we had microservices or granular parts of your application that could function independently. Now, why do we need these kind of changes, right? Why did we not opt for monolithic applications? Now, when you talk about monolithic applications, these were bulky and these were very rigid, not easy to basically go ahead and modify. If you had to change the entire thing. When you talk about Agile, it gave you more flexibility. How? We had multi-tiers, right? So if one of the tiers is not functioning, right? So we could actually go ahead and work on that tier and it would not affect the remaining functionality. But when you talk about DevOps or when you talk about microservices in particular, it basically breaks down your application into granular chunks where each of these applications performs as a whole, but you can think of them as an individual part, which you can basically go ahead and function or operate on individually, and also ensure that you can basically make changes to these individual parts individually without affecting the functioning of the entire application. Now, when we talk about deployment and packaging, we have different ways in which these applications are hosted, right? Or in which these different ways of software development and deployment work, right? So when you talk about deployment packaging, your waterfall model supported or supports your physical servers, right? You have a physical server. Similarly, when you talk about your DevOps, or rather we have Agile first. So when you talk about Agile, you had your virtual servers. Now, if you talk about cloud computing, yes, to some extent, it supports virtualization, but back in those days, virtual servers were a little different. So if you talk about agile model, it basically lies on a deployment model which is based on virtual servers. When you talk about microservices, on the other hand, they are more based on containers kind of an deployment is what I would say. Similarly, if you go ahead and discuss their application infrastructure. Now, for your waterfall models, we had data centers that basically had all these applications being hosted, right? Your monolithic applications. Similarly, when you talk about agile, we mostly move to the hosted platforms, right? And when you talk about current microservices or your container infrastructure, we talk about cloud hosting. And that is why we've come up with this session where we'd be understanding how containers work on top of cloud. That is your Kubernetes orchestration tool. In this case, would be working on our Microsoft Azure cloud platform. So I believe the evolution of development and deployment is clear to you all. Let us now go ahead and understand or discuss some of the other bits that are there on our plate. Now, before we actually go ahead and understand how Kubernetes works, right? And why are we talking about containers and stuff? We need to understand how containers are different from virtual machines, because virtual machines are something that people have been using and many of them have migrated to containers. Why? Because both of them, they have their benefits and reasons for these benefits. So let us try and understand how a container is different from a virtual machine. More than a comparison, it is just understanding how they're different from each other. Now, this image should give you an understanding as to how these two things are different. The one on the left hand side, you have your container, and on the right hand side, you have your virtual machine. Now, when you talk about virtual machine, what a virtual machine does is, on top of your server, it lets you host your guest operating systems. To give you an example, when you talk about a service, right, or if you talk about a cloud platform like Microsoft Azure, where you have Azure virtual machines, which again lets you spawn instances or virtual machines. Now, these virtual machines or instances can have different guest OSs. Say, for example, if you launch a virtual machine that basically has a guest OS of Linux, and there's another virtual machine that has a guest OS of your Windows, right? So we are talking about two different virtual machines or entities which function on the same server, but they have different operating systems. That means if I want an application to run in Windows, I can do that using my VM, that is Windows in nature. And similarly, if I want something to run on top of Linux, I can use the virtual machine that is Linux in nature, right? So that is what virtual machines offer you. Okay. But there's a catch here. When you talk about a virtual machine, you're talking about a server, right? On top of that server, you'd be having your host operating system on which you'd be running a hypervisor. Now, this is more of a middleware, okay? Or a service that supports all the applications that are there on top of it, including the operating system, the guest operating system that we are talking about. Now, here, the problem is, as you can see, the virtual machines that you see on the left-hand side, right? They'll have separate guest OSs, they'll have their bins, and then on top of that, they'll be having the applications that are running. Now, what is the disadvantage here? Here, what happens is, each time you have a virtual machine that is operating, we need to ensure that there's a guest OS there. So there's a dependency on this. And what this does is, it makes it difficult for you to basically break this virtual machine from the existing infrastructure or architecture and make it run somewhere else, right? Because this is a complicated process. But when you talk about your containers, this is where the difference lies. Say, for example, I'll be having a Docker engine in this case, right? It can be anything. I mean, when you talk about Docker engine, it is a type of tool that provides you containers, okay? So supports container spawning for you in simple words. There are other container tools as well. We are not here to discuss Docker, but Docker is one of the most popular container tools. That is why you see Docker here. So think of it as your container image, what you see there in the left-hand side. So you can see that there's a server host, you have your hypervisor, you have your guest OS. So guest OS here is common, right? So when you have a guest OS here, what that means is all the containers that would be running on top of it would be running on the same guest OS. So you do not have a dependency where basically you have to ensure that all the guest OS requirements are also there in your container. So your container is more independent of the operating system, right? The only concern here though is in case of containers, you have to ensure that if you have one hypervisor or one Docker engine that is running for you, right? In that Docker engine where there's a single guest OS, in that case, you'll be running all your containers that are supported by that guest OS, right? Now, if my guest OS is Windows, I cannot expect myself to run Linux containers there. I'm just giving you an example, okay? So there's a drawback there. But the benefit here is, right, since your applications, your bins and your library files are independent, you can package them in a container and move them across easily. So you can run it on other Docker engines as well to support your claim. What that does is, since you have this freedom here where you're not dependent on your guest OS, right, or you do not have a guest OS inside your container, you get certain benefits. It makes your containers faster, okay, makes them reliable, and at the same time makes them efficient. So that is what basically containers are, and that is how they're different from virtual machines. So I hope by now the point here is clear to you all, as in how do these things function. Okay, let us now go ahead and understand the other bits. So now let us try and understand what Kubernetes is, right? Because many of us know that it is a container orchestration tool. We always try to compare it with Docker, which may not be the rightest things to do, or the best things to do rather. Why is that? Let's try and understand that, as in what is Kubernetes, why do we need it, and is it same as Docker or not? Okay. Now, here are few things that would tell us why do we need Kubernetes, and how it is different from Docker is something that I would discuss in this bit itself. Now, when you talk about Kubernetes, it is used for container communication. Now, this is where it is different from Docker. When you talk about Docker, it is something that lets you basically set up containers and work with containers, okay? When you talk about Kubernetes, it is something that lets you manage these containers, be it your Docker containers or be it other kind of containers as well. So that is what Kubernetes does for you. Now, let us try and understand why do we need something like Kubernetes to manage these containers, be it a Docker container or be it any other container. Now, when you talk about containers, they cannot communicate with each other. They need help to do that. This is where a tool like Kubernetes comes into picture. Apart from that, if you go ahead, what containers do is they basically can be deployed as applications, right? As individual applications. But since it is easier to deploy these applications thanks to containers, you cannot just go ahead and deploy applications the way it suits you. You cannot just go ahead and deploy your containers the way it suits you, right? There has to be a process behind it. You need to understand what containers to spawn, what to schedule, what to release, right? I mean, what to deploy rather. So to do that, this is where Kubernetes again comes into picture. Third bit here is careful container management. Now, what do you mean by careful container management? It again is similar to what we discussed, right? As we talked about how deployment works, similarly, we also need to understand how container management works, right? When you talk about containers, there are quite a few pointers that come into picture. Now, at the start, when I talked about Azure Kubernetes Service, you realize that there were certain pointers that talked about, I mean, there were some highlights of features there on the first slide that showed you it helps you in better deployment, right? And quite a few other things. So when you talk about those pointers, right, what services like Kubernetes do is they ensure that your deployment is happening properly. You are able to deploy multiple applications, right? And you are also able to track whether these applications are up and functioning, whether one of these applications is dead. Do you need to work on it, right? So you get this kind of management when you talk about Kubernetes. Enable auto scaling. To give you an example, let's assume that you have an application that basically deals with 3 servers. Now, let's assume that that application does very well, right? In this case, you might need to scale that application. Is it easier just to go ahead and scale these applications? No, right? Because there could be a possibility that now you have to manage not just 3 servers, but you're required to manage like 100 servers. In that case, using a tool or using an orchestration tool rather like Kubernetes would help you ensure that all your containers running in different 100 servers on top of these different 100 servers are functioning properly. So this is where auto scaling comes into picture. what Kubernetes does is it gives you an ability to auto scale your applications in situations where manual intervention is not needed. And that is what Kubernetes does for you. So these are some of the reasons why Kubernetes came into picture. So yes, we had containers, but these were some of the drawbacks that containers had. And this is what something like Kubernetes lets you do. Okay, let us now go ahead and understand what is Kubernetes, right? So I've already explained what Kubernetes is. There's not a lot of different pointers that have left to be explained. So if you talk about Kubernetes, right, it is an open source container management tool which automates container deployment, container descaling, and container load balancing. So all the activities that we discussed, right, be it managing multiple servers, ensuring that all the containers are working together, right, they're able to communicate with each other. So basically all the container management, it happens, all the orchestration, it happens using your Kubernetes, and that is what it does. Okay. What is one of the benefits it offers? It works brilliantly with all cloud vendors, be it your public, hybrid, or on-premise. Okay. And one of those popular cloud platforms, as I've mentioned, is Microsoft Azure, which we'll be discussing as we move further. So what do you need to know more about Kubernetes? Now, these are some of the facts, right? I mean, some of the things that might intrigue you. I'm not very sure about that. But if you talk about Kubernetes, it was developed by Google. Okay. So Google, as we know, brings in a big customer base, a big audience, right? A big community to discuss. And that is why this in itself is a big thing. Why? Because when you talk about something like Kubernetes, it is going to have a huge community. And that would mean that there's huge support, huge documentation for you to work with. It was developed using a programming language called as Golang, and it entirely was built using it. Apart from that, to summarize what Kubernetes is, you can think of it as a number of containers that can be put into one logical unit so that you can simplify the process of managing these containers and how they work. Okay, so this is what Kubernetes is in a nutshell. Let's try and understand how the architecture of Kubernetes works and what are the components that you should know about Kubernetes. So this is what the basic architecture of Kubernetes looks like. Okay, so you have your APIs, you have your Kubernetes master, you have your image registry, then you have your nodes, which basically are nothing but your applications. So let's try and understand these one by one, as in how do these function. Okay, so when you talk about the APIs, the CLI, and the UI, right, the first thing that you need to do is you need to set up a Kubernetes cluster, right? So when you talk about a Kubernetes cluster, a cluster would be nothing but your central management point using which you'll be managing all your applications or your different containers that host your applications, right? So first what you do is you create this cluster, something that you can do by using your CLI, right? And then you can interact, or others can also interact with your cluster by using an API server. Okay, so your API server is nothing but that basically ensures the authentication and the identification of the people or the resources interacting with your Kubernetes master or with your Kubernetes cluster. Okay, now if you talk about Kubernetes cluster to start with, your Kubernetes cluster here, what you can see is you have your Kubernetes master, right? Kubernetes master is something that basically manages your containers. And what you see on the left hand side, the nodes and stuff, right? This is nothing but your worker nodes. Now this is where you will be having your applications that are actually running. So your worker nodes would be implementing or running your applications. Your Kubernetes master, on the other hand, would basically be managing these applications and telling you how to basically run these applications on top of it. To understand this better, let's go ahead and take a look at this diagram that you have. Okay, so what you see here is you see a Kubernetes master, right? And inside this Kubernetes master, there are quite a few other things as well. We'll discuss those. But what you see on the screen are some key components that you need to know. Okay, so inside your Kubernetes master, you'd be having two important pointers, that is your replication controller and your service. Okay, so when you talk about a replication controller, it is nothing but a resource that is owned by your master, that is your Kubernetes master, right? What it does is it ensures that the requested number of pods are running on nodes always. Okay, so your replication controller is something that controls the functioning, not controls, it basically tells your worker nodes that keep the nodes or the pods running. Now, what are the pods and what do they do? We'll discuss that. Do not worry about that. It's not very complicated, but that is what your replication controller does. Apart from that, you have your service, which is nothing but, again, an object on your master node, right? Or your Kubernetes master rather, that provides load balancing across replicated groups of pods. Now, let me try and make sense for these two terms by first explaining what are your nodes, what are your pods, right? So when you talk about your nodes, these are nothing but your worker nodes, which would be holding your application. Now, in this case, your node can hold more than one application. What we do is we basically classify our worker nodes into pods. Now, pods are sub-entities, right? These are logical collections of the containers which need to interact with each other for the applications to keep running. Okay, and inside these pods you basically have your containers. So that is what the infrastructure looks like. You'll be having pods and which would be holding a logical set of containers that probably result in a particular kind of application, right? And you can have multiple such pods. What you see here is you see Docker. So what it tells you is the worker node is nothing but a container, right? So it can be other container tool as well, need not be Docker, but again, as I mentioned, Docker is a popular tool, so you see it here. So what you see here is basically a Docker container, right, which has multiple pods, and these multiple pods are basically responsible for running your application. And who controls all these applications? Your Kubernetes master. So assume a situation where you need to scale up a particular virtual machine, not a virtual machine, in this case, a particular node. So how do you do that? To do that, you basically have something like a load balancer, which helps you balance your load, right? Either distributed or in case if you need scaling, it helps you scale your applications as well, right? And then you have your replication controller that basically ensures, right, your application is running. So what your replication controller does is it tells your node that this application has to run, okay? And who makes it run? There's something called as kubelet. Now inside every node, there would be another entity called as kubelet. That kubelet is responsible for running your application. So this is how your Kubernetes architecture looks like, and this is how it functions. Now we've understood what Kubernetes is, how it works, right? Let us now go ahead and understand Azure Kubernetes Service. Now, to give you a brief about Azure Kubernetes Service, as I've already mentioned, it is a Kubernetes service that is hosted on the Azure cloud platform. Okay, so let me just go back to the slide one and explain that again so that we can go ahead and understand how working of Azure Kubernetes happens. So we've already seen this slide, right? What is Azure Kubernetes Service, but now it would make a lot more sense for you. Okay, so what can happen or what Azure Kubernetes Service offers to you. Now, if you talk about Azure to start with, it is a popular cloud service provider. What that means is with Azure Kubernetes or with Microsoft Azure, you can basically have various services that help you in software development, planning, management, right? Be it your administrative practices, development practices, or architectural practices related to a software. All these things can be hosted on a public server in this case, which again can be your Microsoft Azure cloud. Now, what it does is it basically gives you all the services that are needed to carry out all the actions that I just mentioned, where you can rent these resources or follow a pay-as-you-go model and use these services to benefit your requirement. Okay. Now, when you talk about a platform like Microsoft Azure, which again is a cloud platform, as I've just mentioned, the possibility of dealing with applications are plenty, or the possibilities rather are plenty. So you can do so many things. So what that does is that gives developers or application owners options to work with these applications in numerous ways. Okay, it simplifies their complications, right? Since if you're talking about a platform like Microsoft Azure, it helps you basically orchestrate quite a lot of activities, be it managing your servers, infrastructure, right? Be it basically load balancing, be it auto scaling, all these things can be controlled by using the cloud platform. So what that does is that gives developers this added benefit, okay, or the application owners this added benefit. And that is why what these cloud platforms are doing these days is they are encroaching or basically covering different domains, be it your big data, DevOps, analytics, right? All these things are or can be implemented using these cloud platforms, because when you talk about these cloud platforms, they're already owning various markets of software development and application hosting. Okay. So that is why having something like Kubernetes work on top of Azure is a benefit. Why? Because some of the complications that you'd find difficult to implement using Kubernetes can be controlled by using Microsoft Azure. And that is why you have these added benefits, be it your end-to-end deployment, be it your availability or scalability. If you talk about some of the benefits that it actually offers, what it does is you pay only for the nodes that you use. That means last time I checked, Microsoft Azure did not charge you for your master node. You only get charged for your worker nodes that you use. Okay. Your cluster upgrades are easier, so you do not have to worry about the patching part and stuff like that. Integration with various Azure and other tools and services becomes easier. Not just that, what you can also do is you can actually go ahead and enforce various rules that are under Azure policy across multiple clusters to have uniformity if you need to, right? What you can also do is you can scale Kubernetes and other nodes using autoscaler that Microsoft Azure supports. And you can even expand your scale even greater by scheduling your containers on Azure containers. So that is what Microsoft Azure Kubernetes service provides you with. Okay. Let us now move further in this Azure Kubernetes service tutorial video, and let's try and understand some of the other important pointers, like how does the architecture of Azure Kubernetes services works. Okay, to understand the working of AKS or Azure Kubernetes service, right? You can see this diagram on the screen. It's a fairly simple diagram and it tells you what Azure Kubernetes service does. Okay, so we've already seen how Azure Kubernetes architecture works, right? I mean, we know what all components it has and stuff like that. This is a more detailed view. So what you'll have is you'll have again a Kubernetes master node or cluster is what you can call it. Okay, so in this master node, the functionality would be same. It would be controlling how the deployment and how the management of your containers work. So basically, Azure will manage your master node. It will basically help you control quite a few activities that are there. As a customer, you'd be managing the applications only. There too, you would have support from Microsoft Azure. How we would understand that? Now, if you talk about the control plane, what you have here is you have your API server. Now, when you talk about your API server, what it does is it basically tells you how the underlying Kubernetes APIs are exposed. Okay. What this component basically does is it provides the interaction for your management tools, be it your Kubectl or the Kubernetes dashboard. Similarly, you have your etcd. Now, etcd basically what it does is it maintains the state of your Kubernetes. When I say the state of Kubernetes, I'm talking about the Kubernetes cluster, and basically it helps you control all the configuration that is there. This thing is highly available and it is key value based in nature. Okay. What you also have here is basically you have a scheduler. What a scheduler does is it lets you create and scale your applications to basically determine which nodes can run on what workload and stuff like that. Okay. And finally, you have your controller manager. Now, this is an important bit again. What it does is it controls or oversees a number of smaller controllers, whether they're performing their actions or not. And what it also helps you in doing is replicating the pods that you have and handling your nodal operations as well. So this is what your control plane does, and it is basically managed by your Azure. Now, what is the benefit of having Azure manage it, right? Since Azure is managing it, you do not have to worry about the configuration part, setting up part, right? Your cluster node is basically set up by Microsoft Azure, and that is what it simplifies. Then the other bit is your customer managed bit, be it your kubelet, right? Kube proxy, your container and container runtime. To understand this better, I think this diagram should draw a clearer or a better picture for you. Okay. So basically, when you talk about your customer part, now there are quite a few things that you need to know. I've mentioned kubelet, which basically lets you run your pods, right? Your pods are run by your kubelet. That is what your kubelet does. Okay. There are other things as well that you need to know here. You have your Azure Virtual Network Interface. Now, it is something that takes care of all the interface requirements that you might otherwise have. Okay. And similarly, you have your kube proxy, right? Kube proxy again works together with your virtual network interface, right? Or basically your Azure virtual network and tells you what needs to be done. Okay. Now, all these things, they reside on a virtual machine again. So we've discussed all the differences and benefits of it. So what Azure does is it basically launches a virtual machine for you on top of which your containers would reside. Okay. So when you talk about these containers again, these are nothing but your applications that are running for you. Okay. And these are the services that would help you actually implement or control all these applications that are there. You can actually go ahead and scale up your virtual machines to meet the requirements of your application in different ways. So this is how the working of AKS is. I mean, this is how the master node works, and this is how your basically customer node or your worker nodes work when you talk about AKS. We'll see these as we get into the demo part. But before that, let's go ahead and understand a use case or see a use case as to how vehicle safety with AKS is supported. Now, when we say vehicle safety, we are talking about a use case that was set forth by Bosch. Okay, Bosch, as we all know, is a very popular company which has numerous thousands of employees working across the globe for meeting different technological needs of the world. Okay, in this particular use case, what they thought of was the amount of accidents that happen due to wrong way driving. Okay, and what they thought was, could we find a solution that could basically help us overcome this bit of problem? Okay, so what were the problems that they were facing, right? When you talk about wrong way driving problems, right? What are the issues that we face? Okay, because of wrong way driving, there could be a lot of accidents, unplanned casualties, and stuff like that. But if I am to avoid wrong way driving using technology, it's a very tedious task. The reason for that is what I can try and do here is I can basically set up an application that notifies me of wrong way driving, right? But then for that to happen, I have to have a lot of data that is in real time. And when I'm driving, my only way of fetching data is by using cell phones and GPS, right? But then again, there are problems with these things. When you talk about cell phones, they basically function very well in a radius of 5 meters distance when you talk about their operational radius or the limitations when you talk about range on exchanging this data. Okay, so you can transfer data to a larger audiences. We see that through WhatsApp and stuff. But if you talk about GPS kind of data, we are talking about multiple points or multiple data that we are dealing with. And to deal with them parallelly can be a difficult task. So because of that, Bosch felt was that this was an impossible task to deal with. Why? In order to get the last piece of information out of the noisy sensor data can be a problem. And in order to develop a highly scalable and ultra flexible service to process this data in real time can also be a tedious task. What they also figured out was to solve this problem, they needed this data in real time and in very short duration. If we could do that, we could actually go ahead and save accidents and we could save these wrong way driving incidents. And that is why they decided to work with Microsoft Azure, which was their already supporting partner. What they also did was they ensured that they did go ahead and accommodate Azure Kubernetes service in their infrastructure. What this did was it ensured that Bosch would get repeatable, manageable clusters of containers. And since they work in such shorter durations, do not have latencies in minutes, but rather in seconds, they offered a simple form of services for them to work with. And what that ensured was they had the average time to calculate whether a driver is going the wrong way or not in milliseconds. So around 60 milliseconds they could figure out. That is around a second where they could figure out whether a driver was in the wrong way or not. And that is what basically your Azure Kubernetes service enabled them to do. Their major problem, that is they had the time constraint, that is something it helped them solve. And because of that, they could come up with this wrong way driving problem solution where they basically use Microsoft Azure to host their data and basically Azure Kubernetes service to basically help them in simple provisioning scaling of applications, and ensuring that the real-time data is made available to the drivers within a span of 60 milliseconds, which again is a big achievement. So that is what AKS or Azure Kubernetes Service had to offer. If you go to Microsoft Azure's website, there's so many good use cases that talk about AKS. So you might want to go ahead and take a look at that as well. As far as the session goes, we'd go ahead and take a look at the demo and understand how we can actually go ahead and set up an Azure Kubernetes cluster and a lot more. Okay, so guys, let's go ahead and get into the demo part now. This is how the Azure portal looks like. Okay, I've signed into the Azure portal. Now for people who are new to Microsoft Azure, what Microsoft Azure does is it gives you an Azure portal where you can implement all the cloud related activities that concern Microsoft Azure. Okay, so if you want to practice from scratch, it also offers a free tier account where you have a number of services available free of cost. Okay, or rather, in case of Azure, it works differently. For AWS, you have those free services. With Azure, you have this $200 of credit that it gives you. So you can spend those $200 on creating resources for 11 months duration. Post that, those will expire. So if you do not have an account, you can just go ahead and create a free tier account, fill in the details, right? And you should have this free Azure portal for your usage. Okay. In my case, this is a paid account. This is the company's account. So it's called as pay as you go in my case. In your case, it would be a free tier account. But the functionality would be similar for you as well. The only thing is with the paid account, you have more services available to you. And even the larger instances is something that you can actually go ahead and spawn and use because you're paying for those, right? Under free tier, you don't have to worry about paying for them, right? So there are certain restrictions and limits there. So do go ahead and register to Microsoft Azure's portal. Okay. Now coming back to the demo part, what we are going to do now is we are going to create a Kubernetes cluster. And on top of that, we are going to deploy an application. And the application would be a basic pre-built app by Microsoft Azure. We are not going to create a new app. I'll be sharing the code for the application. So do not worry about that. So we are just going to go ahead and use that pre-built code, and we are going to deploy that code on top of Kubernetes cluster that we have. Okay. So the main thing to note here is we have to see how easily the cluster is created. We are not concerned about the orchestration process at all here. Everything is taken care by your Microsoft Azure, and that is what we are going to look into. So let's not waste any time. Just quickly go ahead and get an instance in place, rather a cluster in place. Okay. So to do that, we are going to click on this icon and say create a resource. Okay. Here you can see all the service domains that are there for offering. So I'm going to click on the containers one and click on Kubernetes service. Once you do that, you see you'll be brought to this page and you'll get all the details, right? AKS manages your hosted Kubernetes environment, making it quick and easy for you to manage containerized applications. The main point is without having to container orchestrate or have any expertise in that. Okay. It eliminates the burden of ongoing operations and maintaining, provisioning, upgrading, scaling your resources rather, which happens on demand here. So you don't have to worry about those things. So let's just go ahead and create a resource group. So for people who do not know what resource groups are, resource group is nothing but you can think of it as a small container or a folder where you put forth all the necessary things that are important for your resource to work. Now, in this case, our resource is Kubernetes. So quite a few other nitty-gritties related to it would be in the resource group. Okay. So let's just go ahead and create one. So I'm going to click on create new. Let's just say we have RG for demo. I'm going to give a simple name so that I can remember that. Okay. So I'm going to say, okay, I'm going to create a cluster. I'm going to call it Cube cluster. Okay. This is enough. So Cube, let's call it Cube cluster. Okay. And this is in place. Where do I want it? If you're using a pay-as-you-go model, there won't be any restrictions here. If you're using free tier, there might be some. Okay. So just select any region that you want to do. I'm going to randomly select a region now. What region it should be? My region would be, okay, let's pick this one. And it would ask me how many nodes do you want to create? Let's create one. Since it's a very simple demo, we do not need more nodes. Okay. We've discussed what nodes are, right? So that is what we are doing. We are creating a node here where our application would run basically. So I'm going to say review, or let's just go ahead and see if we have all the settings. Node pools. Authentication, you have two options, whether you want your server or rather your cloud platform to manage your identity pools and basically create resources accordingly, you can do that, or you can select a service principal, which is an older way to do it, where you use an Azure Active Directory to do that. So there's no rule here. You can go for this one as well. I'm just going to do this just because I've thought of showing it to you. I selected that. It does not hold a lot of impact on our demo. Okay. Just going to say create and review. Okay. So for creating this thing, now it will review all the requirements. If the requirements are in place, what it will do is it will just go ahead and create your cluster and put everything in place. Okay. So it says, do you want to create it now? I'll say yes, create. Okay, let's just refresh and see whether our application is done. It's still deploying. Let's wait for this deployment to get in place, and once it's done, we'll just go ahead and get these things in place. After this, the process is very simple. Okay, we are gonna just go ahead and put in certain set of commands and our job would be done. So you don't have to wait for too long post that. Okay, let's just refresh it again and see whether it's in place. Normally it takes a couple of minutes, so could take longer, right? But it's a very easy deployment process. So let me give you an idea as in what happens when you say that the deployment is happening. So first, your Kubernetes will actually go ahead and launch a Linux instance to start. Okay, so once the Linux instance is in place, that is when we'll actually go ahead and put forth all our resources on top of it. In that Linux instance, we'll set up a cluster, right? All the nitty-gritties that we need, and on top of that cluster, our application would start working. Here in this case, it would probably set up a cache, could be a Redis as well. We'll have to go ahead and look into it, whether it's that one, okay? And then accordingly, we can go ahead and implement everything on top of that. But we don't have to get into the complications of things. It's a fairly simple process for us, okay? Okay, let's just go ahead and refresh it once more. Okay, it's done. Your deployment has been complete is what it says. That means we are good to go ahead and use our resource. You can do other things as well on top of it. It is suggesting what all you can do. Okay, so we are going to do one of these things. Do not worry. So just go to the resource in our case. Okay, and in this resource, you can see there's all the information that you need. Okay, you'll get to know where it is hosted and stuff like that, what kind of instance it is, where it is located, everything. One node pool is what you have, right? So you have all the information to actually go ahead and connect to it. So in your case, I'm hopeful that it would happen faster than what you see in my case, or on my screen rather. You see, Cloud Shell is up and running. So let's just go ahead now and basically get credentials, right? Here, let's get the credentials or merge our cluster, okay, so that we can start using it. So how do we do that? We use this command. We say AKS, okay? And in this case, what we are going to do is we are going to say get credentials. Okay. Now the next thing is, what do we need? Resource group details. So I'm going to say resource dash group. And I'm going to give the resource group name, which I am certain that we should see if we just scroll up. Okay. So the resource name is RG for demo that we used. Okay, RG for demo. And what we also need is we need the name of the cluster. And in that case, it is cube cluster. So you can do it vice versa as well. You don't have to go this order. You can start by giving in the details for your cluster and then the detail for your resource group. I'm just going to hit the enter button now. Merge cube cluster as a current context in this path is what it says. Okay, now let's just go ahead and get the details for the node. In this case, we know there's only one node, but you could be working on multiple nodes, right? So in that case, you have to use this command. You say kubectl. Now it is basically a client-side interactive tool for interacting with your Kubernetes. Okay, so that is what kubectl is all about. Okay, and you say get nodes. If there are multiple nodes, it will give you multiple nodes. If there's only one node, it will give you only one node. So there you go. You can see that there's one node that we have with us. Okay, we have all the details. It's been running for 5 minutes, it says, right? Because that is when we started the node. Okay, now the next thing is we are gonna go ahead and select the YAML file where we've actually put forth the details for our application, right? So how do we do that? For that, we are going to go ahead and use this command, okay? Nano, okay, space Azure. The name of the application is, or the application rather, is related to voting. So that is why I'm going to use this name, and I'm going to say .yaml, okay? Okay, so guys, I've already pasted a piece of code here because I tried implementing this demo before. So you'll see that there's code here, okay? So in this case, what we are going to do is we are going to remove this code just to be safe. I'm going to just paste the code again. So basically, this is where you'll have all the details. What is the API that is being used? What is the container port, right? What is the memory that you are using? What call are you making, right? All those details are here. Do not worry, I'll share the link to this piece of code in the description. If not, you can just look for Azure demos or getting started with Azure on your browser, and you'll find this piece of code. It's available everywhere. You'll get this code on GitHub as well. I do not own this code, so I will not take any right in saying that this is something that I've created. It is a code that has been used and it is somebody else's work, okay? So you may check out online the details. I'll also pass in the details in the description, okay? So everything is removed now. I'm just gonna go ahead and paste my piece of code here, okay? I'm gonna say paste, and all the same code is again here with us, okay? Now, how do I go ahead with it? In this case, I'm gonna say justify, cut, uncut. Do I want to replace? I'm just gonna say exit for now. So it's Control X in my case, and I'm gonna say no, we'll discard the changes. So we'll say yes. So Y. That means it will save my code. Okay. I'm going to hit enter now. So it will take me back to my cluster. Okay. The next step is, now what we are going to do is we are going to go ahead and call out this YAML file. Okay. So once we do that, this is how we are going to do it. We're going to say kubectl again. Okay. And apply /f Azure, what was the name again? /vote dot YAML. I'm gonna hit the enter button. And there you go. What it has done is it has created a vote back application. Its front is created, its back is created, right? So we need to see how it looks like, right? So we are gonna find out all the details, as in if we want to watch this app working, we need the details for it. So we are just gonna go ahead and use a command called as get service. Okay, so get service is in place, and in this case again my app name Azure vote, but this time I want the front. Okay, so I'm gonna say front, and I'm gonna say watch, and hit the enter button. I basically made a blunder here, and that blunder is we have to call this command through kubectl, right? So in this case again we'll have to type the remaining command again. So I'm just gonna do it quickly. Okay, get service Azure vote dash front watch, and there you go. You have your external IP here. So guys, at times what you see here, your external IP, if your system is very slow, which is in my case, but I don't know how it happened, its age is only 85 seconds is what it says. So normally it takes time for you to see this external IP. Okay, but luckily we can see it. So I'm gonna just copy it here. Okay, and I'm gonna paste it here, and this way we should be able to see the application that we've created. Okay, so you can see you can vote here. One, let me vote for dogs, twice, thrice, and I can just go ahead and reset it as well. Okay, so guys, this is how you actually go ahead and create a cluster. Okay, a suggestion here would be you delete all the resources that is there. Delete this one, delete the resource group, and also the Azure Active Directory, so that you do not get charged. If you want to see what all we did here, right, and how the performance went on, Azure lets you track all the working as well, right? If you want to take a look at the insights and stuff, if you click here, you'll have all those details as well. So there you go. If I just refresh it, you should have all the details, right? How long did we use the cluster? This is where the usage started. Okay, so you'll get all these details that you want. So you can do that. So That's it. I believe this demo was clear to you people, and you got to know what things we've worked on, how we've used these things, and how basically your Kubernetes cluster works. Okay. So we've created a simple Kubernetes cluster and explored it. Ensure when you go back, you just delete. Just go to the resources and delete the resource group, the cluster, and the Active Directory, if any. Okay.
Today, nearly 80% of all business solutions and services have moved to the cloud. Most of the projects are happening by utilizing cloud platforms, which include software as a service, infrastructure as a service, and platform as a service. With projects being hosted on the cloud architecture, it makes perfect sense to utilize DevOps solutions to continuously deliver value for enterprises. Building upon that, we have the Microsoft AZ400 exam, or the Microsoft Certified DevOps Engineer Expert. But what is the AZ400 exam? As described by Microsoft, AZ400 certification training is an intermediate level course from Microsoft for professionals who want to gain knowledge of designing and implementing DevOps processes and practices for an enterprise. This 5-day AZ400 training course is ideal for professionals who combine people, processes, and technologies to deliver value to the organization. Some of the skills that are outlined by this curriculum include developing an instrumentation strategy, which carries a weightage of about 5 to 10%, developing an SRE strategy, which again carries a weightage of 5 to 10%. Then you have development of a security and compliance plan, which carries the weightage of 10 to 15%, as well as managing source control, which has the same weightage. Apart from that, you also learn how to facilitate communication and collaboration between your teammates, stakeholders, and vendors, and define and implement continuous integration or CI, which has the majority of the weightage, which is about 20 to 25%. And finally, you learn how to define and implement a continuous delivery and release management strategy, which again carries a weightage of 10 to 15%. Now, this is the entire skill set. But before you get ready to take on the world with your newly certified skill set, a candidate for this exam must be familiar with both Azure administration and development and must be an expert in at least one of these areas. Furthermore, there are other prerequisites that you should keep in mind before appearing for the AZ400 exam. Now, even though these are not mandatory prerequisites, these are the ones which can improve your chances of qualifying the exam, such as proficiency in agile practices, the ability for designing and implementing DevOps practices for version control, configuration management, build compliance, release, and testing, all of this by leveraging Azure technologies. Now that you know how you can qualify to give this exam, let's go ahead and look at who is this exam most beneficial for, or who can take up AZ400. First of all, this course is designed for professionals who are aspiring to clear the Microsoft Certified DevOps Engineer Expert exam, right? So individuals looking to establish their credibility and value in the market as experienced DevOps practitioners, agile practitioners, and cloud computing professionals. Apart from that, this course is also meant for system administrators, software developers, project managers, and technical leads, and practically anybody that wishes or aspires to lead a DevOps team. So now that you understand who can take up this exam, the main question arises, why should you take this exam? What are the benefits of taking the AZ400 examination? Now, the DevOps market is expected to grow from $3.42 billion in 2018 and 19 to $10.3 billion by 2023 at a compound annual growth rate of nearly 25%, which means this industry is going to grow more than threefold in the next few years alone, out of which Azure holds 19% of the total global cloud infrastructure market, which automatically qualifies you for a majority of the MNCs in the industry today. Not just that, this also has proven to give you a huge boost in your salary, as a mid-level Azure DevOps engineer earns on an average of $145,000 per year, whereas a senior level Azure DevOps engineer can make up to $185,000 per year. Apart from that, the Azure infrastructure is very ideal for DevOps, which is why a lot of companies are quickly moving to DevOps, which makes you a front runner in the race for all of these companies. Now, talking of companies, here are a few aggressively hiring for Azure certified DevOps professionals, including but not limited to Amazon, Ernst & Young, Dell, Accenture, Microsoft, Google, and VMware. Now that you know what all is there in store for you, I'm sure you're curious to know what does the curriculum outline look like. So here it is. First of all, you shall be introduced to Azure DevOps and understand the important aspects of Azure as well as DevOps. Along with this, you also learn the role of a DevOps professional in an organization. Then you learn about implementing continuous integration, followed by building containers with Azure DevOps, where you learn to create and deploy a multi-container application for your DevOps pipeline. Followed by that, you learn how to design a dependency management strategy as well as managing artifact versioning. Next up, you learn how to set up a release management workflow where you learn how to configure a CI/CD pipeline using YAML and manage your secrets using the Azure Vault. Followed by which you implement deployment models and services where you configure infrastructure as a service and platform as a service on Azure. Followed by which you learn how to implement and optimize a continuous feedback mechanism. Next is the meaty part where you learn a bunch of different Azure tools for infrastructure configuration as well as a few third-party tools. And finally, you learn how to implement compliance and security, where you learn how to manage and check code quality with Sonar Cloud on Azure DevOps. You also learn how to integrate Azure Key Vault with Azure DevOps to access secrets in the Azure pipeline. And that was all about the course outline of the AZ400 curriculum. This certification exam not just enhances your skills as well as demonstrates it to your employers, thus making you gain that edge in the industry. The time is right to upskill. And DevOps and cloud are two of the biggest domains in the industry to take advantage of the career opportunities that come your way.
Let's move on and compare AWS DevOps versus Azure DevOps. So let's talk about the services that it provides. The Amazon Web Services code pipeline is a continuous delivery service for fast and reliable application updates. Code pipeline builds, tests, and deploys your code every time there is a code change based on the release process models you define. On the other hand, Azure DevOps services for teams to share code, track work, and ship software. Azure DevOps provides unlimited private Git hosting, cloud build for continuous integration, agile planning, and release management for continuous delivery to the cloud and on-premise. It also includes a broad integrated development environment support. In the next comparison, we will talk about what category of tech stack do they belong to. As you can see, Amazon Web Services code pipeline belongs to continuous deployment category of the tech stack, while Azure DevOps can be primarily classified under integrated development environment tools. Now let's talk about the features of Amazon Web Services and Azure. As you can see, Amazon Web Services provides workflow modeling, AWS integration, and it also has some pre-built plugins in it. Whereas Azure, on the other hand, provides agile tools like Kanban boards, backlogs, Scrum boards, and it also provides reporting tools like dashboards, widgets, Power BI, etc. And it also allows you to integrate with Git, which provides free private repositories and pull requests. Now, why do people like AWS is because it is extremely simple to set up, whereas Azure, on the other hand, is a complete package. It's full and it's very powerful. Now, let's move on and check out the uses of AWS and Azure. As I've already mentioned, AWS is extremely simple to set up. It also has several managed services. It can be easily integrated with GitHub, and it also has parallel execution. Deployment is completely automatic, and there are manual steps available, so you're never lost. Azure, on the other hand, supports open source. It also has several integrations. That is, it can be easily integrated with GitHub and Jenkins. It also has several project management features. And the most important plus point of Azure is that it is free for stakeholders. I hope the uses between AWS and Azure are extremely clear. Now let's move on and talk about AWS and Azure clients. So Amazon Web Services is used by companies like PlayHQ, Affirm, Curo Education, UP, Ready4, and Bitbank Incorporation. Whereas Azure has clients like Microsoft, Kingsman Software, Evodeck Digital, Muse, Energy to Market, and QR Point. Now, the next important difference is with what tools that these cloud services can be integrated with. Amazon Web Services, as you can see on the screen, can be easily integrated with GitHub, Jenkins, Amazon EC2, Amazon S3, AWS Elastic Beanstalk, RunScope, and CloudBees. Azure, on the other hand, can be easily integrated with Git and GitHub, Docker, Slack, Jenkins, Trello, and Visual Studio. Now let's move on and compare the salary of an AWS DevOps engineer and Azure DevOps engineer. As you can see on the screen already, the median salary for an AWS DevOps engineer is rupees 4,67,000 rupees, whereas the median salary for an Azure DevOps engineer is about rupees 6,04,000 rupees a year.
Let's quickly jump on to some of the Azure DevOps interview questions. So the first question is, what is DevOps? Of course, this is one of the first Microsoft Azure DevOps interview question that you will be asked. So the answer to this is, DevOps is a set of cultural ideas, practices, and technologies that improves an organization's capacity to provide applications and services at high velocity by changing and enhancing products at a quicker rate than traditional software development and infrastructure management methods. In simple terms, DevOps essentially speeds up the process of delivery of application and software services. Coming with our second question, why use DevOps? So this is a common Azure DevOps interview question. So how do we answer it? DevOps is significant because it is a software development and operation methodology that allows for faster product creation and simpler maintenance of existing installations. When problem arises, the DevOps team is able to listen to the user and provide the necessary features and repairs. It also facilitates the delivery of smaller features to clients in a quick and efficient manner and allows seamless software delivery. So this was the answer to why use DevOps. Let's quickly move on to our next question. How does DevOps work? So DevOps is about breaking down barriers between previously compartmentalized departments such as development and operations. These development and operations teams collaborate across the whole software application lifecycle from development and testing to deployment and operations under the DevOps paradigms. Going ahead, what is Azure DevOps? So as I said before, Azure DevOps is a Microsoft application as a service platform that offers an end-to-end DevOps toolchain for building and distribution software. It also interfaces with the majority of the market's main products and is an excellent choice for coordinating a DevOps toolchain. This process includes testing automation, continuous integration, as well as continuous delivery. People with both development and the operation skill work together and implement various tools for CI/CD and monitoring for quick response to customers' requirement and fixing issues and bugs. Moving ahead, what are the benefits of DevOps? So there are 5 benefits of DevOps which we'll understand one by one. So first is speed. DevOps practices let you move at a velocity you need to innovate faster, adapt to changing marketing better, and become more efficient at driving business results. Second benefit is rapid delivery. So when you increase the pace of the releases, you can improve your product faster and build competitive advantage. Third is reliability. In this, DevOps practices like continuous integration and continuous delivery can ensure the quality of application updates and infrastructure changes so you can reliably deliver at more rapid pace while maintaining an optimum experience for end users. At number 4, improved collaboration. Under DevOps model, developers and operation teams collaborate closely, share responsibilities, and combine their workflows. This reduces inefficiency and saves time as well. And finally, number 5, we have security. So you can adopt a DevOps model without sacrificing security by using automated integrated security testing tools. So these were the 5 benefits of DevOps which makes it more demanding. Let's move on to number 6. So the number 6 question is name a few DevOps tools. So the answer to this is some of the popular DevOps tools are Git, Selenium, Jenkins, Puppet, Chef, Ansible, Negios, Docker. So you can answer any of the 4 DevOps tools which are easy to remember. Moving ahead with the next question. What are the popular DevOps tools for continuous integration and continuous deployment? So, Azure pipelines support macOS, Windows, and Linux. So, some of the popular DevOps tools for continuous integration and continuous deployment are Jenkins and TeamCity. These two are the DevOps tools which provide you both continuous integration and continuous deployment. Quickly moving ahead with the next question. Question number 8, that is, what are Azure Boards? So, Azure Board is a user interface that allows you to keep a track of tasks, defects, and features in your software project. It enables you to monitor all your ideas to each development stage in order to keep your team on track with all the essential code modification related to your work procedure. Azure Boards include features like boards, sprints, work items, dashboards, backlogs, queries, etc. Going ahead, what is Azure Repos? This is a basic Azure DevOps interview question, but it can be difficult to answer. So, the answer to this is Azure Repos is a collection of version control tools for managing your code. Using version control as soon as feasible, whether your software project is huge or little, is a smart idea. Version control systems are a piece of software that allow you to keep a track of changes to your code over time. Azure Repos offers centralized version control system as well as the distributed version control system, that is Git. At number 10, what are containers? Containers are software packages that include all the components required to execute in any environment. Containers virtualize the operating system in this fashion, allowing them to operate anywhere from private data center to a public cloud or even a developer's own laptop. Containers also provide the means to package software code, its configuration, dependencies, and packages into a single unit or object. Multiple containers can run on the same machine or share OS with containers for running fast, reliable, and consistent deployment anywhere. Moving ahead, what containers does Azure DevOps support? So Azure DevOps support the following containers such as Docker, Azure Kubernetes Service, ASP.NET with containers, Azure Service Fabric application with Docker support. So these are the containers which are supported by Azure DevOps. Moving ahead, what are Azure pipelines? Azure Pipeline is a cloud service that allows us to automatically create and test our code projects. The Azure Pipeline includes several features such as continuous integration and continuous delivery that allow us to test and build our code on regular and consistent basis and ship to any destination. It automatically develops and tests the code projects. It is a service on the Azure cloud that offers well with most project types and languages. Going ahead, at number 13, what is the use of Selenium in DevOps? Selenium is widely used browser automation technology, and testing teams heavily rely on it in DevOps pipeline. It is an open source solution that saves money for testing teams and functional testers that are in charge of UI testing. It specializes in the form of regression and functional testing. At number 14, what are Azure test plans? This is another one of the popular interview questions asked in Azure DevOps. So the answer to this is Azure Test Plans is a service provided by Azure DevOps that offers a browser-based test management solution for exploratory, scheduled manual, and user acceptance testing. In addition, Azure Test Plans includes a browser extension for exploratory testing and getting feedbacks for the stakeholders. Additionally, it also focuses on automated testing. It combines the contribution from developers, managers, testers, product owners, and user experience advocates and enhance the quality of the project. Moving ahead, What are the some important features of meme cached? So meme cached offers a wide variety of features. Some of them are like it is an open source, it's a UDP or TCP server client program. It works as a standalone service. The cached nodes are very ignorant, so they don't have other nodes involved. They are also under the license of Berkeley Software Distribution and it reduces the database load. So these were some of the important features of meme caching. Quickly moving ahead, at number 16, what is a dogpile effect and how can you prevent it? So, a dogpile effect refers to an effect that occurs when a cache expires and websites are attacked by several requests sent by the client at the same time. It indicates the expiry of cache followed by the website being simultaneously hit by numerous respects. In simple terms, it indicates the expiry of cache followed by the website being simultaneously hit by numerous requests. This impact can be avoided by employing semaphore lock. When a log expires in this system, the first process gains the lag and begins creating the fresh value. At number 17, what is continuous testing? What is the use of test automation in DevOps? As we know, DevOps is all about people, culture, and automation. In this, continuous testing is the process of running automated tests as a part of the software delivery pipeline to get feedback on the business risks associated with a software release candidate as soon as feasible. DevOps use test automation to use the test cases to find the flaws and save time. Unlike manual testing, automation test cases accelerate testing, allowing you to get products to market faster. Moving ahead, number 18, what is a forking workflow? So before we get to know what is forking workflow, let us know what is forking. So forking is a git clone process that is performed on server copy of the project's repository. The forking method supports open source projects and isolates changes from the main repository until they are ready to be integrated. What is forking workflow? Forking workflow is a git clone process that is performed on a server copy of a project's repository. This method supports an open source project and isolates changes from the main repository until they are ready to be integrated. Moving ahead, what are some of the useful plugins in Jenkins? So it has a very simple answer. So there are many useful Jenkins plugins, out of which would be describing few. So among them are Amazon EC2, Maven 2 project, HTML publisher, join, copy artifact, green balls, and many more. So these are few useful Jenkins plugins and it will be very easy for you to remember it. Quickly moving ahead with number 20, can we move or copy Jenkins from one server to another? So the answer to this is yes, it is possible. Jenkins can be removed from one server to another just by cloning the job directory from the previous server to the new or the current one, and later you can rename it. This enables moving an installation by copying the corresponding job directory. So these were the top 20 Azure DevOps interview questions. So let's look on to some scenario-based Azure DevOps interview questions. So the first one is, we have 50 commits in develop branch, out of which only 5 commits need to be pushed in the release branch, which will eventually deployed in the production. Okay, so the question is, we have around 50 commits in the develop branch, which is mostly used for development activities. So in that we have multiple commits, and the release branch is used to release your changes into your proper environments like your stage production. So here, out of 50, only 5 commits need to be posted into the release branch. So the best way to achieve it is through Git cherry picking. Git cherry picking is the act of picking a commit from a branch, applying it to another. Git cherry pick can be useful for undoing changes. For example, say a commit is accidentally made to the wrong branch. So what you can do, you can switch to the correct branch and cherry pick the commit to where it should belong. More simply, it would be like a box of cherry in which you have to pick 5 best cherries out of it. So you start picking the best cherries, and if you want to run this cherry picking, you need to use the Git console. So using the git line command, you can initiate the cherry picking. So let's move on to our second scenario. So in the second scenario, a developer has created an ASP.NET Core application and now he wishes to automate the entire build and release process through Azure DevOps. Guide the developer with the entire end-to-end process and deploy the application on Azure Web App using IAC methodology. Okay, so guys, as you can see that we have multiple questions, and in this entire scenario which we are talking about, the first question is that there is a developer which is very much new to DevOps and he has reached out of the reaches of DevOps engineer, and now he asks how to automate the entire build and release process. And in the another scenario, we need to deploy this on the Azure web app using the IAC methodology. So the first step is to be taken by the developer to build the application locally. After that, we create a Azure Repos and push the source code in the remote repository along with the IAC configuration file. And lastly, we create a build pipeline, classic or YAML based, in which we can build the solution using MS Build or VS Build, run the code analysis through SonarQube, Veracode, etc., run code coverage, copy ARM or Terraform configuration files, also publish the artifact either on FillerShare or Azure Pipeline drop location. So this was the answer to the scenario. Moving ahead with the next scenario, here the developer named Ram has few commits changes in his local branch and now he has to empty the current work directory to accommodate emergency change. So how can Ram handle such scenario without losing his uncommit changes? So to achieve this, we use git stash. What is git stash? Git stash is a command that takes your uncommitted changes, that is both staged and upstaged, and save them away for later use, and then reverts them from your working copy. So there are commands like git stash, which stashes the uncommit changes, and next is git stash list. So you can list all the stashed changes. Then there are other commands like git stash pop to reapply the most recent stat changes, and git stash drop to drop the most recent stat changes. So this is how he can overcome the scenario without losing any of his uncommit changes. Let's quickly look on to our next scenario. That is, a developer has developed a microservice application, that is ASP.NET Core, and it automates the entire end-to-end process to deploy the application on Azure Kubernetes service. Make sure to use pipeline as a code methodology for the entire build and release. So for this, the first step to be taken is by the developer to build the application locally. Then he needs to create an Azure Repos and push the source code in a remote repository along with the IAC configuration file. Then again, he needs to create a build pipeline, classic or YAML based, as we had discussed in the previous scenarios. Then after that, he needs to use an ARM template or a Terraform configuration to create an Azure web app. Later, he can create a release pipeline and run the ARM template task. And post web app creation, he can run ASP.NET application deployment task. So this was the answer to this scenario. So let's check on to our last scenario, that is a developer has developed an application module and while developing he made around 100 commits locally. Now he needs to push all his changes into a remote developed branch as a single commit. We don't want the developer's messy history in the developed branch. So the answer to this question is git squash. So what is git squash? Git squash is a technique that helps you take a series of commits and condense it to the few commits. That means you can condense it to one single commit, and those 100 commits will be condensed and converted into one single commit. So you can use the git command line, that is git rebase hyphen I head 3, where I represents interactive. So it is interactive head. And 3 means it will take the last 3 commits you want to try on your console or git command line. So this was the answer to the scenario. I hope this will help you out to crack your interviews.
And with this, we have come to an end to this full course on Azure DevOps. If you enjoyed listening to this full course, please be kind enough to like it, and you can comment on any of your doubts and queries. We will reply to them at the earliest. And do look up for more videos and playlists, and subscribe to Edureka's YouTube channel to learn more. Thank you for watching and happy learning.